All right, let's take a look at our practice test. So we're told to simplify each. And for the first problem, we have the square root of negative 50. So how can we simplify this? Well, we know how to simplify the square root of 50 already. But if we have the square root of a negative number like negative 50, then what we want to do is involve the imaginary unit I. So recall that I, again, the imaginary unit, is equal to the square root of negative 1. So what I'm going to do here is just use my product rule for radicals and just break this up. So I'll say this is the square root of negative 1 times, when I think about 50, I'm going to break this up into 25 times 2 because 25 is a perfect square. So I'll say the square root of 25 and then times the square root of 2. So notice that I haven't done anything illegal because if you multiply negative 1 times 25 times 2, you're going to get back to negative 50, right? So you have the square root of negative 50 again. So now what I'm going to do is just replace some things that I can. So let's put equals here. Again, the square root of negative 1 is going to be I. So let me start with that. The square root of 25 is 5, so let me write 5i. And then we just have the square root of 2, which I really can't do anything with. So if you're asked to simplify something like this, the answer would be 5i times the square root of 2. All right, let's take a look at problem number 2 now. So we're going to have the square root of negative 304. So the idea here is the same. You don't need to take the time to write the square root of negative 1 times the square root of 304. If you see the negative here, just replace it with I. So I'm just going to put this as I out in front. And then times, I'm going to break up the square root of 304. If you think about 304, it would factor into 16, which is a perfect square, times 19. So I'm going to say this is times the square root of 16, then times the square root of 19. And we know the square root of 16 is just 4. So I'm going to finish this up by saying this is 4i, then times the square root of 19. All right, let's take a look at problem number 3 now. So we have the square root of negative 5 times the square root of negative 5. So this type of problem throws off a lot of students. You're used to using the product rule for radicals, and you would say something like, okay, this is the square root of negative 5 times negative 5, so the square root of 25, which gives you 5. But that answer is actually wrong. And we talked about why it's wrong in the lesson. Essentially, what you need to do is actually take the time to simplify each guy here first, and then do your multiplication. The product rule for radicals in this situation is not valid because both numbers here are negative. So what I'd want to do here is say that this is I times the square root of 5, and then times this is also I times the square root of 5. And so we know I times I is going to be I squared. So let's put that. Square root of 5 times square root of 5 is 5, so times 5. And we know by definition that I squared is equal to negative 1. So what we're going to do here is say that this is basically 5 times negative 1, which is negative 5. Again, if you do it the way that you're expecting without simplifying first, well, then what happens is you get positive 5 and the sign is wrong. So if you get a multiplication problem like this, always take the time to simplify each guy first, then do your multiplication so you can make sure you get the right answer. All right, let's take a look at problem number 4 now. So what we're looking at is the square root of negative 2 times the square root of negative 8 times the square root of negative 6. All right, so the idea here is the same as from the last problem. What I'm going to do is actually simplify each one of these first, and then I'm going to do the multiplication. So for the square root of negative 2, I'll write I times the square root of 2. Then let's put times. For the square root of negative 8, I'm going to put I times. Let's break 8 up into 4 times 2, since 4 is a perfect square. So I'll say times the square root of 4, then times the square root of 2. Then times, for the square root of negative 6, let's put I first. Now 6 is 3 times 2. It's not going to do you any good here, but let's just go ahead and break it up. I'm going to put the square root of 3 and then times the square root of 2. You'll see that'll be a waste of time in a moment. But basically, we don't know until we try. So let's come down here and let's think about what we have. So I have I times I times I. Let's just write that as I cubed, and we'll simplify that in a moment. We have square root of 2 times square root of 2, so we know that's going to be 2. So let's put times 2. Then we have the square root of 4, which is 2, so let's put times 2. And then we have the square root of 3 times square root of 2, and in this case, we can't do anything with it, so I'm just going to combine that back and say this is the square root of 6. Okay, so at this point, I would just say that you have 2 times 2 or 4 times I cubed, so 4 times I cubed, and then times the square root of 6. Now, how can we simplify something like I cubed? So I cubed is equal to what? It's I squared times I to the first power. We know by definition that I squared is negative 1. So we can just replace this with negative 1. So I can say this is the negative of I to the first power, or just negative I. And so wherever I see I cubed, I'm allowed to legally replace it with negative I. So what that means is that in this case, let's go ahead and put equals here. Instead of a positive 4, I'm just going to put the negative out front. So I'll say it's negative 4, and then times I, and then times the square root of 6. So in other words, the I cubed got replaced with negative I. Okay, so negative 4I times the square root of 6 would be our solution. All right, let's take a look at problem number 5 now. So we have the square root of negative 55 times the square root of negative 11. And the idea here is the same. We want to simplify each guy here first before we do our multiplication. So this square root of negative 55 would be I times the square root of 55. I'm going to break 55 up into 5 times 11. So let's say this is the square root of 5, then times the square root of 11. Then times, for this guy, the square root of negative 11, it's just I times the square root of 11. So from here I have I times I, which is I squared. And as you work more problems, you're just going to put negative 1 when you get that. But I'm just going to, for completeness, put I squared here, just so nobody's lost. And then you have the square root of 11 times the square root of 11, which is 11. So let me put that out in front. And then you have the square root of 5, which you can't really do anything with. So I'm just going to put it at the end. So times the square root of 5. Okay, so we know that I squared is negative 1. So to finish this problem up, I'm just going to replace I squared with a negative and just put that out in front. So negative 11 times the square root of 5 would be my answer. Okay, let's look at problem number 6. So we have the square root of negative 3 times the square root of 21. So let's just write this as I times the square root of 3 times the square root of 3 times the square root of 7. So we know that square root of 3 times square root of 3 is 3. So I can just write 3i times the square root of 7 for my answer. All right, let's look at problem number 7. So we have the square root of negative 20 times the square root of negative 2 times the square root of negative 5. So I'm just going to set this up and say this is I times the square root of 4 times the square root of 5 times I times the square root of 2 times we'll have I times the square root of 5. Okay, so what can we do here? We have I times I times I, that's I cubed. So again, we know that's negative I, but let's just write it out. Let's put I cubed here. And then we have square root of 4, which is 2. We have square root of 2, can't do anything with that. Square root of 5 times square root of 5 is going to be 5, so times 5. And then we'll put times square root of 2. Then from here, let's say that I cubed is negative I, so negative I. And then 2 times 5 is 10. So let's actually erase this and put this as negative 10i like this. And then we would have times the square root of 2. So negative 10i times the square root of 2 would be our answer. Okay, let's look at problem number 8. So we have 3 times the square root of negative 50 over square root of negative 5. All right, so I'm just going to break this up. I think it's easiest to just say this is 3 times I times the square root of 5 times the square root of 10 over I times the square root of 5. So notice that I over I is 1. So you can still cancel in that way. And then square root of 5 over square root of 5 is 1. So really all I'm going to be left with here is 3 times the square root of 10. All right, let's look at problem number 9. So we have negative 5 times the square root of negative 40 over the square root of 8. So we'll say this equals negative 5 times, I'm going to say this is I times the square root of 8 times the square root of 5 over the square root of 8. So we are going to cancel this with this. Square root of 8 over square root of 8 is 1. So what I'll be left with is negative 5i, so negative 5i, and then times the square root of 5. All right, let's look at problem number 10. So we have negative 2 times the square root of negative 20 over the square root of negative 10 times the square root of negative 15. Okay, so let's say this is negative 2 times, I'm going to pull this out, so I'll say this is I, and then what I actually want to do is cancel this with the denominator, so I'm going to write this as the square root of 10, and then times the square root of 2, and then times I times the square root of 15. Okay, so that's taken care of with the numerator. In the denominator, I'm just going to say that I have I times the square root of 10, and so I'm going to cancel this with this, and this with this. And so really what I'm going to be left with, if you think about 15, it's 5 times 3, and then 2 is just 2, it's just prime. So what I'd have is negative 2i times the square root of 30. So let's put equals here, and we'll write negative 2i times the square root of 30 as our answer. All right, let's take a look at our practice test. We're told to simplify each. So for problem number 1, we have this quantity 3 minus 4i. Then we're subtracting away this quantity negative 4 minus 3i. Then we have plus 4. So the first thing I'm going to do here is just get rid of the parentheses in each case. So for this first set here, I can just drop them. I have 3 minus 4i. Then for this second set here, because I'm subtracting this away, I need to change the sign of each term inside of the parentheses. Again, a lot of times we'll just put plus negative 1 here and then distribute the negative 1 to each term. It's up to you if you need that. But basically, when I drop the parentheses here, I would change the sign so negative 4 would become positive 4, and then negative 3i would become positive 3i. Then I just have this plus 4 here. All right, so from here, I'm going to combine what I can. So that means I'm going to take the real parts, so the 3, the 4, and the 4, add those together. Let's just put those in parentheses for right now so it's crystal clear. So I'm going to do 3 plus 4, and then plus 4 like this, and then plus. I'm going to work with the imaginary parts. So we have negative 4i and 3i. So let's put those in parentheses. So negative 4i plus 3i like this. And of course, you don't need all these steps, but just to make things crystal clear, we're taking them. And so inside the parentheses here, 3 plus 4 plus 4, 3 plus 4 is 7, 7 plus 4 is 11. So let's write that this is 11, and then plus. Here you have negative 4i plus 3i. That's just going to be negative 1i, or you could put negative I. Now you can put plus negative I, or it's probably better to just write minus I like this. So 11 minus I would be our answer. And remember, this is in standard form because it matches that format of A. Again, this is the real part, plus b. In this case, the b would be negative 1 times I. Okay, so this is your real part, and then this is your imaginary part. So you want to write this in the format of a plus bi. So we get 11 minus, you could put 1i or 11 minus I. Okay, let's look at problem number 2, and we'll go a little bit quicker on this one. So we have the quantity 6 plus 2i plus 3 plus the quantity 2 plus 6i. So we can basically drop the parentheses because we have addition signs everywhere. And what I'm going to do here is just write 6 plus 2i plus 3 plus 2 plus 6i. And again, you can take the time to reorder things, or you can just add it mentally. It's really up to you. I think we can just add it mentally. So we're going to have 6 plus 3 plus 2. So 6 plus 3 is going to give us 9. 9 plus 2 is going to give us 11. So let's write 11 here. And then let's change up the color here. I'll put plus. Now you have 2i here and 6i. So 2i plus 6i would give me 8i. So this is 11 plus 8i here is my answer. Again, this is in standard form. The a is 11 plus the b, which is 8, times your I. So 11 plus 8i is your answer in standard form. Okay, let's look at problem number 3 now. So we have this negative 8i minus the quantity 2 plus 6i, then plus the quantity 5 plus 7i. So again, the idea is that if you have a negative or a minus out in front of some parentheses, you need to change the sign of each term when you're dropping the parentheses. So let me put this plus negative 1 here, and then just distribute this as a reminder. So this first guy will just write negative 8i. And then again, I'm going to change the sign of each one of these. So minus 2, and then minus 6i. And then I can just drop the parentheses here because I have a plus sign. So it's plus 5 and then plus 7i. Okay, so from here, again, you're just going to combine what you can. You have the negative 2 and you have the positive 5. So negative 2 plus 5 would be positive 3. So let's write that first. And then for this guy right here, you have this negative 8i. And then you have this negative 6i. And then you have positive 7i. So negative 8i minus 6i would be negative 14i. And then plus 7i would be negative 7i. So let's write minus 7i like this. And again, this is in the format of a plus bi. So a is 3, and then b is going to be negative 7, and then you have your I. So 3 minus 7i is the answer in standard form. All right, let's look at problem number 4 now. So we have a basic multiplication problem. So we're going to have negative 4i times negative 7i times 8i. All right, so the idea here is we're going to multiply the numbers together first. Negative 4 times negative 7 is positive 28, and then positive 28 times 8 is positive 224. So this is 224. Then you're going to have I times I, which is I squared, then times I again, which is I cubed. But we're going to talk about how to simplify these powers of I in the next section. For right now, what I would do is just say this is I squared times I, because we know by definition that I squared is negative 1. So you can just replace this with a negative 1 here. And of course, the way to write this is to just say that this is negative 224i. Now, in standard form, if you were required to do this for your textbook, you may have to give an answer of 0. That's your a, or your real part. And then minus your 224. So the negative 224, that's your b. And then times your I. Okay, so your real part plus your imaginary part. And so you could give this as the answer, 0 minus 224i, or a lot of people would just take this one, so negative 224i as your answer. All right, let's look at problem number 5. So here we have negative 6i times the quantity negative 1 minus 6i. So I'm just going to use my distributive property and multiply the negative 6i by each term inside the parentheses here. So negative 6i times negative 1 would be positive 6i. And then negative 6i times negative 6i again would be negative times negative is positive. 6 times 6 is 36. And then I times I is going to be I squared. Now we have more simplifying to do here because we know I squared by definition is -1. So let's write 6i, and then we'll put plus -1 times your 36 there. So we know that this is just going to be 6i and then minus 36. But again, this is not in standard form. You want the a plus the bi. So you'd want to take the time to rearrange this and put the real part first. So let's put -36 out in front. And then we want to put plus the imaginary part. So plus, let's put this 6i here. So you have your a plus bi. So this guy's in standard form. So -36 plus 6i. Okay, let's look at problem number 6. So we have the quantity -2 minus 5i times the quantity -2 plus 8i. So what I'm going to do here is just use FOIL. So I'm going to go first terms, -2 times -2 is +4. Then I'm going to do my outer terms, -2 times 8i. Well, -2 times 8 is -16, so let's put -16 and then times I. Then the inside terms, -5i times -2. We know that's going to be positive. 5 times 2 is 10, and then times I. And then for the last terms, you have -5i times positive 8i. So we know that's negative. 5 times 8 is going to be 40, and we know that I times I is I squared. Now again, whenever you see I squared, you're supposed to replace that with -1. So let's say that this is 4, and then -16i plus 10i would be minus 6i, and then -40 times -1 is going to be positive 40. So let's just put plus 40 here, and this equals, so 4 plus 40 is 44. So again, we want to write that real part first. Let's put this out in front. So this is 44, that's your A, and then you'll have minus 6i. So -6 is your B. So A, 44, then minus 6, that's your B, and then times I. So 44 minus 6i is your answer. All right, let's look at problem number 7. So we have 7i times the quantity -4 plus 7i times the quantity 7 minus 2i. All right, so let's start by distributing this guy into each term here, and then we'll do FOIL. Okay, so 7i times -4 would be -28i, and then 7i times 7i would be plus 49i squared. Again, whenever you see I squared, you can replace this with -1. So this is just going to change the sign here. All right, so let's wrap this in parentheses, and we're going to multiply by this 7 minus 2i now. And let's come down here and see what we got. So -28i times 7, those are the first terms. And so -28 times 7, that's going to be -196, and then times I. Then for your outer, -28i times -2i, that's going to be plus 28 times 2 is 56, and then I times I is I squared. Then for my inside, -49 times 7 would be -343. Let's slide this down a little bit. Then for my last terms here, I have -49 times -2i. So negative times negative is positive. 49 times 2 is 98, and then times I. Okay, so from here, you can replace I squared again with -1. So let's just say that we have -196i. And then instead of 56i squared, I'll just put minus 56, because again, this is -1. And then minus 343, and then plus 98i. Let me put my equal sign here. Forgot to do that. So let's come down here. And let's go with our real part first. So -56 minus 343. This is going to give me -399. And then if I go with -196i plus 98i, that's going to give me -98i. So I end up with -399 minus 98i. So again, this is in standard form. This is your A, your -399, and then your B is going to be -98. So -399 minus 98i is your answer in standard form. All right, for problem number 8, we have -2 over 8i. So what I'm going to do here is first, let's just rewrite this. So -2 over 8i. I know that the 2 is divisible by 2 and the 8 is divisible by 2. So let's start with that. So 2 divided by 2 is 1. 8 divided by 2 is going to be 4. Now, we can't have I in the denominator, at least not if we're reporting a simplified answer. And the reason is that, again, you don't want a radical in the denominator, and I, by definition, is the square root of -1. So it's just like if I had said that this is the negative of 1 over 4 times the square root of -1. We want to get rid of this. So the way we're going to do that, let me just actually erase all this. The way we're going to get rid of this, let's put -1 over 4i like this. I'm just going to multiply by I over I. And in the numerator, let's just say this is the negative of I over. In the denominator, it's 4 times I times I. So I times I is I squared. So really, you could just say that this is -4 down here. And so negative over negative would be positive. So in the end, we'll just say that this is I over 4. 4. So this would be our answer. And again, if your teacher requires you to always write things where you have an a part, you could also say that this is 0 plus your 1/4 times I. So this is your a plus your bi. So you may be required to do this. It's just up to your teacher. Most people would just accept I over 4 as a solution. All right, let's look at problem number 9 now. So we have 3 over 2 plus 4i. And recall, if we have a two-term denominator like this and we have a radical involved, when we want to simplify, we can multiply the numerator and denominator by the conjugate. So I'm going to say this is times 2 minus 4i and then over 2 minus 4i. So the terms are the same. You have a 2 and a 2 and then a 4i and a 4i, but it's just that the signs are different. So you have a plus and then a minus. So this is going to work a little bit differently when we have this I involved because it's going to change the sign from what we're used to. In other words, if you have a plus b, this quantity, times the quantity a minus b, this gives me a squared minus b squared. We already know this. The middle two terms drop out. But if you throw an I in here, so let's say we put an I there and an I there, what's going to happen is you're going to have a squared minus b squared times I squared, and the I squared is -1, so it flips the sign, and so this becomes a squared plus b squared. So you want to make sure you have the different formula in mind when you do this. Okay, so I'm going to do 3 times 2, that's going to give me 6, and then minus 3 times 4i, that's going to be 12i. This is over. You have, again, just square 2, that's 4. And then plus now, you're going to take 4 and square it, that's 16. So 4 plus 16 would give you 20. And again, if you want to do that the long way, you can. 2 times 2 is going to give you 4. The outer is -8i, the inner is plus 8i, those would cancel. And then the last, 4i times -4i, let's put minus 16i squared. Again, the I squared is -1, so it's going to flip this sign to a plus, and 4 plus 16 is going to give you the 20. Okay. Now, looking at this the way it is, you could factor out a 2 and cancel. So you could say that this is 2 times the quantity 3 minus 6i, and this would be over, let's say 2 times 10. And let's cancel this 2 with this 2. So some people would report their answer as 3 minus 6i over 10. But again, it's really up to your teacher. They may want it written in standard form. So in this case, what you would want to do is break this up and say this is 3 over 10. So that's your a, or your real part. And then you could say minus, you're going to have this 6 over 10 times I. So the 6 over 10, which can be reduced, this would really be 3/5. Okay, so a plus your bi. So 3 over 10 minus 3/5 times I. All right, let's look at problem number 10. So we have -4 minus 8i over 6 plus 4i. So again, I'm going to multiply the numerator and denominator by the complex conjugate. So that's 6 minus 4i over 6 minus 4i. So let's wrap this and wrap this and wrap this and wrap this. And it's a little bit more work because we have 2 terms here and 2 terms here. But let's just use FOIL. So -4 times 6 would be -24. Let's write that there. Let me slide down here a little bit. Have a little room. And then my outer, -4 times -4i, would be plus 16i. My inner, -8i times 6 would be -48i. Then my last, negative times negative is positive. 8 times 4 is 32. And then I times I is I squared. Now again, you could just flip the sign with I squared. So I could just write this as a -32. And then -24 minus 32, we know that would be -56. So let's keep that out in front. Let's just erase this and put -56 out in front. And then 16i minus 48i, that's going to give me -32i. So let's write minus 32i like this. Okay, so the numerator is done. Let's work on the denominator. Again, we could just use our formula. I'm going to square 6. That's going to give me 36. And then plus, I'm going to square 4. That's going to give me 16. So 36 plus 16 is going to give me 52. Now from here, everything is divisible by 4. So let's factor a 4 out. And so this would give me -14 and then minus 8i. And this is over. Let's write this as 4 times 13. So let's cancel this common factor of 4. And let's come down here and say that this is going to be -14 minus 8i over 13. Again, some people will let you write your answer like that. If you want it in standard form, you're going to break this up and say this is -14 over 13. So that's your A. And then plus your B. Your B here is going to be -8 over 13. And then times your I. So this is your A plus BI. So this is in standard form. So -14 over 13 minus 8 over 13 I. All right, let's take a look at our practice test. We're told to simplify each. And for the first problem, we have I raised to the power of 30. So recall, when we're simplifying powers of I, we refer to a little pattern. So let's just, for completeness, put I to the power of 0. We're not going to use it today, but essentially I like to write it for a sense of completeness. So any non-zero number raised to the power of 0 is 1. We have that. Then we have I to the first power. That's just I. We have I squared. By definition, this is -1. And then we have I cubed. So we're basically going to simplify I cubed using our rules of exponents. So with your product rule for exponents, let's say you could break this up into I squared times I to the first power. Again, going in reverse, if you're multiplying, I would stay the same. You would add your exponents. 2 plus 1 would give me back to 3. And then we can do a little substitution here. We know that I squared is equal to -1. So basically, where this I squared is here, I'm just going to put a -1 in its place. So this is -1 times I to the first power. So we just write this as -I. So that's -I. Then I to the fourth power, we're going to do something similar. We're going to say this is I squared times I squared. Remember, from your product rule for exponents, I stays the same. 2 plus 2 would get me back to 4. And then we know that I squared is equal to -1. So I have I squared here, and I have I squared here. So I'm just going to have -1 times -1, which is +1. So the idea here is that if you have something in this range, you can just replace it. So if you're given on a test something like I squared, you know it's -1. If you're given I cubed, you know it's -I. If you're given I to the fourth power, it's just 1. If you're given something that has an exponent that's larger than 4, what you want to do is you want to find the next whole number going down that's divisible by 4. Now, why would you do that? Let's think about it with this problem. If you have something like I to the power of 30, well, think about 30. Is it divisible by 4? Again, you could just punch it into your calculator if you don't know. The answer is it's not. So then you would start going down. So you go to 29. That's an odd number, so it's not divisible by 4. Then you would go to 28. Well, 28 divided by 4 is 7. Okay? So I'm going to think about 28 first. So let's put equals. And again, I'm going to use my product rule for exponents to break this up. I'm going to say this is I to the power of 28 and then times I squared. Okay, so 28 plus 2 would get me back to 30. So again, just using the product rule for exponents, nothing is illegal there. Now, the reason I want to break it up in this manner, since 28 is divisible by 4, I know that I raised to the power of 28 would be 1. Now, how do I know that? Well, basically, I can break this up using my power to power rule. So I can say this is I to the power of 4 and then raised to the power of 7. Remember, with this rule, I would stay the same and you would multiply exponents. 4 times 7 would get me back to 28. So nothing is illegal there. And then times your I squared. So once we have it in this format, you can basically say that this part right here is 1. And why can you say that? Well, I to the fourth power, if I go over here, this is 1. So I can just substitute a 1 in there. So say this is 1 to the 7th power times I squared. We know 1 raised to any power is always 1. So this is going to be 1 times I squared, which is just I squared. And again, I squared is -1. So basically in the end, this simplifies to just -1. So something like I to the power of 30 is going to be simplified as -1. Okay, let's look at another one. For problem number 2, we have I to the power of 52. Now again, just ask yourself the question, is 52 divisible by 4? The answer is yes. 52 divided by 4 is 13. So if you're going quickly, you can immediately just say that this is equal to +1. You don't need to do anything else. But for the long version, what you would do is say, okay, well, 52 is divisible by 4. So that means using my power to power rule, I can rewrite this and say this is I to the fourth power and then raised to the 13th power. And again, I to the fourth power by definition is 1. So we can say that this is 1 to the 13th power, which is 1. So again, if this exponent is divisible by 4, you're always going to be able to match this pattern here. And so you're going to end up with 1 as your answer. Okay, let's look at problem number 3. So we have I to the power of 27. So is 27 divisible by 4? No, it's an odd number. Is 26? No. Is 25? No, but 24 is. It's 24 divided by 4 gives you 6. So I'm going to break this up and I'm going to put I to the power of 24 and then times I cubed. Now I'm going to go a little bit slower here. At this point, if you're more advanced, you know that this part right here, because 24 is divisible by 4, that's going to be 1. And so you're just simplifying I cubed, and you know that's -I. So again, if you want to do this more quickly, you can. I'm just trying to explain it more thoroughly in case you're still lost. So this right here, again, you could break this up into I to the power of 4 and then raise to the power of 6. I stays the same. 4 times 6 is 24. And then times I cubed. So again, we know that this is 1 to the 6th power. And then times I cubed. And then this is just going to be 1, and then times I cubed. And again, we know from the definitions from earlier that I cubed is -I. So I can just say this is -I, and that's my answer. Okay, let's look at problem number 4. So here we have I raised to the power of 201. So 201 is an odd number. It's not going to be divisible by 4, but 200 would be. So I would start by saying this is I to the power of 200, and then times I to the first power. You could just write I. And so with this guy, again, I know that this is going to end up giving me 1. Maybe we'll do it the long way one more time. So let me actually erase this just so nobody's lost. This would be I raised to the power of 4. And then 200 divided by 4 would be 50. So it would be I raised to the power of 4 raised to the power of 50. And then times I like this. And of course, this would end up being 1 to the power of 50. And then times I. And this just ends up being 1 times I, or just I. Okay, so that's all it is. Okay, let's look at problem number 5. So we have I to the power of 309. Again, 309 is an odd number. It's not going to be divisible by 4. But 308 would be, right? The final 2 digits of that number is going to be 8. And so that's divisible by 4, so the number will be. And so what we'll do here is just say this is I raised to the power of 308, and then times I. And again, you can go through and break this up if you want. At this point, I think you pretty much get it. So I'm just going to say that this is going to be 1, and 1 times I would just give me I. All right, let's take a look at problem number 6 now. So we have I raised to the power of negative 58. So I'm going to show you 2 ways to do this. One is the slower way, the way that they generally show you in a textbook, and then I'll give you a little shortcut. So the first thing is, using your rule for negative exponents, you can legally write this as 1 over, you have I to the power of 58. So everyone knows at this point, if you drag this across the fraction bar, the sign of the exponent changes. Okay, from here, you would think about 58. We know that it's not divisible by 4, but we would say going down 57 isn't, but 56 is, right? 56 divided by 4 is 14. So just to make this a little bit more clear, I'll go the long way. We'll say this is 1 over. I'll say I to the power of 56 times I squared. So again, 56 plus 2 will get me back to 58. So nothing is illegal at this point. So then from here, I know that 56 divided by 4 is 14. So I can say this is 1 over. We'll go I to the 4th power, raised to the 14th power, then times I squared. Let's put equals here. And again, I to the 4th power is 1. So you would have 1 to the 14th power, which is still 1. So let's put 1 over. I'm just going to put 1 and then times I squared. And we know I squared by definition is negative 1. So let's finish this up by saying this is 1 over negative 1, which is just negative 1. So the answer here is that it's negative 1, but it took us a long time to figure this out. I mean, obviously you could have skipped some steps here, because once you realize that I to the 56th power is 1, then you could just say, okay, well, this is negative 1 here and you'd be done. But there's actually an easier way. So let's erase this and let's think about something. We know that I to the 4th power, or I raised to some exponent that's divisible by 4, that's going to give you a result of 1. Okay, so I to the 4th power, I to the 8th power, I to the 12th power, so on and so forth. Now, what I would want to do is think about the minimum number that would be required to take this guy right here, this exponent that's on I, and put it into the range of I to the 1st power, 2nd power, 3rd power, or 4th power. But it's got to be an exponent that's divisible by 4, because again, that's going to give you 1, and if you multiply by 1, you're not changing anything. So thinking about this, I can't just multiply by, a lot of students will just say, okay, well, I'm going to multiply by I to the power of 59. Well, that doesn't work, because 59 is not divisible by 4. You need to multiply by a form of 1, okay? So you would want to go to I to the power of 60. The reason you could do this is because this is I to the 4th power raised to the 15th power. So we already know from many examples now that this is really 1. And again, if you multiply something by 1, it's unchanged. If I said I to the power of negative 58 times 1, this is I to the power of negative 58. Nothing has changed. I'm just multiplying it here by a more complicated form of 1. So again, nothing's going to change in terms of the value. It's going to change the way it looks, but it's still going to have the same value. So I'm going to erase this, and I'm just going to say this is I raised to the power of negative 58 plus 60, okay, which is I squared, which is negative 1. So I think this is a little bit faster. Some people get lost when they do this. Remember, when you're multiplying here, this exponent on I has to be something that's divisible by 4 so that you have a form of 1. You can't just multiply by any I that you want. Okay, that's not going to work. It has to be a form of 1 like we did here. All right, let's look at the next one. So for problem 7, we have I raised to the power of negative 222. So again, if I think about this, 222, forget about the fact that it's negative, is not going to be divisible by 4. So what I want to think about, again, I'm just going to use my same trick. So I'm going to say this is times I raised to what power do I need here? Again, I want to put this into the range of I, or I squared, or I cubed, or I to the 4th power. So thinking about this, I would want 222, and I would want to start going up. So is 223 divisible by 4? No. Is 224? Yes. So I'm just going to put 224 here. again, this is divisible by 4. So I know that this is 1. Again, it's a complex form of 1. So when we multiply, you get I raised to the power of negative 222 plus 224, which is 2. And this is just I squared, so it's negative 1. Again, if this is confusing for you, you can always do it the other way. So you could say this is I raised to the power of negative 222, which is 1 over I raised to the power of 222. And again, you're just going to break this up and say this is 1 over I raised to the power of 220. Again, 220 would be divisible by 4. So that's just going to be 1, and then times I squared. So again, this would just be 1 here. So in the end, you have 1 over I squared. I squared is negative 1. So 1 over negative 1, which is negative 1. So again, this is a little bit quicker if you can use this, but it might be confusing for you. So you might want to just stick to this longer method if that's what works for you. Okay, let's look at problem number 8. So now we have the negative of I raised to the power of negative 101. So first and foremost, is 101, again, forget about the fact it's negative, is that divisible by 4? No, it's an odd number. So going up is 102. No, it wouldn't be. 103 wouldn't. You'd have to go to 104. So what I'd want to do here is multiply by I raised to the power of 104. Again, 104 is divisible by 4. So again, this is just like I'm multiplying by 1. That's all I'm doing. So if I look at this, I would have the negative out in front, and then essentially I would have I, that stays the same. We have 104 minus 101, which is cubed. And we could say that this is basically negative 1 times, remember, I cubed is negative I. So times negative 1 times I. So this just ends up simplifying and giving me I. Okay, so that's one way to do it. That's the quicker way. If you wanted to do this the long way, I think we should probably show it the long way because people probably tried it that way and got confused. Let's start by just saying we have negative I raised to the power of negative 101. Okay, so I'm going to first say this is negative 1 times, I'm going to say 1 over, let's go ahead and say I raised to the power of 101. And again, you could break this up. Let's say it's negative 1 times 1 over. We'll have this 101 down here. Let's break this up into I to the power of 100 times I. And then again, I to the power of 100 would be 1, right? Because 100 is divisible by 4. So we'll say this is equal to, let me slide down here. We'll say that this is negative 1 times 1 over, again, I to the power of 100 is 1, so your I there. Okay, so a lot of people write their answer as negative 1 over I like this. But the reason you can't leave your answer like this is because you have a radical in the denominator. Remember, I by definition is the square root of negative 1. So it's like I put negative 1 over the square root of negative 1. So we have to take the additional step to simplify that. So what you would do here is you would multiply by I over I. And so what this will give you is negative I over I times I is I squared. And I squared by definition is negative 1. So you have negative I over negative 1, which gives you I. Okay, so either way you want to do it, you're going to get I as your answer. But I wanted to make sure I did it this way because I know a lot of people answered this and got the negative 1 over I. And so I wanted to make sure you understand where this is coming from. It's basically coming from us rationalizing the denominator. Again, if you do this with the quicker method, then you're not going to have to worry about that at all. Okay, let's look at problem number 9. So we have negative I raised to the power of negative 229. And so again, I'm just going to do this the quicker way. So we have negative I, and then basically raised to the power of negative 229. So 232 would be divisible by 4. So let's multiply this by I raised to the power of 232. And so this would be negative I raised to the power of 232 minus 229 would be 3. So this would be negative I cubed like this. And so again, we know I cubed by definition is negative I. So you basically have negative 1 times I, which is just I. And again, if you want to do this the long way, and I know this is going to get cut off, but let's put negative I. I'll just put a border here. Raised to the power of negative 229. So this is negative 1 times, we'll say 1 over I raised to the power of 229. And 228 would be divisible by 4. So let's start with that. So we'll say this is negative, I'll put the negative 1 up here. I think it's a little bit faster. Over, we'll put I to the power of 228 times I. And so again, what you're going to end up with is this guy right here is going to be 1. So you have negative 1 over I. And again, you're back to that same problem. You've got to rationalize. So I'm going to multiply this by I over I. And this gives me negative I over I squared. And again, I squared is negative 1. So this is negative I over negative 1, which gives me I. Okay, so either way you get I. But again, the first method that I showed you is a little bit quicker. Let's look at problem number 10. So now we have 1 over negative I raised to the power of negative 79. So I'm just going to start by just moving that out of the way. I'm just going to put negative 1 out in front so I don't have to deal with it. And then there's 1 over, you have I raised to the power of negative 79. I'm just going to use my rules of exponents to move this up. So really, I'm just going to have negative 1 times I raised to the 79th power. Again, this I would come into the numerator, and then the exponent would change the sign. So from negative to positive, you could write this over 1 if it makes you feel more comfortable, but it's just not necessary. Okay, so from here, I'm basically just thinking about 79 is not divisible by 4. Well, I know that going down, 78 would not be. I would need to go all the way down to 76. So I can say that this is negative 1 times, we'll say I to the power of 76, times you're going to have I cubed, right? Because 76 plus 3 would get you back to 79. So this, again, is going to be positive 1. So basically what you have is negative 1 times I cubed is negative I. So negative 1 times negative 1 times I, which is just going to be I. So this answer here is just I. All right, let's take a look at our practice test. We're told to solve each equation. And for all the problems we're looking at today, they're quadratic equations that we're going to solve using factoring. So for the first problem, we have 75x squared plus 133x. Then we have minus 101, and this is set equal to 4 plus 5x squared. So if you want to solve a quadratic equation using factoring, the first thing you want to do is put the equation in standard form. So that looks like this. The ax squared plus your bx plus your c is set equal to 0. So what I can do is move these two terms over to the left-hand side. So I'm going to subtract 4 away from each side of the equation. And I'm going to subtract 5x squared away from each side of the equation. Let's put that over there. I'm going to show this is canceling and this is canceling. Now, when you do 4 minus 4 or 5x squared minus 5x squared, the result is 0. Typically, if something's left over here, we don't write 0 because you don't need it. But in this case, everything has canceled away, so you want to put a 0 there because we need this for this process. So this is equal to 0. We got to have that there. Okay, so continuing, on the left-hand side now, 75x squared minus 5x squared would give me 70x squared. Then we have plus 133x. Then we have negative 101 minus 4. So that's going to give me negative 105. Okay, so this is my setup for the left-hand side. Remember, the right-hand side is 0. So now once we have it into this form, what you want to do is factor the left-hand side into the product of two binomials. So looking at this, you always want to check to see, is there something I can pull out before I start factoring? Is there a GCF that's not 1? In this case, if you think about 70, let's just say it's 7 times 10. I know you could break it down further and say it's 7 times 2 times 5, but let's just say 7 times 10. For 133, you would check. We know it's not an even number, so it's not going to be divisible by 2. And we know it doesn't end with a 5 or a 0, so it's not divisible by 5. But I could check to see if it's divisible by 7, and it is, right? It's 7 times 19. Then for 105, forget about the fact that's negative. I know that this is 7 times 15. So I can pull a 7 out before I even start. Now, you can factor this out, or you can divide every term by 7. That's up to you. Let me go ahead and show this to you. So let's pull out the 7. And you would have a 10x squared, and then plus you would have a 19x, and then minus you would have a 15 here, and close that down, and that's set equal to 0. Now, what you can do legally is divide both sides of the equation by 7 if you want to get rid of this. So this would cancel, and 0 divided by 7 is 0. So essentially your equation becomes 10x squared plus 19x minus 15 equals 0. And I'm just going to factor this left-hand side into the product of two binomials. Now, when we think about this guy right here, this 10x squared, the 10 is not a prime number. So it could be that you have 5x and you have 2x, or it could be that you have 10x and you have x. Now, after having solved a lot of these problems on my own, I would say that this one down here, this second choice, is probably unlikely. So I would hold off on this one. And I'm just going to tell you in advance it's not going to work. But even if you were working this and you had no idea, I would always try this one first. Okay, so thinking about the fact that this is a negative here, we know we're going to be performing a subtraction. And just think about the factors of 15. You have 1 and 15, and we have 3 and 5. Now, we're going to be able to save a little bit of time here because you have a 5 here. So you can't put a 15 here because you'd have a common factor of 5 here. There's no common factor of 5 in this. So that is not a possibility. Now you could put a 15 here and a 1 here, but that's just going to be too big. Okay, so that's not going to work. You can just throw this away. So if this is going to work, it's going to need to work with 3 and 5. Now I can't put a 5 here because you have a common factor of 5. So I would have to put a 3 here and a 5 here. So does that work? Well, 5 times 5 is 25. So let's think about this being, let me just get rid of this real quick. This would be 25x, and then 3 times 2 is 6, so this would be 6x. Well, yeah, if I get the signs right, if I make this a plus and this a minus, then you would have positive 25x and you would have negative 6x. Those would combine to give you the plus 19x in the middle. So this is what I'm looking for. Okay, so once I have the correct factorization, it's really a piece of cake. All I'm going to do is take each factor with a variable, set it equal to 0, and solve. So in other words, I'm going to take this factor, which is 5x minus 3, set that equal to 0, and then I'm just going to say or, and then I'll take this factor over here, which is 2x plus 5, set that equal to 0. And so we're just going to solve these two resulting equations. So let's start over here on the left. I'm just going to add 3 to both sides. This would cancel. You'll have 5x is equal to 3. Divide both sides of the equation by 5. This cancels. You'll get x is equal to 3/5. For the other one, let's subtract 5 away from each side of the equation. That cancels. You're going to get 2x is equal to negative 5. Divide both sides of the equation by 2. And let's cancel this 2 away. Let's put or here. We'll say x is equal to negative 5/2. So x could be 3/5 or x could be negative 5/2. And you can always pause the video and go back and try it in the original equation. And you'll see that you get a true statement from either one of these. And again, that's how you know that your solutions are correct. All right, let's take a look at problem number 2 now. So we're going to see 107x squared minus 258x minus 56 is equal to 2x squared plus x. So again, the idea is to write it in the form of ax squared plus bx plus c equals 0. So I'm just going to subtract 2x squared away from each side of the equation. I'm going to subtract x away from each side of the equation. So let's cancel this away and cancel this away. And remember, we want to write a 0 here. 2x squared minus 2x squared is 0, and x minus x is 0. So you put a 0 there. And let's slide down a little bit and say that we would have 107x squared minus 2x squared. That's going to be 105x squared. Negative 258x minus x would be negative 259x. And then we have minus 56, and this equals 0. Now we should always check to make sure that our GCF is not 1. I would start by looking at this smaller number. Forget about the fact that it's negative. 56, let's just write that as 8 times 7. I know it's 2 cubed times 7, but let's just write it as 8 times 7. Now 259 is an odd number, and so is 105. So they're not going to be divisible by 8 or 2 or 4 or anything like that. But they could be divisible by 7. You just have to check with your calculator. If you punch up 259 divided by 7 into your calculator, you're going to get 37. So this would be 7 times 37. And we know 105 divided by 7 is 15. So let's write 7 times 15. So at this point, you could divide everything here by 7 without factoring anything out. So in other words, you could say this is 15x squared minus 37x, then minus 8 is equal to 0. Because again, 0 divided by 7 would still give you 0. You could do it that way. Because we're practicing some factoring, I'm just going to factor it out. So I'm going to say this is 7 times the quantity, 15x squared. And then I'll say minus, this would be 37x. And this will be minus, this will be 8. And then I'll say this equals 0. Again, you can divide both sides by 7 if you want. I'm just going to leave this here to show you what happens. So let's slide down here. And let's say that we're going to now factor what's inside the parentheses into the product of two binomials. So let me keep my 7 out here. And then I'm just going to expand this out into 2 sets of parentheses. And then for 15, it's not a prime number. So it could be 15 times 1 or it could be 5 times 3. When you get a situation, something like 15 times 1 or 10 times 1, it rarely works. So I would always start with something like 5x and then 3x. And if it doesn't work, then just try the other one. So for this one, you have a negative 8 as the final, right? So because this is negative, when I'm trying things out, I'm going to be doing a subtraction. And again, I always work with absolute values. So I'm going to think about, for 8, there's 1 and 8, and there's 2 and 4. So let's start with 1 and 8. If you were to put an 8 here and a 1 here, and it looks like that's going to work out for us, essentially you would want this to be a minus and this to be a plus. Because again, if you do the outer here, your 5x times negative 8 would be negative 40x. If you do your inner, 1 times 3x would be 3x. So negative 40x plus 3x is going to give you negative 37x. Now let's erase this. And now we're at the easy part. So we just need to set each factor with a variable equal to 0 and solve. So here's why it doesn't matter if you divide both sides of the equation by 7 or not. 7 does not have a variable involved. So I only have to work with this and this. those two are going to have variables involved. So you want to set those equal to 0 and solve. You can ignore the 7. It doesn't come up. So again, if you want to divide both sides by 7, that's up to you. If you don't, you just leave it out there. It doesn't matter. So we're going to have the 5x plus 1 equals 0. Then or you'll have the 3x minus 8 equals 0. And so from here, I'll subtract 1 away from each side of the equation. And let's cancel this away and say we have 5x is equal to negative 1. Let's divide both sides of the equation by 5. We'll cancel this away. We'll say x is equal to negative 1/5. Then over here, let's add 8 to both sides of the equation. Cancel that away. We'll say 3x is equal to 8. Divide both sides of the equation by 3. Cancel that away. And we'll say or x is equal to, this will be 8/3. So x could be negative 1/5 or x could be 8/3. All right, let's take a look at problem number 3 now. So we have 10x squared minus 66x plus 110, and this is equal to x squared plus 5. So once again, I'm just going to move these terms to the left. I'm going to subtract x squared away from each side of the equation. Let's cancel that. Let's subtract 5 away from each side of the equation. Let's cancel that. And remember, this is going to be a 0, so it's very important to put that. So 10x squared minus x squared would be 9x squared, and then minus 66x, and then plus 110 minus 5 is going to be 105, and this equals 0. Okay, so again, we're going to check to see, is there a greatest common factor other than 1, or something we could pull out from the left-hand side, or again, you could divide both sides by it. It's really up to you. And what I notice here is that everything is going to be divisible by 3. So 9 is divisible by 3, 66 is divisible by 3, and 105 is divisible by 3. So I'm just going to pull it out. Again, if you want to divide everything by 3, that's up to you. Let's pull out the 3, and we'll have 3x squared minus 22x, and then plus 105 divided by 3 is going to be 35. Okay, close that down and put that equal to 0. Okay, so let's write 3, and then I'm going to set up my parentheses here to factor. So we know that 3 is a prime number. So I can put 3x here and x here, and I don't need to worry about it like in the last two examples. For 35, it's either 1 times 35 or it's 5 times 7. Again, when you get into something like 1 times 35, it's unlikely to work. So I would start with 5 times 7 and see if that works. And basically, let's put a 7 here and a 5 here. This is a plus here, so I know I'm going to be adding. And again, this is in terms of absolute value. So if you just eyeball this, 3 times 7 is 21, and this would be 5. So 21 plus 5 is 26. We need to get to 22. Again, forget about the fact it's negative. I'm just working with absolute values. So this is not going to work. You would have to rearrange this and put a 7 here and a 5 here. Does that work? 3 times 5 is 15. 7 times 1 is 7. 15 plus 7 is 22. So it looks like that works. We've got to make the signs work. So this would be a negative, and this would be a negative, because again, negative times negative is positive, and negative plus negative is negative. So we're going to have this guy right here would be negative 15x, and this guy right here would be negative 7x. Negative 15x plus negative 7x will give you the negative 22x that you need. So now that this is done, we can get into the easier part, which is just to solve the equations. So again, you can ignore the 3 because it does not have a variable involved. So I'm just going to set 3x minus 7 equal to 0, then or x minus 5 equals 0. So let's add 7 to both sides of the equation, and let's cancel this away. We'll have 3x is equal to 7. Divide both sides of the equation by 3. And so what we'll end up with, this cancels. We'll say x is equal to 7/3. Then we're going to have the or there. Over here, I'm just going to add 5 to both sides of the equation. So let's cancel this away. We'll say that x is equal to 5. So x could be 7/3 or x could be 5. Okay, let's look at problem number 4 now. So we're going to have 67x squared minus 150x plus 67, and this is equal to negative 5 minus 8x squared. Let me add 8x squared to both sides of the equation to get things started. I'm going to cancel that away. Let's add 5 to both sides of the equation. Let's cancel that away. Let's put a 0 over here. And then what I'd have is 67 plus 8 is going to give me 75. So this would be 75x squared. And then we have minus 150x. And then plus 67 plus 5 is going to give me 72. And this equals 0. So again, is there something that I can pull out from here? Well, this number's odd, and this number's even, and this number's even. So it wouldn't be something like 2. So let's think about 72. 72 is 9 times 8. And again, you could further break it down if you wanted to, but I think this is the best way to do it. So for this one, I know it's not divisible by 9, but it is divisible by 3. It's 3 times 50. And for 75, it's 3 times 25. So it looks like I can pull a 3 out from everything. Let's write this as 3 squared times 8 like this. So what I'll do is I'll say this is going to be 3 out in front, and then 25x squared minus 50x, and then plus, I'm pulling 1 3 out, so 3 times 8 would be 24. Close that down and set that equals 0. Again, if you want to divide both sides by 3 and get rid of it, it's up to you. I'm just going to leave it there. Let's come down here, and I'll set up my parentheses so we can factor this guy. So now we have 25. Again, not a prime number, so it could be 25 times 1, which again is unlikely to work, or it could be 5 times 5. So let's put 5x here and 5x here. Now we have 24, and we have a plus here. So remember, if it's a plus, when you're going through, again, working in terms of absolute value, you're going to add things and see if you can get to, forget about the fact that it's negative, see if you can get to 50. So let's think about the factors of 24. You've got 1 and 24. That's unlikely to work. You've got 2 and 12. Let's stop and check that real quick. So 5 times 2 would be 10, and then 5 times 12 would be 60. So that's not going to work. You can get rid of these two. That's gone. So next you would have 3 and you would have 8. Would that work? Well, 5 times 3 is 15 and 5 times 8 is 40. So 15 plus 40 is 55, so that's too big. So next you would have 4 and 6. Would that work? 5 times 4 is 20. 5 times 6 is 30. 30 plus 20 is 50. So that's what we need. We need 4 and 6. So we're going to put a 4 here and a 6 here. And in each case, you're going to want a minus sign. And again, that's because you want the outer here to be negative 20x, and the inner here would be negative 30x. If you add those, negative 20x plus negative 30x, that gives you negative 50x. So we're good to go here. All right, so for the next thing, again, we're just going to set each factor with a variable equal to 0. Don't worry about the 3. Again, it's irrelevant. So 5x minus 6 equals 0, or 5x minus 4 equals 0. What we'll do is add 6 to both sides of the equation. This will cancel. You'll have 5x is equal to 6. Let's divide both sides of the equation by 5. And let's cancel this away and say x is equal to 6/5. Then we'll say or. Over here, I'll add 4 to both sides of the equation. Let's cancel this away. We'll have 5x is equal to 4. Divide both sides of the equation by 5. This cancels. You'll say x is equal to 4/5. So x is 6/5 or x is 4/5. All right, so let's look at problem number 5. So we have 35x squared minus 112 is equal to 266x. So the first thing I would do is just subtract 266x away from each side of the equation. So this is going to cancel. Again, I'm just going to write 0 there. And so I'll have 35x squared minus 266x minus 112 is equal to 0. Now, just looking at things, I know that you could probably pull something out here because the numbers are pretty large. So for 35, it's 5 times 7. Now, this number and this number, it's not divisible by 5, so you would check for divisibility by 7. So this is 7 times 5. For 266, forget about the fact that it's negative. If you divide it by 7 in your calculator, you would get 7 times 38. And then for 112, if you divide that by 7, you would get 16. So let's say this is 7 times 16. So again, you could divide everything by 7 if you wanted to, if you just want to get rid of it. Because we're factoring, I'm just going to keep pulling it out. So I'm going to say this is 7 times. We'll have 5x squared. And then minus, I'm going to say this is 38x. And then minus, we'll say this is 16. And let's set this equal to 0. Okay, let's slide down here. We'll have a 7 out here. And I'll set up my binomials. So then 5 is a prime number. So we know this is only 5x or x. That's the only possibilities. For 16, you've got quite a few things. So you've got 1 and 16. You've got 2 and 8. And then you've got 4 and 4. Okay. So we want, because this is subtraction here, again, if you're playing with the numbers, you just think about this in terms of absolute value. Because it's subtraction, you want to subtract what you get, and you're trying to get to 38. Forget about the fact that's negative. Just work with the absolute values. If I put a 16 here, it's way too big, right? 5 times 16 is 80. And if I put a 16 here and a 1 here, that's going to actually be too small. So get rid of this. That's not going to work. So now you have 2 and 8. If you put an 8 here and a 2 here, does that work? You would have 40 minus 2. Yeah, that would give me the 38. Again, forget about the signs. You're just working with the absolute value. So let's get rid of this. So what do I want in terms of my signs? Well, I want the larger in terms of absolute value to be negative. So let's put a minus here and a plus here so that this becomes negative 40x. And this becomes positive 2x. And again, negative 40x plus 2x will give you that negative 38x. Okay, let's get rid of all this. And again, now we're at the easy part. So take each factor with a variable, set it equal to 0, and solve. So I'm just going to take 5x plus 2, set that equal to 0. Then or x minus 8, set that equal to 0. Let's slide down here real quick. And and we'll subtract 2 away from each side of the equation. That cancels. 5x is equal to negative 2. Divide both sides of the equation by 5. And so let's cancel this away. And we'll say that x is equal to negative 2/5. Over here, let's add 8 to both sides of the equation. This cancels. Let's put or here. I'll just say x equals 8. And I'll say it over here. So x equals 8 like this. So x is equal to negative 2/5, or x is equal to 8. All right, let's take a look at problem number 6 now. So we have 14x squared minus 80x plus 76. This is equal to negative 4 minus x squared. And again, what I'm going to do is add 4 to both sides of the equation. Let's add x squared to both sides of the equation. Let's put that over there. Let's cancel this away and say this is 0. And then coming down here, we'll say 14x squared plus x squared would be 15x squared. Then minus 80x. And then plus 76 plus 4 is going to be 80. And of course, this equals to 0. Okay, looking at this, I see that everything ends with a 5 or a 0. So I know I can pull a 5 out. So let's pull out a 5. And actually on this one, let's maybe just take a different approach and divide everything by 5. So let's divide this by 5. Let's divide this by 5, this by 5, and this by 5, just so you see another way to do this. So what I'll do is cancel this with this and put a 3 here. I'll cancel this with this and put a negative 16 here. I'll cancel this with this and put a 16 here. And then 0 divided by 5 is just going to be 0. So let's put that this is 3x squared. We'll put minus 16x. We'll put plus 16 is equal to 0. Again, if you just wanted to factor the 5 out and leave it out on the left-hand side in front of parentheses, it does not affect your answer when you're doing this as factoring. So let's go ahead and factor this now. So let's put our 3x here and x here. For 16, we've already looked at this, so we know it's 1 and 16, it's 2 and 8, or it's 4 and 4. Okay. Let's think about this. So this is a plus, so I know I'm going to be adding. Again, forget about the fact that this is negative. I'm trying to get a sum of 16, okay? So if I put a 16 here, it's too big. And if I put a 16 here, it's still going to be too big. So this is out. So 2 and 8. If I put an 8 here, that's going to be 24. And then if I put an 8 here, let's actually check that. So if I put an 8 here and a 2 here, this would be 6, and then this would be 8. 8 plus 6 is 14, so that's not going to work. So you can throw this out. So the last possibility is 4 and 4, so that's going to have to work. Let's put a 4 there and a 4 there. And if you check it, you would have 3 times 4, which is 12, and then plus 4, which is 16. Again, forget about the fact that's negative. So now you just have to make the signs work. I'll put a minus here and a minus here. And again, you'll see that this works. This would be negative 12x, and this would be negative 4x. Negative 12x plus negative 4x is negative 16x. So we're good to go on the factorization. Okay, so now I'm just going to take 3x minus 4, set that equal to 0, then or your x minus 4, set that equal to 0, and I'm going to solve the resulting equations. So let's add 4 to both sides of the equation, cancel that. We'll have 3x is equal to 4, divide both sides of the equation by 3. Let's cancel this away. We'll have x is equal to 4/3. Then over here, let's add 4 to both sides of the equation. That'll cancel. Let me put or here, and I'll put x is equal to 4 there, and I'll just put it here, so x equals 4. So x is equal to 4/3, or x is equal to 4. All right, let's take a look at problem number 7. So we have 15x squared minus 16 is equal to negative 21x plus 2. Let me slide down here, and let's think about this. So I can just add 21x to both sides of the equation. And I'm also going to subtract 2 away from each side of the equation. Let me slide this down a little bit so it fits. Let's put minus 2 over there. Just going to cancel this away and put 0. So I would have 15x squared and then plus 21x. You have negative 16 minus 2. That's going to be negative 18. And this equals 0. Okay, so you can eyeball that. These numbers are very small. You can see everything would be divisible by 3. So again, you could divide everything by 3 at this point, or you could factor 3 out. Again, it's really up to you. Let's go back to factoring it out. So I'm going to pull a 3 out, and I would have 5x squared plus 7x, and then minus 6, set that equal to 0. So keep the 3 out in front. I'm going to set up my parentheses here, and so I'll put a 5x here and an x here. For this guy right here, it's minus 6. So again, when I'm working through this, I know I'm just thinking about this in terms of absolute value. I'm going to be doing a subtraction. So 6 is only 1 times 6 or 2 times 3. So if I put a 1 here and a 6 here, again, thinking about this in terms of subtraction, it would be 30 minus 1, which is 29. So that's not going to work. You could also try a 6 here and a 1 here. That is going to be 5 and 6. 6 minus 5 is 1. I'm trying to get to 7. Okay, so forget about that. That's not going to work. So it has to be 2 and 3. So if I put a 3 here and a 2 here, that is not going to work. That's 15 minus 2, which is going to be 13. So that's out of the question. The other one, the last possibility, is a 2 here and a 3 here, and that does work. 5 times 2 is 10. 3 times 1 is 3. 10 minus 3 would give me that 7 right there that I need. So I just need to figure out the signs. The larger in terms of absolute value has to be positive. So I want to put a plus here and a minus here. So this would be my 10x, and this would be my negative 3x. Again, 10x minus 3x is 7x. All right, let's get rid of this. And let's set each factor with a variable equal to 0 and solve. Again, the 3 out there, don't even worry about it. So we're going to have the 5x minus 3 equals 0. Then or x plus 2 equals 0. We'll add 3 to both sides of the equation. And let's cancel this away. We'll have 5x is equal to 3. Divide both sides of the equation by 5. So let's cancel this away. We'll have x is equal to 3/5. For this one, let's subtract 2 away from each side of the equation. Let's cancel this away, and we'll say x is equal to negative 2. So we'll have x equals 3/5 or x equals negative 2. All right, let's take a look at problem number 8 now. So we have 42x squared minus 174x plus 140 equals negative 4. So let's start by adding 4 to both sides of the equation. Let's cancel this away. And so again, I'm going to put 0 there. And we'll say that this is 42x squared minus 174x plus 144 is equal to 0. All right, so looking at this, again, these numbers are pretty big. So the first thing I notice is that everything is divisible by 3. 4 plus 2 is 6. 1 plus 7 plus 4. So 1 plus 7 is 8. 8 plus 4 is 12. And then 1 plus 4 is 5. 5 plus 4 is 9. So everything is divisible by 3. All these numbers are also even numbers, so they're automatically divisible by 2. So if a number is divisible by both 2 and 3, it's divisible by 6. So that means I can pull a 6 out from everything. Or again, if you want to, you can divide everything by 6. Maybe we'll just do that to change it up. So let's divide everything by 6 just to get a little bit of a change up here in the method that's used. So 42 divided by 6 is going to be 7. So this is 7x squared. And then minus 174 divided by 6 is going to be 29. So let's say this is 29x. And then plus 144 divided by 6 is going to be 24. And 0 divided by 6 is just 0. Okay, so let's set this up like this. I know that 7 is a prime number, so 7x and x. 24 does have a few possibilities. So you've got 1 and 24. You've got 2 and 12. Let's see, you've got 3 and 8. And then you've got 4 and 6. So this right here is a plus sign. Okay, so that means we're going to be adding when we're working this out. Again, in terms of absolute value, we're trying to get to positive 29. So again, forget about the signs for right now. So 1 and 24, could that ever work? If I put a 24 here, it's way too big. If I put a 24 here, it's actually still going to be too big. So this is out. 2 and 12. So if I put a 12 here, it's too big. If I put a 12 here and a 2 here, this is 7 times 2, that's going to be 14. And then plus 12 times 1, 12 times 1 is 12. 14 plus 12 is 26. So we need 29. Again, forget about the sign. So get rid of this. That's not going to work. So let's try 3 and 8. So if I put an 8 here, it's 56. That's already too big. So let's put a 3 here and an 8 here. And you notice that 7 times 3 is 21. And 8 times 1 is 8. 21 plus 8 is 29. Okay, so we got what we need. Just need to make the signs work now. So what I'd want is both signs to be negative. Again, negative plus negative is negative. Negative times negative is positive. So the outer here is going to be negative 21x. The inner here is going to be negative 8x. So negative 21x plus negative 8x is that negative 29x. Okay, so continuing from here, we'll take 7x minus 8, set that equal to 0. Then or x minus 3, that equals 0. So we'll add 8 to both sides of the equation. And let's cancel this away. 7x is equal to 8. And so let's divide both sides of the equation by 7. Let's cancel this away and say x is equal to 8/7. Let me make this 8 a little bit cleaner. Then over here, let's just add 3 to both sides of the equation. That cancels, so x equals 3. Let's put or x equals 3. So we have that x is equal to 8/7 or x is equal to 3. All right, let's take a look at problem number 9. So we have 174 plus 162x is equal to 6 minus 30x squared. All right, so what I want to do is, again, just move these to the left. So let's subtract 6 away from each side. And let's also add 30x squared to both sides of the equation. And so let's cancel this side away and say this is 0. On the left, I'll say this is 30x squared. And then we'll have plus 162x. You have 174 minus 6, and that's going to give me 168. So plus 168, and that equals 0. So again, what is my greatest common factor here? What could I pull out, or what could I divide everything by? Let me make this 0 better. Well, let's think about 30. It's the smallest number. So I would factor that first. And I would say, okay, well, this is 3 times 10. So 3 times 5 times 2. We know that nothing here other than 30 is divisible by 5, so 5 is out. We know that everything is going to be divisible by 2 because they're all even numbers. So we know we can pull a 2 out. So we want to check if we can pull out a 3 as well. That way we can pull out a 6. So 1 plus 6 is 7. 7 plus 2 is 9. So yes, this is divisible by 3. 1 plus 6 is 7. 7 plus 8 is 15. So yes, that's divisible by 3. So it looks like we can pull out a 6 or divide everything by 6. Let's go one more time and divide everything by 6. And then on the last one, we'll go back to just pulling it out. So 30 divided by 6 is going to be 5. So this is 5x squared. And then plus 162 divided by 6 is going to be 27. So this is 27x. And then plus 168 divided by 6, that's going to be 28. And this equals 0 divided by 6 is 0. All right. So now we have something pretty easy to factor overall. Let's put a 5x here, and let's put an x here. And so we have all plus signs. So let's just go ahead and put plus here and plus here. We know that's going to be the case. For 28, we do have a few possibilities. So we have 1 and 28. We have 2 and 14. We have 4 and 7. And that's going to be it. Okay, 1 and 28, that's unlikely to work. So let's start with 2 and 14. Can I make that work? If I put a 2 here and a 14 here, well, 5 times 2 is 10. And then 10 plus 14 would be 24. So that's not going to work. Flipping it around would make it way too big. So let's get rid of these possibilities. Has to be 4 and 7. So I can't put the 7 here, but I could put it here, and I could put the 4 here. That's going to have to work. So 5 times 4 is 20, and then 20 plus 7 would be 27. So this works. This would be 20x, and this would be 7x. So that's going to be 20x plus 7x. We're giving you 27x as a result. Okay, so now let's set each factor with a variable equal to 0 and solve. We'll have 5x plus 7 equals 0. Then or x plus 4 equals 0. So let's subtract 7 away from each side of the equation. That cancels. You'll have 5x is equal to negative 7. Divide both sides of the equation by 5. And so this would cancel. You get x is equal to negative 7/5. Over here, let's subtract 4 away from each side. Cancel that. We'll say x is equal to negative 4. So let's put or x equals negative 4. So x equals negative 7/5 or x equals negative 4. Okay, let's look at problem number 10. So we have 14x squared minus 35x equals negative 7x squared plus 56. So again, you could immediately look at this and say, I can divide everything by 7. So it's up to you if you want to do it. I'm just going to go through this the long way. And I'm going to add 7x squared to both sides of the equation. And I'm going to subtract 56 away from both sides of the equation. So this is going to be 0. So 14x squared plus 7x squared would be 21x squared. And then you have minus 35x, and then minus 56 equals 0. So instead of dividing everything by 7, let's just pull it out. So we would have 3x squared minus 5x minus 8. And let's set this equal to 0. Let's slide down here. This is going to be really easy to factor this. Let's keep the 7 out here. Set up our parentheses here. And so I know this is 3x, and this is x. So again, this is subtraction here, and this is 8. So we know we have 1 and 8, or we have 2 and 4, and that's basically it. With subtraction, again, all you're going to do is think about playing around with these all in terms of absolute value to see if you could subtract and get to 5. So in other words, you could put an 8 here and a 1 here, but that's too big, right? You have 24 minus 1, that's going to give you 23, so that doesn't work. If you put the 8 here and the 1 here, you have 8 minus 3, which I can get to 5 with. Okay, so forget about the fact that's negative. So I'm going to start by thinking about, okay, I want that sign to be negative 5x in the middle. So my larger in terms of absolute value needs to be negative. So I need a negative there and a positive there. Because what this is going to do is give me an outer of positive 3x and an inner of negative 8x. 3x minus 8x will give you negative 5x. So this is what I'm looking for here. Let me slide down and say that 3x minus 8, this factor here, we set that equal to 0. Then or the x plus 1, we set that equal to 0. Again, don't worry about 7. There's no variable there. Only set the factors with a variable equal to 0 and solve. So let's add 8 to both sides of the equation here. Cancel this. We get 3x is equal to 8. Divide both sides of the equation by 3. And let's cancel this away and say x is equal to 8/3. Over here, let's subtract 1 away from each side of the equation. Cancel this and say x equals negative 1. So we'll say or here, x equals negative 1. So x could be 8/3 or x is equal to negative 1. All right, let's take a look at our practice test. We're told to solve each equation. And for the first problem, we're given 17x squared plus 10. This is set equal to 129. So for all of the problems today, we'll be able to solve them using the square root property. And so just as a little refresher, if it's been a while since you've watched the lesson, recall if you have something like x squared is equal to, let's just say some number k, then x is equal to plus or minus the square root of k. So this is all we want to do. So we need to match the form here. We want this as x squared equals some number. Okay, so how can we do that? Let me just erase this. Well, basically, if I want to isolate this x squared here, the first thing I would do is I would subtract 10 away from each side of the equation. So this would cancel away. I would have 17x squared is equal to 129 minus 10 is going to be 119. Again, if I want to isolate this x squared here, what's being done to it? Well, 17 is being multiplied by x squared, so just divide both sides of the equation by 17. And let's cancel this away. And so what we'd have here is that x squared is equal to 119 over 17. 119 divided by 17, and you're going to see that you're going to get 7. Okay, so this is going to simplify to 7. Let me do this in a different line. I'll just say that this is x squared is equal to 7 here. Okay, so this is what we have. So once we have it in the form of x squared equals k, then you could just use your square root property. So in other words, x is equal to plus or minus the square root of whatever this number is. In this case, it's 7. So this would be your solution for the problem. If you want to pause the video and plug this in for x in the original equation, you can do that. You're going to see that square root of 7 would work, and then also the negative square root of 7 would work. Okay, let's look at problem number 2 now. So we have 18x squared plus 1 is equal to 3,403. Let me slide down here just a little bit. Again, the idea here is to isolate x squared on one side and then have a number on the other so that we can use our square root property. So I'm going to subtract 1 away from each side of the equation just to get things started. And so this would be 18x squared is equal to 3,403 minus 1 would be 3,402. From here, let's divide both sides of the equation by 18. And so this is going to cancel with this. Let me slide down here just a little bit. And so now I'm going to have that x squared is equal to 3,402 divided by 18. That's going to give me 189. And so I have x squared equals some number. Okay, so once we have it in that format, again, you can just use your square root property. We'll say that x is equal to plus or minus the square root of 189. Now, you might want to think about 189. Can you pull something out there that's going to simplify? Well, if we think about 189, again, I would just try to factor it and see what you get. I know that it's going to be divisible by 3, and it's also actually going to be divisible by 9. So let's go ahead and start off by saying that it's going to be 9 times 21, and I think that's as far as we need to go. We know 9 is a perfect square, it's 3 times 3. And for 21, we know it's 7 times 3. So basically, I can simplify this. Let's just erase this. We know what we have here. We'll say x is equal to plus or minus the square root of 9 times the square root of 21. And the square root of 9 is just going to be 3. So let's say x is equal to plus or minus 3 times the square root of 21. All right, let's look at problem number 3 now. So we have 10x squared plus 5 is equal to 995. So again, I'm trying to isolate this x squared here and then have a number on the other side. So let's subtract 5 away from each side of the equation. Let's cancel this away. And so we have 10x squared is equal to 995 minus 5 would be 990. Let's divide both sides of the equation by 10. And let's slide down here a little bit. Let's cancel this. We'll say x squared is equal to 990 divided by 10 would be 99. And now that we have it into the format of x squared equals some number, again, we can use our square root property. So we would just say x is equal to plus or minus the square root of 99. But you know that 99 is divisible by 9, right? It's 9 times 11. So you can say that x is equal to plus or minus the square root of 9 times the square root of 11, and you can replace the square root of 9 with 3. So let's slide down here and write our final answer. We'll say x is equal to plus or minus the square root of 9 is 3, and then times the square root of 11. All right, let's look at problem number 4 now. So we have 17x squared plus 6 is equal to negative 368. All right, so again, to isolate x squared, what I'll do is subtract 6 away from each side of the equation. Let's cancel that away. We have 17x squared is equal to negative 368 minus 6. That's going to give me negative 374. To finish things up, let's divide both sides of the equation by 17. And so this would cancel. We have x squared on the left, and this is equal to, on the right, negative divided by positive is negative. 374 divided by 17 is going to be 22. So we have x squared is equal to negative 22. So to finish things up, we'll say x is equal to plus or minus the square root of negative 22. Now again, we've talked about how to simplify if you have a negative radicand here, so a square root of a negative number. Remember, we can use our imaginary unit I. So what we're going to do is say x is equal to plus or minus, let's go the square root of negative 1 times the square root of 22. And 22 is 2 times 11, so you really can't do anything further with that. But you can replace the square root of negative 1 with I. So let's say that the answer here is going to be x is equal to plus or minus, we'll put I, that's the imaginary unit, times the square root of 22. All right, let's take a look at problem number 5. So what we're looking at here is 14x squared plus 9 is equal to 65. Again, we want to isolate x squared, so let's subtract a 9 away from each side of the equation. Let's cancel this away. We'll have 14x squared is equal to 65 minus 9. That's going to give me 56. And again, if I want x squared by itself, then I've got to divide both sides of the equation by 14. So let's slide down here a little bit. Let's cancel this away and say x squared is equal to 56 divided by 14. That's going to give me 4. So again, by the square root property, if x squared equals 4, then that means x is equal to plus or minus the square root of 4. And we know that the square root of 4 is simply going to be 2. So my final answer here is going to be that x is equal to plus or minus 2. All right, let's take a look at problem number 6. So we have 15x squared plus 3 is equal to negative 147. So what I'll do here is subtract 3 away from each side of the equation. Let's cancel this away. And now I'll have the 15x squared is equal to negative 147 minus 3. That's negative 150. Again, trying to get x squared by itself. So let's divide both sides of the equation by 15. Let me make that a little bit better. And so this is going to cancel. And what we'll have here is x squared is equal to negative divided by positive is negative. 150 divided by 15 is going to give me 10. So this would be x squared equals negative 10. So from here, we'll say that x is equal to plus or minus the square root of negative 10. Again, if you have that negative there, you can simplify again using the imaginary unit I. So let's break this down and say we have x is equal to plus or minus the square root of negative 1 times the square root of 10. And for 10, it's 2 times 5, so you really can't do anything else with that. But to finish things up, I can say that x is equal to plus or minus the square root of negative 1. We're going to write that as I, the imaginary unit, then times the square root of 10. Okay, let's look at problem number 7. So we have 13 minus 15x squared equals negative 2,927. So what I want to do here is subtract 13 away from each side of the equation. Let me cancel this. We'll have negative 15x squared is equal to negative 2,927 minus 13. That's going to give me negative 2,940. Again, to isolate x squared, I'm just going to divide both sides of the equation by negative 15. Let me make this one a little bit better over here. So let's redo that. And so let's cancel this away. We'll say x squared is equal to, if you punch this into your calculator, negative 2,940 divided by negative 15. Of course, negative divided by negative is positive, and 2,940 divided by 15 is 196. So if x squared equals 196, then x equals plus or minus the square root of 196. And the square root of 196 is 14, so we can finish this up by saying that x is equal to plus or minus 14. All right, let's take a look at problem number 8 now. So we have 20 plus 400x squared is equal to 56. All right, so let's slide down here a little bit. And let's think about, again, how we're going to get this x squared by itself. Let's subtract 20 away from each side of the equation. And let's cancel this away. We'll have 400x squared is equal to 56 minus 20 is going to be 36. And let's divide both sides of the equation by 400 so we can get x squared by itself. And so this is going to cancel here. And let's think about how we can simplify 36 over 400. So let me write x squared over here. This is equal to, so for 36, let me write this as 2 squared, or 4, times 3 squared, or 9. For 400, I know it's 20 squared, right? So 20 is 4 times 5. So basically, you would have 5 squared. Let me put 5 squared here like this. And then 4 is 2 squared, so this is going to be 2 to the 4th power. So 2 to the 4th power times 5 squared. So before we do anything, let's cancel some things out. I know I can cancel this out and put this as a 2 here. So let's write this as 9 over 2 squared is 4, and then 4 times 5 squared is 25. 4 times 25 would be 100. Okay, so let's write this as 9 over 100 like this. And let's come down here, and we will say that we have x squared is equal to 9 over 100. And of course, to finish this up, we'll use our square root property and say that x is equal to plus or minus the square root of 9 over 100. And so we can keep simplifying. We can say x is equal to plus or minus. We'll have the square root of 9 over the square root of 100. And so x is equal to plus or minus. The square root of 9 is 3, so let's put that as 3, over the square root of 100 is 10. So x will be equal to plus or minus 3 over 10. Okay, let's look at a different type of problem for 9 and 10. This leads us into the next section where we're going to be talking about completing the square. So here we have 2 times the quantity x minus 9 squared equals 288. So you can also use the square root property when this type of situation comes up. Now you're trying to isolate this right here. Okay, so that quantity x minus 9 that's being squared. So what you would do is you would first just divide both sides of the equation by 2. And I didn't do that so well, so let's try that again. And so essentially this 2 is going to cancel with this 2 here. So what you have is this x minus 9, this quantity being squared, and this equals 288 divided by 2. That's going to give you 144. All right, so just like before when we had x squared is equal to k, and we said x is equal to plus or minus the square root of k, it's the same concept here. So the quantity x minus 9 being squared is equal to 144. So that means x minus 9 is equal to plus or minus the square root of 144. So same concept here. So let's put x minus 9 is equal to plus or minus the square root of 144. But you can see that we have more steps when we have this type of problem, right? We're not done immediately like we normally are. So what we'd want to do is first take care of the square root of 144, which is 12. So let's say x minus 9 is equal to plus or minus 12. And then you have to actually split this up into 2 different equations, right? Because you have positive 12 and negative 12. So you have to say that x minus 9 is equal to 12, then or x minus 9 is equal to negative 12. So you have to solve both scenarios. So let's come down here. And for the one on the left, let's just add 9 to both sides of the equation. That cancels. So you get x is equal to 12 plus 9 is 21. And then let's put or here. On the right, let's add 9 to both sides of the equation. That cancels. So we'll say x is equal to negative 12 plus 9 is going to be negative 3. So the solution for this equation is that x equals 21 or x equals negative 3. All right, let's look at problem number 10. So we have 4 times the quantity 3x minus 5 being squared. And this is set equal to negative 500. So again, the idea for this type of problem, you want to isolate this part right here. It's what's being squared. And what I'll do is I'll, again, just divide both sides of the equation by 4. And this is going to cancel away. So now I have this quantity 3x minus 5 being squared. And this is equal to negative 500 over 4, which would be negative 125. Okay, so continuing here, again, using our square root property, this guy right here being squared is equal to negative 125. So we can say 3x minus 5. So what's being squared here will be equal to plus or minus the square root of negative 125. Okay, let's slide down here a little bit. We have a lot to do in terms of simplifying. So let's say we have 3x minus 5 is equal to plus or minus. For the square root of negative 125, let's write the square root of negative 1 times, let's write the square root of 25 times the square root of 5. Okay, so we know that the square root of negative 1 is I. We know the square root of 25 is 5, so let's just replace that. And let's say that we have 3x minus 5 is equal to plus or minus, this will be I, this will be 5, so let's write 5i. So 5i, then times the square root of 5. So again, because you have this plus or minus here, and you haven't solved for x yet, you have to keep going, and you have to set up 2 different equations, okay? So that's very important. So we would say that 3x minus 5 is equal to, I'm going to go with the plus 5i times square root of 5, so we have to solve that. And then we'll have or, let me see if I can scooch this down a little bit so I can fit it all in one line. We'll say the other scenario is 3x minus 5 is equal to, now we have the negative 5i times square root of 5. And so we'll add 5 to both sides of the equation over here. And so this is going to give us 3x is equal to 5i times square root of 5, and then plus 5. And then to finish things up, let's divide both sides of the equation by 3. And so this would cancel, and we'll have x is equal to 5I times square root of 5 plus 5, and this is over 3. Okay, over here, let's add 5 to both sides of the equation. And so we'll have 3x is equal to, this would be negative 5I times square root of 5, and then plus 5. We'll divide both sides of the equation by 3. And so again, this part right here is going to cancel. And you're going to have, let's put or, we'll have x is equal to negative 5I times square root of 5 plus 5 over 3. Now you can combine these two. You'll notice that the difference here between them is just going to be this one's a positive and this one's a negative. So a lot of times we'll just condense our solution. So we'll say x is equal to, let's put the 5 out in front, and then we'll say plus or minus. We've got that 5I times the square root of 5, and this is over the common denominator of 3. So if you want to write it this way, it's fine if it's less confusing, or you can combine them into one solution like this. Again, it's kind of up to you. It's personal preference, but most textbooks will just list their answer this way. All right, let's take a look at our practice test now. We're told to solve each equation, and for the problems today, we're going to use the method known as completing the square. So for the first problem, we have x squared minus 4x minus 32, and this is set equal to 0. All right, so the idea here is that the first thing you would do is make sure that the coefficient on x squared is a 1. If it's not, we have to do additional work. In this case, it is, so we can skip to the next step. What you want to do is put all the variable terms on one side, typically I use the left, and put your constant on the other. So in other words, what I want to do is add 32 to both sides of the equation. So this would cancel away. And so what you have now is x squared minus 4x is equal to 32. Okay, so here's where people get a little bit lost. What you want to do is you want to take 1/2 of the coefficient that's on x to the first power. So in this case, that's negative 4. So let's put negative 4 times 1/2. So this is where I say cut it in half. And then you want to square that. So you want to square this. So this is equal to what? Well, negative 4 divided by 2 is negative 2, and negative 2 squared is going to be positive 4. So this right here is what you need to add to both sides of the equation so that the left side is a perfect square trinomial. So what I'm going to do, let me actually move this off to the side. I'm going to say that I'm going to go x squared minus 4x. I'm going to add 4 to the left, and to make that legal, I'm going to add 4 to the right. So I didn't do anything illegal. I added 4 over here and added 4 over here. So you can get rid of this scratch work at this point. What you want to do now is factor the left-hand side. I've now created a perfect square trinomial, so this factors into a binomial squared. So this would be x minus 2 quantity squared, and this is equal to 32 plus 4 is 36. So now we have this into the form such that we can use the square root property. If this quantity x minus 2 squared is equal to 36, then what we can do is say that x minus 2 is equal to plus or minus the square root of 36. And from there, we would just split this up into two different equations. So we would say that x minus 2 is equal to, the square root of 36 is going to be 6. Let's say plus or minus 6. So x minus 2 equals 6, or x minus 2 is equal to negative 6. All right, let's slide down here, and let's add 2 to both sides of the equation here. Let's cancel that. We'll have x is equal to 8. Then or, over here, let's add 2 to both sides of the equation. Cancel that. We'll have x is equal to negative 6 plus 2 is going to be negative 4. So my solutions here, you have x equals 8 or x equals negative 4. All right, let's look at the next one. So for problem 2, another easy one, we have x squared minus 4x minus 60 equals 0. Let's slide down a little bit. Again, the first step is always to make sure that the coefficient on x squared is a 1. If it's not, again, we have additional stuff to do. In this case, it's easy. So that's done for us. So the next step is you want to move this guy over here to the right. So you want all your variable terms on the left, or you can put it on the right. Again, it's up to you, but I like it on the left. So I'm going to take x squared minus 4x and keep that on the left. And then I'm going to add 60 to both sides of the equation because you want your constant on the other side. So I want mine on the right. Okay, so here's where we're going to, again, complete the square. So this is the step where everyone gets lost. Look at this coefficient for x to the first power. In this case, it's the same as in the last example, it's negative 4. You want to cut it in half, meaning you multiply it by half and then square it. So cut it in half and then square it. And you're going to add that to both sides. So negative 4 times a half square that, and this is going to give me, again, negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So this is what we need to add to both sides of the equation, again, to complete the square. And so we'll say that x squared minus 4x, again, I'm going to add 4 over here. This equals 60 plus 4. So I added 4 over here. To make it legal, I added 4 over here. So now we want to just factor this into a binomial squared. So this would be x minus 2 quantity squared is equal to 60 plus 4 is 64. And again, at this point, we can use our square root property. So we can say that basically this is x minus 2 is equal to plus or minus the square root of 64. We know the square root of 64 is going to be 8. So basically we can say that x minus 2 is equal to plus or minus 8. And here's where we split this up into two different equations. So we'll say that x minus 2 is equal to 8, or x minus 2 is equal to negative 8. What we can do from here is add 2 to both sides of the equation. Let's cancel this away. We have x is equal to 8 plus 2 is 10. Then or over here, let's add 2 to both sides of the equation. Cancel that away. We'll say x is equal to negative 8 plus 2 is going to be negative 6. So we get x equals 10 or x equals negative 6. Okay, let's look at problem number 3 now. So we have x squared minus 10x minus 36 equals 0. So again, the first step is always to make sure that the coefficient for x squared is 1. Again, in this case, we have an easier scenario, so we don't have to do anything there. And then we want to move all the variable terms to one side and the constant to the other. So let's add 36 to both sides of the equation. And we'll say that we have x squared minus 10x. And then we'll say this is equal to positive 36. Okay, so from here, again, what you want to do, this step again is where everyone gets lost. Take the coefficient of the x raised to the first power, cut it in half, and then square it. If you say that a few times, you won't forget it. So cut it in half and then square it. So negative 10 times a half, and then square that. So what is negative 10 divided by 2? That's going to be negative 5. You square that, you get 25. So this equals 25. So this is what I need to add to both sides of the equation, again, so I can complete the square or make a perfect square trinomial on the left. Let me actually slide this out of the way, and I'll write this in a different color. So x squared minus 10x, I'm going to add 25 to the left, and again, to make it legal, I'm going to add 25 to the right. Okay, so I added it here and added it here. So now we're done with this scratch work, so let's get rid of this. And so we're going to factor the left-hand side now because this is a perfect square trinomial, so it factors into a binomial squared. So it's going to be x minus 5, quantity squared, and this equals 36 plus 25. That's going to give me 61. Okay, so from here, again, I can use my square root property. So this guy right here would be x minus 5 is equal to plus or minus the square root of 61. Okay, so we need two different equations here to get our solutions. So we have x minus 5 is equal to square root of 61. Then or we have x minus 5 is equal to the negative of the square root of 61. Now in this case, you could really just combine things because you really can't simplify the square root of 61. And in each case, you're just adding 5 to both sides. So you could put this back into a more compact form if you want. So let me actually do it individually, and then I'll do that way. So let's just add 5 to both sides over in each case. This cancels and this cancels. So you have x is equal to 5 plus the square root of 61, or x equals 5 minus the square root of 61. And then again, you could write this in a more compact form. You could say that x is equal to, you have the 5, and then you have plus, and then you have minus. So you're going to go plus or minus the square root of 61. So you can write it like this or this, whatever you want to do. Let's look at a few now that are a little bit harder. So for problem number 4, we have 3x squared plus 6x minus 70 is equal to negative 10. All right, so the problem here is that you don't have a coefficient of 1 on your x squared, okay? So you want to make sure that it's 1. Now, in this particular case, I would actually do this other step first because I think it's a little bit easier. So let me add 70 to both sides of the equation. And let's get rid of this. So we'll have 3x squared plus 6x is equal to, you have negative 10 plus 70. That is going to give me positive 60. And so from here, I'm going to divide everything by 3. Again, why am I doing that? Because I want the coefficient for x squared to be 1. And since the coefficient is 3, if I divide everything by 3, this is going to cancel and give me 1x squared. Okay, so I have to have that to use this procedure. So this would be x squared plus 6 divided by 3 is 2, so this would be 2x, and this equals 60 divided by 3 is going to give you 20. Okay, so now we have this into the form that we are used to, and again, I'm just looking at the coefficient for my x raised to the first power, and just say it with me, you want to cut it in half and square it. Okay, again, just keep saying that over and over until it just sticks in your mind. So x squared plus, again, you have your 2x. If you take 2 and you cut it in half, multiply by half, and then you square that, 2 times a half is 1, 1 squared is 1. So I'm just going to add 1 to both sides of the equation to complete the square. So plus 1 equals 20 plus 1. Okay, we can just write this as 21 if you want. I think we can keep track of that. So this left side here is just going to get factored into a binomial squared. So we know that this would be x plus 1, quantity squared, is equal to 21. Okay, so now that we have it in this form, we can use the square root property and just say that x plus 1 is equal to plus or minus the square root of 21. And for 21, it's 7 times 3, so we really can't do anything with that. So if you want to take the time and write it out, you can. I think for this situation, if you know this isn't going to simplify, you could just subtract 1 away from each side and just write your answer more cleanly and say x is equal to -1 plus or minus the square root of 21. So that would cover -1 plus the square root of 21 and then -1 minus the square root of 21. All right, let's take a look at problem number 5 now. So we have x squared minus 4x plus 48 is equal to -5. So we have another easy one because the coefficient on x squared is 1 there. So we really don't have to worry about that. So let's subtract 48 away from each side of the equation. Let's cancel that away. Let's have x squared minus 4x is equal to -5 minus 48. That's going to give me -53. And from here, again, we're just going to complete the square. So we're going to take this coefficient on x to the first power, which is -4. You got to cut it in half. So I'm going to multiply by half, and then I'm going to square it. So cut it in half and square it. So -4 divided by 2 is -2. -2 squared is 4. So I need to add 4 to both sides of the equation. So let's do that real quick. So we'll say that we have x squared minus 4x plus 4 is equal to -53, again, plus 4. So I added 4 over here, added 4 over here. So nothing illegal. Let's get rid of this, and let's factor this left-hand side here into a binomial squared. So this would be x minus 2, quantity squared. And this equals -53 plus 4 is going to give me -49. So what I want to do now is use my square root property. So again, I would just take the x minus 2 here and set this equal to plus or minus the square root of -49. So this can actually be simplified. So let's put x minus 2 is equal to plus or minus, let's write the square root of -1 times the square root of 49. We know the square root of 49 is 7. We know the square root of -1 is I. So let's put this as x minus 2 is equal to plus or minus 7i. So from here, what you would do is add 2 to both sides of the equation. And we would say x is equal to 2, we'll say plus or minus 7i. And again, that's one way to write it if you wanted to write x equals 2 plus 7i or x equals 2 minus 7i. Again, that's completely up to you. Okay, let's look at problem number 6 now. So we have 2x squared plus 4x plus 4 is equal to 10. So again, when we think about the coefficient on x squared, it needs to be 1. So you could divide everything by 2 now, or you could subtract 4 away from each side. It's really up to you. I think this is a little bit easier. Let's cancel this away. Let's go 2x squared plus 4x is equal to 6. And now what I'm going to do is divide everything by 2. Again, so that this coefficient here on x squared is 1. That's very important. Don't forget to do that. So this cancels, and you get x squared plus 4 divided by 2 is 2. So 2x is equal to 6 divided by 2 is 3. Okay, so now we have it into the correct form. And what we want to do, again, is cut this coefficient on x to the first power in half. Let me highlight this real quick. So 2 times a half, and then we want to square it. So cut it in half and square it. So no, 2 times a half is 1. 1 squared is 1. Okay, so we're going to add 1 to both sides of the equation so we can complete the square. So we'll have x squared plus 2x plus 1 is equal to 3 plus 1. Again, I added 1 to the left. I also added it to the right. So looking at this on the left, again, I have a perfect square trinomial, which means I can factor this into a binomial squared. So this is going to be x plus 1, quantity squared, is equal to 3 plus 1 is 4. Again, from the square root property, we know that this is x plus 1 is equal to plus or minus the square root of 4. And then from here, basically you have x plus 1 is equal to square root of 4 is 2, so plus or minus 2. And then we're going to split this into two different equations. So you have x plus 1 is equal to 2, then or x plus 1 is equal to -2. Let's subtract 1 away from each side over here. This cancels. You'll get x is equal to 2 minus 1 is going to be 1. So then or over here, let's subtract 1 away from each side. This cancels. You'll have x is equal to -2 minus 1 is going to be -3. So you get x equals 1 or x equals -3. All right, let's look at problem number 7 now. So what we're going to have here is 4x squared plus 73. This is equal to 6 minus 2x. So again, you're looking at the coefficient on x squared, and in this case, it's a 4. You need it to be a 1. So you could immediately divide everything by 4. You can do that if you want. But I would suggest actually going to the second step first, which is to move all the variable terms to one side and the constants to the other. So let's add 2x to both sides of this equation. Let me put this over here like this. And let me subtract 73 away from both sides of the equation. And the reason I'm going to do that first is so that I don't have to mess with any fractions or anything like that for now. So this is going to cancel and this is going to cancel. So you would have 4x squared. Then you would have plus 2x. So that's my left-hand side. And this equals, now I have 6 minus 73, and that's going to give you negative 67. Okay, so now I can divide everything by 4. Again, you could have done it to start. It's really up to you how you do it. But then you're going to have to combine some fractions, which I think is a little bit more work. So I'm going to divide everything here by 4. And so this right here is going to cancel, and you'll have x squared plus 2 over 4 we know is a half. So you could write x over 2, but I think for this exercise, let's write this as 1/2, and then times x, and this equals, we'll have negative 67 over 4, and there's really nothing you can do to simplify that. 67 is an odd number, so we just have to leave that as it is. Okay, let's come down here a little bit. And again, we want to think about the coefficient that's on x to the first power. So in this case, that's 1/2. So what do? We cut in half and then we square it. So if I cut a half in half, it's 1/2 times a half. So that's going to be 1/4 squared. So you would have 1/4 being squared. So the 1 is squared, that's 1. And the 4 is squared, that's 16. So you have 1 over 16 here. So this is what you're going to be adding to both sides of your equation. So let's erase this, and let's say we have x squared plus 1/2 x plus 1 over 16, and this is equal to negative 67 over 4 plus 1 over 16. So this is going to be x plus 1/4 quantity squared. So this is going to be x plus 1/4 quantity squared, and this equals, here you would need a common denominator, so you would have to multiply this by 4 over 4. So you could have a denominator of 16. 4 times negative 67 is going to be negative 268. So let's write negative 268, and this will be over. 4 times 4 is 16, and then plus we have 1 over 16. And of course, negative 268 plus 1 would be negative 267. So let's just write this as negative 267 over 16. Okay. So now we have this into the form where we can use our square root property. We'll say x plus 1/4 is equal to plus or minus the square root of negative 267 over 16. Let me make this a little bit better so it covers everything. All right, so there's a lot of simplifying to do. So let's first say that x plus 1/4 is equal to, let's break this up and say plus or minus, we'll say the square root of negative 1 times the square root of 267. This is over the square root of 16. All right, so we know the square root of 16 is 4. So let's replace that. So we would have x plus 1/4 is equal to, we know that the square root of negative 1 is I. So let's put plus or minus. We'll put I times the square root of 267. Now 267 is 3 times 89, but 3 is not a perfect square, and 89 is not a perfect square, and I would note that 89 is a prime number, just like 3 is. So you really can't do anything with this. So this is 267 here, and then this will be over, square root of 16 is 4. Okay, so all we really would want to do to finish this up is subtract 1/4 away from each side of the equation. So what I'll do is say minus 1/4 over here, and minus 1/4 over here, cancel this away, and say x is equal to negative 1/4. Then you have your plus or minus I times the square root of 267 over this 4. Now you have a common denominator, so if you want, you can write this in a more compact way by saying x is equal to, we'll go negative 1 plus or minus I times the square root of 267 over the common denominator of 4. Okay, let's look at problem number 8 now. So we have 8x squared minus 10x plus 5 is equal to negative 8x. All right, so let's clean up just a little bit first. Again, you see that the coefficient on x squared is not 1, so we need to divide some things. But what I'm going to do is actually just add 8x to both sides of the equation and just clean that up and then subtract 5 away from each side of the equation. Let's cancel that away and cancel that away. So let's say we have 8x squared. Negative 10x plus 8x would be negative 2x. And this will be equal to basically just negative 5. So from here, again, I have this 8 that's the coefficient for x squared. This, in order to use our procedure, has to be a 1. So to take care of that, I'm just going to divide everything here by 8. So now what we would do is cancel this and say that x squared minus 2 over 8 is a fourth. So let's write this as 1/4 times x like this, and this equals negative 5/8, and you really can't simplify that fraction. Okay, thinking about this now, again, I want to complete the square. So I want to take this negative 1/4, I want to cut it in half, and I want to square it. So let's take negative 1/4 times a half, and I want to square this, okay? So this negative 1/4 times a half would be negative 1/8. If I square that, think about squaring 1, that's 1. If I square 8, that's going to be 64, okay? So think about 1 over 64 is going to be added to both sides of the equation. So 1 over 64. So we would have x squared minus 1/4 x plus 1 over 64 is equal to negative 5 over 8 plus 1 over 64. Now let's think about factoring the left side. So this is going to factor into x minus 1/8. Again, this would be quantity squared, and this would be equal to, over here, you need a common denominator. So let's write negative 5 over 8 times 8 over 8, because I would want 64 as my denominator, because that's what I have over here. So plus 1 over 64. So let's just rewrite this. So x minus 1/8 quantity squared is equal to negative 5 times 8 is going to be negative 40. So let's say this is negative 40 plus 1 over the common denominator of 64. So this would be negative 39 over 64. So let's write this side as negative 39 over 64. So from here, I'm going to use my square root property. So we know that this would be x minus 1/8 is equal to plus or minus the square root of negative 39 over 64. So let's split this up and say this is x minus 1/8 is equal to plus or minus, again, you have the square root of negative 1, which is going to be I, times the square root of 39. Now 39 is 13 times 3, so you're not going to be able to do anything with that. This is over the square root of 64, which we know is 8. So let's go x minus 1/8 is equal to plus or minus, this would be I, square root of negative 1 is I, the imaginary unit, times the square root of 39 over the square root of 64 is 8. All right, to finish things up, let's add 1/8 to both sides of the equation. That would cancel. You have x is equal to, let's say 1/8 plus or minus I times the square root of 39 over 8. And again, if you want to condense this, you could say x is equal to, let's go 1 plus or minus I times the square root of 39 over the common denominator of 8. All right, let's take a look at problem number 9 now. So we have 69 minus 17x is equal to 4x minus 2x squared. Now I like my variable terms to be on the left, but what you could do is you could just add 17x to both sides of the equation. So let's do that real quick. We'll have 69 is equal to 4x plus 17x is going to give me 21x, and then minus 2x squared, and then you could just flip things legally. So what I can do is actually just say this is negative 2x squared plus 21x is equal to 69. All right, so from here, remember, the coefficient on x squared has to be 1. Right now it's negative 2, so you've got to get rid of that. So I'm going to divide everything here by negative 2. And so this is going to cancel. You'll have x squared, then you can have minus 21 over 2 times x is equal to negative 69 over 2. All right, so now, again, we're going to go into completing the square. We need to take the coefficient for this x to the first power. In this case, it's negative 21 over 2. We need to cut it in half, and then we need to square it. So in this case, you have negative 21 over 2 times a half, and then we're going to square that. And so negative 21 over 2 times a half would be negative 21 over 4. And then we're going to square this. So what is negative 21 being squared? 441. And 4 squared we know is 16. So 441 over 16 is what we need to add to both sides of the equation. And let's say that this is x squared minus 21 over 2 times x plus 441 over 16 is equal to negative 69 over 2. Again, this is going to be plus this 441 over 16. Let me slide this down so it all fits. Okay, let me make this 16 a little bit better. So we already know that we're going to need a common denominator over here. So I'm just going to write times 8 over 8. And we'll come back to that in a moment. So I want to factor the left side into a binomial squared. And I know with things like this, it gets a little bit tricky to factor. But remember, it's always going to be whatever you took here that you cut in half before you squared it, right? So before you squared it, you had negative 21 over 4. So it's x minus 21 over 4. Okay, so this is what we want. So x minus 21 over 4, that quantity being squared. Over here, let's do negative 69 times 8. That's going to give me negative 552. Then you have plus 441, and this is over 16. So negative 552 plus 441, that's going to give me negative 111. So let's come down here and say that we have the quantity x minus 21 over 4 being squared is equal to, again, this up here would be negative 111, and this is over 16. All right, so from my square root property, again, I know that this would be x minus 21 over 4 is equal to plus or minus the square root of negative 111 over 16. And now we can just do some simplifying here. So we have x minus 21 over 4 is equal to plus or minus, let's say the square root of negative 1 times the square root of 111, and this is over the square root of 16. So we know the square root of 16 is 4. Then for the square root of 111 is 37 times 3, so you really can't do anything with that. We know the square root of negative 1 is I. So let's write over here that x minus 21 over 4 is equal to, we'll go plus or minus I times the square root of 111, and this is over, square root of 16 is 4. So you have this common denominator that you're going to have. If you add 21 over 4 to both sides, let's just do this the long way so nobody gets lost. So let's add 21 over 4 to both sides of the equation. Let's cancel this away. We'll say x is equal to, we'll have 21 over 4, then plus or minus I times the square root of 111 over 4. And again, you have a common denominator there, so most people will just decide to write this as x is equal to, we'll go 21 plus or minus I times the square root of 111 over the common denominator of 4. All right, let's take a look at problem number 10 now. So what we're going to have here is 10x squared minus 4x is equal to 142. So in this case, we really don't have to do much work in terms of moving things because I have all my variable terms on the left and I have my constant on the right. So I'm looking at this coefficient for x squared and it's a 10. So of course we need to divide everything by 10 to get rid of that. So let's go ahead and do that real quick. 10 divided by 10 is 1. So let's go ahead and put this as x squared and then minus 4 over 10. You think about 4 divided by 2 is 2 and 10 divided by 2 is 5. So this is 2/5 times x and this equals 142 divided by 10. You could cancel a common factor of 2. And so this would be 71 over 5. Okay, so from here, again, I want to complete the square. So let's look at this coefficient for x to the first power. It's negative 2/5. So cut in half, negative 2/5 times a half, and then square that result. So just simplifying here, this would cancel. And basically you would have negative 1/5. And if that was squared, again, the negative goes away. 1 squared is 1, 5 squared is 25. So you're going to be adding 1 over 25 to both sides of the equation. So 1 over 25. So I'm going to have, on the left side, x squared minus 2/5 x plus 1 over 25 is equal to 71 over 5 plus, again, this 1 over 25. So adding 1 over 25 to both sides of the equation. And then from here on the left side, you can factor this into a binomial squared. So again, I know when you work with fractions it's tough, but what did we square? We squared negative 1/5, right? So we want x minus 1/5 quantity squared. That's all you have to think about. So this is equal to, over here, let's just get a common denominator going. So let's put this as times 5 over 5. 71 times 5, that's 355. Then plus 1 over the common denominator of 25. So this would be 356. Let's write this in another step so nobody gets lost. So we'll say the quantity x minus 1/5 being squared is equal to, this would be 356 over 25. And from here, I can just use my square root property. So in other words, what I could say is that x, then we have minus 1/5. This will be equal to plus or minus the square root of 356 over 25. All right, from here we can break this up. So let's say this is x minus 1/5 is equal to plus or minus, you'll have the square root of 356 over the square root of 25. Now we know the square root of 25 is 5, but what about the square root of 356? Well, 356 is 89 times 4. So let me write this as the square root of 89 times the square root of 4. So that's a little bit more clear. And then we know that this would be x minus 1/5 is equal to plus or minus. The square root of 4 is 2, so let's write 2 times the square root of 89 over, we know the square root of 25 is 5. Okay, so from here I could just add 1/5 to both sides of the equation. So let's do that right here. So plus 1/5 and then plus 1/5. Let's cancel that away. And we'll say x is equal to 1/5, then plus or minus 2 times the square root of 89 over 5. So again, if you want to, and I advise this, you can write this in a more compact form because you have a common denominator. So you have x is equal to, you'll have 1 plus or minus 2 times the square root of 89 over the common denominator of 5. All right, let's take a look at our practice test. We're told to solve each equation, and for the problems today, we're going to be solving quadratic equations using our quadratic formula. So for problem number 1, we're given 9x squared minus 9x minus 20, and we're going to set this equal to negative 10 minus 6x. All right, so maybe you don't have the quadratic formula memorized at this point, but it's just something you're going to commit to memory after you work a lot of problems. So just keep writing it down before you solve each problem, and after 10 or 15 problems or so, you will have memorized this guy. So the first step is actually to write your quadratic equation in standard form. So you want something that looks like this. So ax squared plus bx plus c is equal to 0. So the formula is easy to use. It's very, very easy to make a simple sign mistake. So I'll be showing you how to stay away from those in this problem and the next ones. The first thing I would do for this problem is get all these terms on the right over to the left. So I would add 10 to both sides of the equation. Let's cancel that away and put that over here. And then I would add 6x to both sides of the equation. So let's cancel this away over here. Now, if everything's canceled, remember, negative 10 plus 10 is 0. Negative 6x plus 6x is 0. So if you just had one of those terms left, you wouldn't have to put plus 0 because obviously that doesn't do anything. But in this case, everything is canceled away. So you need to write something. You just can't leave it blank. So you want to put a 0 there. Okay, so the right side is 0. On the left-hand side, and let me move this down out of the way. On the left-hand side, your 9x squared, there's nothing to combine with that. So let's just keep 9x squared. Then you have this negative 9x plus 6x. Well, let's say that's negative 3x. Then you have negative 20 plus 10. That's going to be negative 10. And this equals 0. So the idea here is that we've matched this form here. So you can look at this and just draw a line and say, well, A is going to be 9 and B is going to be negative 3. So be really careful with the signs. If you have subtraction there and you get confused, you can always say this is plus negative 3. And then for the C, this is the constant. Again, if you get confused with the sign, you can say this is plus negative 10. But if it's a subtraction, always take that sign with it. So if you're subtracting away a positive number, then just treat it as a negative number when you take that number. Okay, so this would be negative 3 and this would be negative 10. So you just record those values, you plug into the quadratic formula, and as long as you don't make a mistake there, you pretty much get your answer right away, right? There's not a whole lot of work versus completing the square or factoring or something like that. So let's write down that A is equal to, again, this is the coefficient for x squared, that's going to be 9. And then we'll say B is equal to, in this case, again, it's negative 3. And we'll say C is equal to, in this case, is going to be negative 10. All right, let's grab this and let's paste this in here. I've already pre-written the quadratic formula. Again, you can pause the video and just write this down on your own, or you can just follow along with me in the video. It's really up to you. And basically, we're just going to plug in. It's very easy to make a simple mistake with this, so just really, really pay attention when you plug these things in. So we're going to say that x is equal to, here's the first place where you can make a mistake. This negative right here throws so many people off, it's not even funny. You want to write the negative first. Then you want to plug in for B. So what is B? B is negative 3. So plug in a negative 3 there. What I always do is wrap my B in parentheses just so I don't make a sign mistake. So I have the negative of negative 3, which is going to end up being positive 3. You can see how easy it is to just put negative 3 there because there's a negative out in front and get the wrong answer. Okay, so that's very easy to do. So then we'll put plus or minus the square root of, now we have B squared. So whatever B is, wrap it in parentheses and square it. So I'm going to wrap negative 3 in parentheses, both the negative and the 3, and I'm going to square that. Then minus 4 times A is going to be 9. Then times C is going to be negative 10. Let's just drag this over here. And then I'm going to slide down. I just need 2 times A. So what is A? A is going to be 9, so 2 times 9. So x is equal to, the negative of negative 3 is positive 3. Then plus or minus the square root of, so negative 3 squared is going to be 9. Then you have a negative and another negative. So just treat this as plus Negative times negative is positive, so forget about the signs now. 4 times 9 is 36, and 36 times 10 is 360. So basically you would have 9 plus 360, which is 369. So this is 369. Then this is going to be over 2 times 9, which is going to be 18. So here's where we just have to do a lot of simplifying. Most of us don't work with 369 very often, so we don't know if it's a perfect square or not. So I would just start by looking at my divisibility rules and thinking about how can I break this number down to see if I can simplify this any further. Well, I know that 3 plus 6 is 9, and 9 plus 9 is 18. So 18 is divisible by 9, so 369 will be divisible by 9 as well. So I could write this as 41 times 9. So let's say this is 41 times 9, and we know that 9 is a perfect square. So let's say this is x is equal to 3 plus or minus, the square root of 9 would be 3. So we'll say 3 times the square root of 41, and this would be over 18. Now, we're not done because we can simplify a little bit more. Notice that you have a 3 here and a 3 here, and you have an 18 down here. So here's where your factoring comes into play. You don't want to just go through and cancel stuff, just eyeballing it. That's where you can make another simple mistake. You want to pull it out or factor it out first and then cancel with the denominator. So we'll say x is equal to, let me factor out a 3. So that gives me 1 plus or minus. You could put a 1 here for clarity, times the square root of 41. It's not necessary, but you can just put it there. Then over, let's break 18 up into 3 times 6. And then from here, let's cancel this with this. And so what we get is x is equal to, let's say 1 plus or minus, let's just say the square root of 41, and this is all over 6. So this would be my answer. Okay, let's look at problem number 2. We'll go a little bit faster on this one. So we have negative x squared minus 5x is equal to negative 4x squared plus 8. So again, the first thing you want to do is put this into standard form. So the ax squared plus bx plus c equals 0. So let's add 4x squared to both sides of the equation. Let's subtract 8 away from each side of the equation. And just remember, all this canceled away, so we want to put a 0 there. Don't leave it blank. So on the left-hand side, negative x squared plus 4x squared would give me 3x squared. Then you have minus 5x, and then you have minus 8, and this equals 0. So let's record our values for a, b, and c now. So what is a? It's the coefficient for x squared. So a is equal to 3. What is b? It's the coefficient for x. So again, if it's a minus sign there, if you have minus a positive number, you're going to take it as a negative 5. If this is confusing, just put plus negative 5 so you don't get lost. So this is negative 5. And then this one is minus 8. So I'm going to take this c here, my constant, as negative 8. Again, there's lots of tricks to stop yourself from making a silly mistake. You can always go plus negative if you want. And if you need to, you can just keep writing the ax squared. So ax squared plus bx plus c equals 0 so that you can match things up. So a is 3, b is negative 5, c is negative 8, whatever you need to do to make sure you don't make a simple mistake. So let's grab this guy. And again, all we're going to do is just plug in. So we're going to have x is equal to the negative of b. Again, I told you before, this is easy to make a mistake. B is negative 5, just wrap it in parentheses. So the negative of negative 5 plus or minus the square root of b squared. What is b squared? Negative 5, wrap that in parentheses and square it. Then minus 4 times a is 3, times c is negative 8. Okay, this is going to be all over the 2 times a. So a is 3, so 2 times 3 would be 6. So you could write 6 if you want, or you put 2 times 3. It's really up to you. So in the next step, I'm just going to simplify as much as I can. So let's say this is x is equal to, the negative of negative 5 is just 5. Then plus or minus the square root of negative 5 being squared is going to be 25. Then again, you have a negative and a negative. You can always write this as plus negative if that's confusing, but you have a negative times a negative, so I know this is going to be positive. So let me just put a plus. So now I can just work with the absolute values. 4 times 3 is 12. 12 times 8 is going to be 96, and 25 plus 96 is going to be 121. So this is 121, and this is all over 6. So now what we'll have is x is equal to 5 plus or minus, the square root of 121 is 11. So let's put 11, and this is over 6. So if you get something like this, you have to go through and grab both solutions. What you'll need to do is say x is equal to 5 plus 11 over 6, or x is equal to 5 minus 11 over 6. So for this one on the left, let's say that x is equal to 5 plus 11 is going to give me 16. So we would have 16 over 6. And 16 over 6, they're both divisible by 2. 16 divided by 2 is 8. And then 6 divided by 2 is going to give me 3. So this is 8 thirds. Then or 5 minus 11 is negative 6. So negative 6 over 6 would be negative 1. So let's say x is equal to negative 1. So x could be equal to 8/3, or x could be equal to negative 1. All right, let's take a look at another one. So here we have problem 3. We have 3x squared minus 9x minus 26 is equal to negative 7 minus 6x squared. Okay, so again, I just want to get this in the format of ax squared plus bx plus c equals 0. So let's add 6x squared to both sides of the equation. Let's put that over there, and let's cancel this away. Let's add 7 to both sides of the equation, and let's cancel this away. Remember, this is going to be a big fat 0 because everything is canceled. And so on the left-hand side now, 3x squared plus 6x squared would be 9x squared. Then you have minus 9x. Negative 26 plus 7 would give me negative 19, so minus 19, and this equals 0. Okay, so once again, I'm just going to record my values for a, b, and c. If it helps, we can just keep writing ax squared plus bx plus c equals 0. Additionally, if the signs are messing with you, you can always put plus negative and plus negative, just so it's crystal clear what you're doing. So again, a is going to be 9, b is going to be negative 9, and c is going to be negative 19. So a is equal to 9, b is equal to negative 9, and c is equal to negative 19. Let's grab this. All right, so x is equal to, we have negative b. So put a negative out in front, and then b is negative 9. So let's put that in there. And then plus or minus the square root of, we have b squared. So b is negative 9. Wrap that in parentheses and square it. Then minus 4 times a is 9. Then times c is negative 19. Okay, let's extend that a little bit. Let's put this over 2a. So a is 9. 2 times 9, you can just write 18 here and be done with it. And now let's just simplify as much as we can. Let's say x is equal to, the negative of negative 9 is positive 9. Then plus or minus the square root of negative 9 squared is 81. And then negative times negative. Again, if you see this, just put plus a negative there like this, so this is clear. You have a negative times a negative here, so you know the answer is going to be positive. So now you can just go 4 times 9 is 36. 36 times 19, that's going to be 684. So you have 81 plus 684, and 81 plus 684 is going to be 765. So 765. Okay, this is all over 18. So I see it ends in a 5, so I know at minimum it's divisible by 5. So I would start by saying, what is 765 divided by 5 on my calculator? Well, if you do that, you're going to get a result of 153. So let's just do this off to the side. So 765, right now we would know that it's 5 times 153. Well, 153, we have 1 plus 5 is 6, 6 plus 3 is 9. So I know that's divisible by 9. So that would be 17 times 9. So this is times 17 times 9. So 9 is a perfect square. So really what I'd want to do, let's write this as 5 times 17, which is 85 times 9 like this. And the square root of 9 is 3, so we can simplify like that. Okay, so let's say x is equal to, we'll have 9 plus or minus. Again, square root of 9 is 3, so let's put a 3 there, times the square root of 85. Can't do anything with that because it's 5 times 17. And then over 18. Now, you're going to have a factor of 3 there. 9 is 3 times 3. You have a 3 there, and 18, you have a factor of 3 there, right? It's 3 times 6. So let's come down here, and let's do a little factoring. So we're going to go x is equal to, I'm going to write 3 times the quantity. This would be a 3 plus or minus. Again, you could put a 1 there for clarity, or you can leave it off. It's up to you. Times the square root of 85. Close that down. This would be over 3 times 6. All right, let's cancel this with this. So that's gone. So let's report our answer as x is equal to, we'll have 3 plus or minus. You don't have to put the 1 there. We'll just put the square root of 85. Again, if you want to write that, that's up to you. It doesn't change the answer. Then this will be over 6. So this would be our simplified answer. Okay, let's look at problem number 4 now. So we have 4x squared minus 10x minus 53 is equal to negative 3. All right, so the first thing I'm going to do is just add 3 to both sides of the equation. This will cancel and become 0. So my left-hand side is 4x squared minus 10x. We'll have minus 50, and this is equal to 0. All right, so something you can do, and this is not necessary, but something you can do, if you want to work with smaller numbers, let's say you're not working with a calculator, you're working with this by hand, you can divide everything here by 2. Notice that you have an even number, an even number, an even number, and when you divide 0 by something that's not 0, you always get 0. So I am legally allowed to divide both sides of an equation by the same non-zero number, and I won't change the solution set. So I can divide this by 2, this by 2, this by 2, and this by 2. Now I just want to note that you don't have to do this. If you work with the original form of this equation, you get the exact same answer. And if you don't believe me, when we finish, pause the video, go back and try these original numbers in the quadratic formula. You see you get the same solution. So what we're going to have is 2x squared minus 5x minus 25, and this equals 0. And I do this a lot because sometimes I don't have a calculator handy. And if you're doing the calculations by hand, then smaller numbers will help. Again, if you're using a calculator, then who cares? You can punch whatever you want in there and it'll figure it out for you. So my values for a, b, and c, let's say this is ax squared plus bx plus c is equal to 0. So again, my a is 2, my b is going to be negative 5, and my c is going to be negative 25. Okay, so let's write that out so we can copy it. So a equals 2, b equals negative 5, and c equals negative 25. Okay, so again, just plugging into the formula. So we have x is equal to negative, and then for b it's negative 5, and then plus or minus the square root of, you have negative 5 wrapped in parentheses being squared, then minus 4 times a is 2, then times c is negative 25. Let's extend that a little bit, and let's put this over. Let me slide this down just a little bit, and it didn't catch that, so let's just extend this again. My a here is 2, so 2 times 2 would be 4. Okay, so let's simplify. So x is equal to, the negative of negative 5 is 5, then plus or minus the square root of, negative 5 being squared is 25. Again, if this is a negative and this is a negative, you can always put plus negative so that's clear. Negative times negative is positive, so just work with the absolute values. I'm just going to put a plus here. So 4 times 2 is 8, 8 times 25 is 200. So this would be 225. So this is 225. Okay, let's put this over 4. Now the square root of 225 is going to be 15. Let's say x is equal to 5 plus or minus 15 over 4. So just like we saw previously, if we get something that sets up this way, we have to go through and set up both equations. We can't just leave this as our answer. So we would say x is equal to 5 plus 15 over 4. Then or x is equal to 5 minus 15 over 4. All right, so on the left, we'll say x is equal to 5 plus 15 is 20. 20 divided by 4 is 5. Then or over here on the right, we would have x is equal to 5 minus 15 is negative 10. You'd have negative 10 over 4. So let's write x is equal to negative 10 over 4. Each is going to be divisible by 2. 10 divided by 2 is going to be 5. 4 divided by 2 is going to be 2. So the answer here is that x can be 5 or x can be equal to negative 5 halves. All right, let's take a look at question number 5 now. So we have 5x squared minus 10x minus 19 is equal to 1. So again, all I'm going to do here is just subtract 1 away from each side of the equation. And so this would cancel and become 0. So on the left-hand side, we're going to have 5x squared minus 10x. Negative 19 minus 1 would be negative 20, so let's put minus 20. And we'll say this is equal to 0. Okay, so again, we're just recording the values for a, b, and c. So this is ax squared plus bx plus c is equal to 0. So once again, you can keep these values like this, or if you want, you notice that everything's divisible by 5. So you could divide everything by 5 and make the numbers smaller. Again, it's up to you. So you could divide by 5 here, 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 and here. Completely legal. Let's move this down. And let's say this is x squared. We'll have minus 2x minus 4 is equal to 0. So a is going to be 1, right? You can put a 1 there to make that clear. B is going to be negative 2. Again, you can put plus negative 2 to make that clear. And c is going to be negative 4. So you can put plus negative 4 to make that clear. Let me actually write this down so we can copy it. So a is equal to 1. We have b is equal to negative 2. And then we have c is equal to negative 4. Okay, so I'm just going to plug in. So we'll have x is equal to the negative of b. So the negative of negative 2. Then plus or minus the square root of b squared. So it would be negative 2 being squared. Then minus 4 times a is 1. Then times c is going to be negative 4. So again, you have negative times negative. So you can put a plus negative there just to make that clear. But when you multiply here, you're just going to work with absolute values. So this will be over 2 times a, and a is 1, so just put 2 down there. Let's clean up. So we have x is equal to, the negative of negative 2 is 2. Then plus or minus the square root of negative 2 being squared is going to be 4. And then again, This is negative. This is negative. Like I said previously, you're going to end up with a positive. So just say 4 times 1 times 4. 4 times 4 is 16. So basically it's 4 plus 16 or 20. All right, so let's just write 20 down here. All right, then this is going to be over 2. So we can simplify this a little bit more. Let's say this is x is equal to 2 plus or minus. For the square root of 20, remember 20, you could really break this up and say this is 4 times 5, and the square root of 4 is going to be 2. So you can say this is 2 times the square root of 5 like this, and then over 2. So I think we can see that we can cancel a common factor of 2, but again, to keep from making a silly mistake, you want to take the time to factor this out. So we'll have x is equal to, again, factoring out a 2. So inside the parentheses, we'll have 1 plus or minus. Again, you could put a 1 there for clarity, or you can skip it. You could just put the square root of 5, and then this is over 2. So this right here is going to cancel with this. And so what I'm left with is going to be x is equal to 1 plus or minus the square root of 5. Okay, let's look at problem number 6. So we have negative 4x squared plus 9x plus 2 is equal to x. Let's subtract x away from each side of the equation. Let's cancel this away and put 0. So let's say we have negative 4x squared. 9x minus x would be 8x. So let's say plus 8x. Then let's say plus 2, and this equals 0. Let me make this x a little bit cleaner. And again, we're just going to write out the ax squared plus bx plus c equals 0 and just match things up. So now your a is negative 4. So negative 4. B is going to be 8. C is going to be 2. So let's come down here and write that down. So a is equal to negative 4. B is equal to positive 8. And c is equal to 2. Let's grab this. So let's go x is equal to the negative of b. So b is positive here. So this is just negative 8. Again, to never make a mistake, just wrap whatever it is inside of parentheses. If you do that, it will always guard against you making mistakes. So then plus or minus the square root of b squared. Again, I'm just going to wrap this in parentheses and square it. Then minus 4 times a is negative 4. Then times c is 2. Okay, so that's set up. Let's put this over. You have 2 times a. Again, a is negative 4. 2 times negative 4 is negative 8. All right, let's clean up. So x is equal to, this is just negative 8, and then plus or minus the square root of, if you look at 8 squared, that's 64, and then you have negative times negative. So let's put a plus negative there so that's clear. So negative 4 times negative 4 is positive 16, and positive 16 times 2 is positive 32. So let's put plus 32 like this, and this will be over negative 8. What is 64 plus 32? Well, that's going to give me 96, so let's put 96 here. All right, so the square root of 96 can be simplified. Let's write 96 as 6 times 16. So we'll say x is equal to negative 8, then plus or minus, the square root of 16 is 4. So let's put a 4 out here, then times the square root of 6, and this will be over negative 8. So let me make this 8 a little bit better. You'll notice that you have a common factor of 4, right? So you have negative 8, forget about the fact that's negative. You have 8 there, so that's 4 times 2. You have a 4 there, and then you have, forget about the fact that's negative, you have an 8 there, so it's 4 times 2. So you can do this multiple ways. What I would do actually is I would factor out a negative 4. So I think that would be a little bit cleaner. So I would say x is equal to, I'm going to pull a negative 4 out. So from here, I'm pulling out the negative and I'm pulling out a 4. So that's going to leave me with a positive 2, right? Negative 4 times 2 would get me back to negative 8. Then from here, this is a bit strange. This is plus or minus. So this pulling out of a negative really doesn't affect it because you still have a plus or minus. So just think about it as if I'm pulling out a 4. So you could put plus or minus. So then you could put the 1 there. Let me just put it for clarity. Then times the square root of 6. Of course, you can leave the 1 off. It's really up to you. And then this is over. For negative 8, let's write this as negative 4 times 2 like this. And then let's cancel this negative 4 with this negative 4. And let's report our answer as x is equal to, we'll have 2 plus or minus. Again, you don't need the 1 there. We'll just say the square root of 6 over 2. Okay, let's look at problem number 7 now. So we have negative 7x squared minus 5x minus 3. This is set equal to negative 8 minus 9x squared. All right, so let's just add 8 to both sides of the equation. And let's also add 9x squared to both sides of the equation. And let's cancel this away and cancel this away. Okay, so I'm going to put a big fat 0 there. On the left-hand side, I'm going to have negative 7x squared plus 9x squared. That's 2x squared. So 2x squared. Then I'll have my minus 5x. Negative 3 plus 8 is going to be plus 5, and this equals 0. Okay, so again, I'm just going to record the values for a, b, and c. And so let's just write this ax squared plus bx plus c equals 0. Again, to make this clear, I'll just put plus -5 here, just so nobody's lost. And then we'll take the value for A, which is going to be 2, B, which is -5, and C, which is 5. So A is equal to 2, B is equal to -5, and then C is equal to +5. Okay, so again, we're just going to plug in. So X is equal to, we have the negative of B. So the negative of -5, and then plus or minus the square root of, for B squared, we have -5 being squared. Again, make sure you wrap that in parentheses. Then minus 4 times A is 2, then times C is going to be 5. Let's slide that down, and let's put this over. Let me slide this down just a little bit so it fits better. And then for 2A, A is 2, so 2 times 2 would be 4. Okay, so let's clean up. So X is equal to, the negative of -5 is 5, then plus or minus the square root of, -5 being squared is 25, and then this is minus, there's only one negative, so you can put this as plus -4 like this if that's more clear. But basically, you know you're going to have a negative. You just put a minus out in front if you want. 4 times 2 is 8, 8 times 5 is 40. And so 25 minus 40 is going to be -15. So we know we're going to have a solution that's going to be a complex solution, or you could say a non-real complex solution if you wanted to be more specific, because the imaginary unit I is going to be involved. So then this is over. We're just going to have 4. So thinking about -15, the negative we know we can figure out with the I, the imaginary unit, but 15 is 5 times 3, so I really can't do anything else with that part. So I'm just going to say that X is equal to 5 plus or minus, again, the square root of -1, we consider that to be I, the imaginary unit. So let's put I, and then times the square root of 15, and then this is over 4. So this would be my answer. All right, let's take a look at problem number 8. We have -10x squared minus 4x plus 3 is equal to 6. All right, so I'm just going to subtract 6 away from each side of the equation. That'll cancel and be 0. So we're going to have -10x squared, then minus 4x. 3 minus 6 is going to be -3, and then this equals 0. Okay, so again, just record the values for A, B, and C. So what we'll have here, again, this is ax squared plus bx plus c equals 0. Let's put plus negative here and plus negative here to make that clear. And so A is going to be -10. So that's my A. So let's put A is equal to -10. And then B is going to be -4. So let's put B is equal to -4. And then C is this -3. So C equals -3. So let's grab this and let's just plug in. So we're going to have X is equal to, again, the negative of B. So negative, and then B is -4. Always wrap it in parentheses and you'll never make a mistake. So plus or minus the square root of, again, B is -4. Wrap it in parentheses. We're going to square it. And then minus, we have 4 times A is -10, and then times C is -3. So here, let me put plus negative here. You're going to have 3 negatives, so this is going to be a minus in the end, right? It's going to be a negative result. So this will be over 2 times A is -10, so that would be -20. So let's put that down there. So we'll have X is equal to, the negative of -4 is +4, then plus or minus the square root of, -4 being squared is 16. We already know this is a minus here, right? The result of this is negative, so just multiply with the absolute values. Let's do 4 times 3 first. That's 12. And then 12 times 10 would be 120. It's a little bit easier for me to do it that way. 16 minus 120, that's going to be -104. So let's write -104. Then this is over -20. All right, so 104, we don't work with that very often, but you would notice that this is 4 more than 100. And you know that 100 is basically going to be 25 times 4. So this is going to be 26 times 4, right? So if you think about this is 26 times 4, let me write 104 like this. And 26 is 13 times 2, so you're not going to get anything else out of that. But you can pull the square root of 4 out. So let's write this as -1 times 26 times 4. From here, let's say that X is equal to 4 plus or minus, again, the square root of -1 is I, the imaginary unit. And then the square root of 4 is 2. Actually, let me put this out in front. So 2i like this. And then times the square root of 26. We can't do anything with that. And this would be over -20. Now, we're not done because, as you can see, we have a common factor of 2. Right? If you look at 4, 4 is 2 times 2. You have a 2 there. And -20 divided by 2 would be -10. Okay, so what I'm going to do is say that we have X is equal to, I'm going to pull a 2 out, so let's factor that out. We would have 2 plus or minus I times the square root of 26, and this would be over. Let's write this as 2 times -10. Let's cancel this 2 with this 2. We'll say X is equal to 2 plus or minus I times the square root of 26 over -10. Now, you can leave your answer like this, but most teachers would prefer that you put this negative out in front. So you could also write it as x is equal to. You could basically say, remember, if a fraction has a denominator that's negative, you could also make the denominator positive and the numerator negative. So in other words, I could multiply -1 times the numerator of 2 plus or minus I times the square root of 26, and this would be over positive 10. Okay, so that's allowed. Remember, if you have negative a over b, this is the same as a over negative b. That's really all I did. So you could move this to a -2 plus or minus I times the square root of 26 over 10, so that's fine. Or you could just put the negative out in front like this. So whatever you want to do, if you want to leave your answer like this, it's fine. If you want to put it like this, it's fine. Or if you want to put the negative in front of the 2, it's fine. Remember, this plus or minus here, it's not going to affect it because you have both of them. All right, let's take a look at problem number 9. So we have 4x squared minus 7 minus 5x is equal to -5x. So again, when we see something where we have the same thing on each side of an equation, we can just get rid of it. So let's add 5x to both sides of the equation. Let's cancel it away from here and here. Let's put a 0 here because there's nothing left. We don't want to leave it blank. So on the left-hand side, we have 4x squared minus 7, and this just equals 0. So you might notice that we're missing the bx part. So what are we going to do? Well, we can still use our quadratic formula. We have the ax squared plus bx plus c equals 0. So I'm just going to write this as, we'll say 4x squared. And then since I don't have a bx here, I'm just going to put plus 0 as the coefficient for x. So 0x, and then you'll have minus 7, and this equals 0. Okay, so now we can see clearly that a is 4, b is 0, and c is -7. Again, you can always put plus -7 if you need to. That's really up to you. So let's say that we have a is 4, b is 0, and c is -7. Okay, so let's say we have x is equal to the negative of b. Again, b is 0. Just plug it in. I know it's going to go away, but just plug it in. Then we'll have plus or minus the square root of, you'll have 0 squared minus 4 times a, which is 4, times c, which is -7. And then this is over. We have 2a. Again, a is 4, so 2 times 4 is 8. So x is equal to, so we have -0, so that's just 0. Let's put plus or minus the square root of, 0 squared is just 0, so just forget about it. You basically have a negative times a negative here. That's going to be a positive. So let's just do 4 times 4, which is 16, then times 7, which is 112. But you probably don't want to multiply there because you're going to end up breaking it back up. Let's just put 16 times 7 like this. Again, because this was a negative and this was a negative, we end up with a positive. So let's put this over our 8 here. And then let's just simplify. We'll say x is equal to plus or minus. For the square root of 16, it's 4. So let's put the 4 out here, then times the square root of 7. And then this is over 8. And we know that basically 8 and 4 have a common factor of 4. So let's do some canceling here. And let's just say this would go away. This would be 1. And this divided by 4 would be 2. So let's report our answer as x is equal to plus or minus the square root of 7 over 2. All right, let's take a look at problem number 10 now. So very similar to problem number 9. We're going to have -3x squared minus 2 plus 6x equals 6x. Again, if you see the same thing on each side of an equation, you can get rid of it. For completeness, let's subtract 6x away from each side of the equation. Let's show this is canceling. Let's show this is canceling, and let's put a 0 there. Okay, so let's write -3x squared. And then, again, we're missing a bx part, right? So you can just put plus 0x. You don't need to do this forever. In the future, you'll just know that b is 0. But for right now, while we're practicing, let's just put this for completeness. And then we'll have -2, and then this equals 0. So let's say here that this is your a, so ax squared, plus your b is going to be 0, so bx, and then plus your c is -2. So again, you can put plus -2 there for clarity, and this equals 0. Okay, so a is going to be -3, and b is going to be 0, and c is going to be -2. All right, so let's put x is equal to, you have -b, so b is 0, so let's just put it in there. I know it's not going to do anything, it's just going to go away, but let's put it in there for now. So then plus or minus the square root of b squared, so we're plugging in a 0, just put that in parentheses and square it, and then minus 4 times a is going to be -3, times c is going to be -2, and let's put this over your 2a is -3, so 2 times -3 is -6. Okay, let's put x is equal to, -0 is just 0, so forget about that. So you really just have plus or minus the square root of 0 squared. Forget about that. You have negative times negative times negative, so you know that's negative. Now you're going to have 4 times 3 times 2. So I would just stick with having, let's put negative 1 here times 4, and then times 6, and we'll put this over your negative 6. Okay, let's slide down here, and let's think about what we can simplify. So x is equal to, we'll have plus or minus, for the square root of negative 1, we know that's I. For the square root of 4, we know that's 2. And then for the square root of 6, I can't do anything with that, so we'll have plus or minus 2i times the square root of 6, and this is over negative 6. Now, what you can do is actually cancel a common factor of negative 2 away, but I think that's a bit confusing if I do it that way, so let me do it a longer way so nobody gets lost. So let me do this. Let me put negative 1 times 2 times 3 like this, and I think everybody knows that you can cancel this with this. Okay, so we're good to go there. Remember, this plus or minus is just shorthand notation. Okay, before I did the canceling, this top part was 2i times square root of 6, and then it was negative 2i times square root of 6. So in each of those cases, I can cancel a common factor of 2 between the numerator and the denominator. So we're good to go there. Okay, so what this is going to give me now is x is equal to plus or minus, we have I times the square root of 6 over negative 1 times 3. Now you can get rid of this negative 1, and the reason you can get rid of it, again, because you have this plus or minus here, when you think about fractions, let me just do this off to the side. We talked about this earlier, but if you have negative a over b, this is the same as a over negative b. So really, I could move this negative 1 up into the numerator, and because you have a plus or minus there, it's just going to stay plus or minus. So in other words, if I think about this in a little bit of a longer format, I just want to make sure nobody's confused. You would have x is equal to, let's say I broke this up and I said I times the square root of 6 over negative 3, and then or x is equal to, let's say negative I times the square root of 6 over negative 3. So in each case, again, let's say I move the negative from the denominator to the numerator. So now this would just be negative I times square root of 6 over 3. And then over here, if I move the negative to the numerator, well, it's the negative of the negative, which is positive. So you could delete it from here and here. It's like canceling a common factor of negative 1. So look at what you have here. You have x equals negative I times square root of 6 over 3, or x equals positive I times square root of 6 over 3. So you're back to the x is equal to plus or minus I times square root of 6 over 3. So if you're confused about why you're able to get rid of that negative, again, it's because of that plus or minus there that it doesn't really affect it. It affects it, but then when you put the solutions back together in this more compact form, you're right back to what you had. So x equals plus or minus I times square root of 6 over 3. All right, let's take a look at our practice test. We're told to solve each equation. All right, so for problem number 1, we're looking at 5x to the 4th power plus 25x squared is equal to negative 30. And the first thing I'll do is just add 30 to both sides of the equation, cancel that away and put a 0. And so I'll say this is 5x to the 4th power plus you have 25x squared, then plus 30, and this equals 0. So the idea here is that this highest exponent here, which is 4, is double that of the lowest exponent, which is 2. So again, this will be quadratic in form. If you think about a normal quadratic equation, it's ax squared plus bx plus c equals 0. So notice that this exponent is a 1 and this exponent is a 2. So the highest exponent, the 2, is double that of the 1. Okay, so you want to see this pattern and then make a substitution. But before I do that, I want to make this equation a little bit simpler. Some of you will have noticed that everything here is divisible by 5. So let's divide everything here by 5 just so we're working with smaller numbers. It's just going to make everything a little bit easier. And remember, this is legal because we can always divide both sides of the equation by the same non-zero number and not change the solution set. All right, so 5 over 5 is 1, so this is x to the 4th power, plus 25 divided by 5 is 5, so this is 5x squared. And then plus 30 divided by 5 is 6, and this equals 0 divided by 5 is 0. All right, so now that we have this set up, you could factor this straight away, but again, we're just going to use a substitution technique. So what I'll do is I'll let u be equal to x raised to the smaller power. So we're going to let u be equal to, in this case, it's going to be x squared. Okay, so we're just going to perform a substitution. Again, I can do this the long way. Some of you already know how to do this. You're just going to rewrite this using exponents. So you would say that x to the 4th power is x squared being squared. So you would just take this smaller guy here, x squared, and then square it. Okay, that's all you're going to do in each case. So then plus, you're going to take 5x squared plus 6, and this equals 0. And again, now we're going to make our substitution. So we'll say that this is u squared, because again, x squared is u. So where there's an x squared, so that's right here, and then right here, you're just going to plug in a u. So now I have u squared plus 5u plus 6, and this equals 0. So now I have a quadratic that I can solve. And I'm just going to solve this using factoring. So I'm going to put a u here, and I'm going to put a u here. And what I'll do is say I need two integers that sum to 5 and give me a product of 6. Obviously, that's going to be 2 and 3. So plus 2 and then plus 3. And then we can just solve this using the zero product property. So we'll say that u plus 2 is equal to 0. Or we'll also have u plus 3 is equal to 0. And we'll just subtract 2 away from each side of the equation here. Cancel that away. We'll have u is equal to negative 2. Then over here, we'll subtract 3 away from each side of the equation. Cancel that away. We'll have u is equal to negative 3. Now, a common mistake is for students to stop at this point and report this as your answer. But remember, you made a substitution. You're trying to solve for x. Okay, so that's the goal. So what we have to do is substitute again. Remember, we let u be equal to x squared. So what you would say here is that x squared, so x squared is equal to negative 2. Or you would say x squared is equal to negative 3. Again, I'm just plugging in x squared for u because originally we plugged in a u for x squared. Okay, so you're just going backwards. So you can solve this using the square root property. So if x squared equals k, then x equals the square root of k, or x equals the negative square root of k. So here I would just say x is equal to plus or minus the square root of negative 2, or you would have x is equal to plus or minus the square root of negative 3. And of course, you can make that simpler using your imaginary unit I. So let's say that what we'll have is x is equal to, we'll go plus or minus I times the square root of 2. I'll just put a comma here instead of or. This is a different notation you can use. It means the same in the end. We'll put plus or minus our I times the square root of 3. So basically, you have 4 solutions for that original equation. X could be I times square root of 2. X could be negative I times square root of 2. X could be I times square root of 3. Or X could be negative I times square root of 3. Okay, let's look at problem number 2 now. So we have 3x to the 4th power is equal to 24x squared minus 21. So what I'm going to do is put it to where the right side is 0. So let's use a few steps to do this. Let's subtract 3x to the 4th power away from each side of the equation. I'll cancel this and put it as 0. Let me slide down here just a little bit. I'll put 0 is equal to, I'll put this out in front. So negative 3x to the 4th power, then plus 24x squared, then minus 21. If you watch my videos, then you know I like my variable or variables, whatever I'm working with, depending on the equation. I like them to be on the left. Okay, so I'm going to just switch this up. This is completely legal. I'll say negative 3x to the 4th power plus 24x squared minus 21 is equal to 0. Okay, now that I have it in the manner that I like, I want you to notice that everything here is divisible by 3, or also you could divide by negative 3. So let's divide everything here by negative 3. Again, completely legal, because I'm dividing both sides of the equation by the same non-zero number. So if I look at negative 3 over negative 3, that's obviously 1. So that's going to give me x to the 4th power. Then 24 divided by negative 3 is negative 8. Then times x squared. Then negative 21 over negative 3 is going to be positive 7. And this equals 0 divided by negative 3 is 0. Okay, so from here, a lot of you will just factor this right away and solve it. But I'm just going to use the little pattern. Again, if you notice that this exponent right here is a 2 and this one's a 4, well, this guy's quadratic in form, right? This highest exponent is double that of the smallest. So let's let u be equal to x raised to that smaller power. So in this case, it's x squared. And using the rules of exponents, again, you can rewrite this and say this is x squared squared minus 8x squared plus 7 is equal to 0. And again, wherever there's an x squared, you're just going to plug in a u. So here and then also here. And what I'll have here is u squared minus 8u plus 7 is equal to 0. So again, another easy one that we can solve using factoring. And so let's set this up. So I'm going to put a u here and a u here. So give me two integers whose sum is negative 8 and whose product is positive 7. So that's going to be negative 7 and negative 1. So let's put minus 7 here and minus 1 here. And again, using the zero product property, I can just say u minus 7 equals 0, or I could say u minus 1 equals 0. From here, I would add 7 to both sides of the equation. This cancels. You get u equals 7. And then over here, let's add 1 to both sides of the equation. This cancels. So let's put or u is equal to 1. Now again, you're not done. The most common mistake here is for students to report their answer as u equals 7 or u equals 1. We need to solve for x. Remember, we let u be equal to x squared, so we have to substitute again. So now we're going to say, since u equals x squared, that x squared is equal to 7, or x squared is equal to 1. Let me make this equal sign a little bit better. So again, you can solve this just using your square root property. Again, if x squared equals k, then x equals plus or minus the square root of k. So here, x squared equals 7, so x is equal to plus or minus the square root of 7. Then we could put or. Over here, if x squared equals 1, then x is equal to plus or minus the square root of 1. We know the square root of 1 is just 1, so you could just put plus or minus 1. And again, if you wanted to make this more compact, you could say x is equal to plus or minus the square root of 7, comma, plus or minus 1. So again, 4 solutions. You have x could be square root of 7, negative square root of 7, 1, or negative 1. Okay, let's look at problem number 3. So once again, we have something that's similar to problems 1 and 2. So we have 2x to the 4th power plus 20x squared plus 10 is equal to negative 2x squared minus 10. So the first thing I'll do here is add 2x squared to both sides of the equation. Just like that. Let's cancel this and put 0. Let's add 10 to both sides of the equation. Let's cancel this and put 0. And really you only need 1 0 here, so let me just put one big fat 0 there. And then on the left-hand side, we'll just say that we have 2x to the 4th power. Then plus 20x squared plus 2x squared would be 22x squared. 10 plus 10 would be 20, so plus 20, and this equals 0. All right, so you might notice again that you could divide everything here by 2. So divide this by 2, this by 2, this by 2, and this by 2. And so this would be 2 over 2 is 1, so x to the 4th power plus 22 divided by 2 is 11, so 11x squared. Then plus 20 divided by 2 is 10, and this equals 0 divided by 2 is 0. So again, you might want to just factor this as it is now, but I'm just going to use my substitution technique, and I'm going to rewrite this as x squared squared plus 11x squared plus 10 is equal to 0. And I'm just going to let u be equal to, again, x raised to the smaller power. So this is x squared. So everywhere that you see an x squared, so here and also here, you're going to replace that with a u. So coming back here, we're going to say that we have u squared plus 11u plus 10 is equal to 0. All right, let's slide down here. Again, another one we can just solve using factoring. So let's put this like this. Let's put a u here and a u here. So two integers that sum to 11 and give me a product of 10, well, that's going to be 10 and 1. So let's put plus 10 here and then plus 1 here. All right, so using my zero product property, so we have u plus 10 is equal to 0, or we have u plus 1 is equal to 0. So let's subtract 10 away from each side of the equation. This cancels. We'll have u is equal to negative 10. Then or, let's subtract 1 away from each side of the equation. This cancels. We'll have u is equal to negative 1. Okay, so again, we know that we let u be equal to x squared. So we're just going to substitute again. We'll say that x squared is equal to negative 10. Or we'll say x squared is equal to negative 1. For both of these, you can just solve them using the square root property. Again, if x squared equals k, then x equals plus or minus the square root of k. So if x squared equals negative 10, then x is equal to plus or minus the square root of negative 10. Let's just write that as I times the square root of 10. And then we'll put or. We'll say that if x squared is equal to negative 1, then x is equal to plus or minus the square root of negative 1 is just I, right? So we could just put plus or minus I. Okay, so let's maybe put this in a more compact form. Again, you might be used to seeing it like this. So x is equal to plus or minus I times square root of 10, and then comma plus or minus I. And again, this is 4 different solutions. Let me make this plus sign a little bit better. So you have I times square root of 10, you have negative I times square root of 10, and then you have I, and then you have negative I. Okay, let's change up the problem type just a little bit. So now for problem 4, you see we have x minus 3, then minus 7 times the square root of x minus 3. This is equal to negative 10. If you're in a section like this, look for something that you can group together. So what I notice is you have x minus 3 here, and you have x minus 3 here. So I would start with that if you don't know what to do. I'm just going to group this together just by putting them inside of parentheses. So let's say this is x minus 3 like this, and then I'm going to put minus 7 times, instead of the square root of x minus 3, I'm going to use exponents here, just so this is more clear. I'm going to put the quantity x minus 3 raised to the power of a half. Remember, the square root is the same as raising to the 1/2 power. Then this is equal to negative 10. So now that I've written it like this, I think most of you can see that this is quadratic in form. Again, if you look at the smaller power here, it's a half. And the larger power here is 1. So 1 is double that of a half. So that's how you can use this pattern. So let me come down here real quick. And again, when you think about your substitution, you're going to let u be equal to this guy raised to the smaller power. So you could put the square root of x minus 3, or you could put x minus 3 raised to the 1/2 power. Again, it really doesn't matter. You could rewrite this again just using exponents so it's crystal clear what you need to do. So you would say this is x minus 3 raised to the 1/2 power, and then you're just going to square it like this. Again, power to power rule, this x minus 3 would stay the same. 1/2 times 2 would get you back to 1. Okay, so nothing is illegal there. Then minus 7 times this quantity x minus 3 raised to the 1/2 power, and this is equal to negative 10. And for what we want to do, let's just add 10 to both sides and say this is plus 10 equals 0, so that's more consistent. Let's move this down here real quick so it all fits. And now I'm just going to make a substitution. So this will be u, and this will be u. Okay, so let's slide down here. And let's say that we have u squared minus 7u plus 10 is equal to 0. Okay, so let's factor this. I'm going to put a u here and a u here. Two integers that sum to negative 7 and give me a product of 10. That's going to be negative 5 and negative 2. So using my zero product property, we have u minus 5 is equal to 0, or u minus 2 is equal to 0. So let's add 5 to both sides of the equation here. Cancel this. And we get u is equal to 5. Let's add 2 to both sides of the equation here. Let's cancel this. Let's put or. U is equal to 2. All right, so we let u be equal to, it was the square root of x minus 3, or you could say the quantity x minus 3 raised to the 1/2 power. Let's just put the square root of x minus 3 here. And so to get our final solutions here, what we're going to do is take and put the square root of x minus 3 everywhere we see a u. So in other words, there's a u here. So I'm going to put the square root of x minus 3, and this equals 5. Then or there's a u here. So I'm just going to put the square root of x minus 3 there, and this equals 2. So now we just want to solve these two equations for x. Now, in this course, we haven't talked about how to solve a square root equation yet. Most of you remember this from Algebra 1 or Algebra 2. Basically, to solve something like this, you're just going to square both sides. Just keep in mind that when you square both sides of an equation, you might get extraneous solutions or solutions that don't work in the original equation. We're going to talk more about this as we get into later sections in our course. All right, so if I square both sides here, let me just rewrite it. So the square root of x minus 3 is equal to 5. If I square this side and square this side, remember, the squaring is going to basically undo the square root operation, and you're left with a radicand. So you get x minus 3 is equal to 5 squared is 25. To solve this for x, just add 3 to both sides of the equation. This cancels, and you get x is equal to 28. So that's going to be one of our solutions. You can check this by plugging in here. 28 minus 3 is 25. The principal square root of 25 is 5, so that does work. This is a valid solution. Then over here, let me just put a little border. We would write the square root of x minus 3 is equal to 2. Again, we're going to square both sides here. And so this, let me show this is canceling. This is going to cancel with that. So the square root operation is being undone by the squaring. You're left with this x minus 3 again. So you get x minus 3 is equal to, now 2 squared is 4. We would add 3 to both sides of the equation. And so this cancels, and you're going to get x is equal to 7. Now, you should always check this in the original. So coming back up here, if you plug in a 7 for x, 7 minus 3 is 4. The principal square root of 4 is going to give you 2. So this one works out as well. So let me list these solutions here side by side. We'll just say that x is equal to 28 and then comma 7. Here I could put an or, so that's just two different ways to notate it. If you wanted to say x was 28 or x was 7, that's fine. Or you could just put x equals 28 and then comma 7. Just two ways to notate the same thing. Okay, let's look at a similar problem. So this is problem number 5. We have x plus 48 is equal to 14 times the square root of x. So let me start by subtracting 14 times the square root of x away from each side of the equation. I'll cancel that away and put a 0. So we'll say x minus 14 times the square root of x plus 48 is equal to 0. So again, the reason this is quadratic in form, if you'll notice that the square root of x, again, you can always rewrite that as x to the power of a half. So you have an exponent of a half and then an exponent of 1. So the larger exponent is double that of the smaller. So you can use this little pattern. We could say this is x, and I'll go ahead and say this is to the 1/2 power, and then I'll say this is squared, minus 14 times x to the 1/2 power. And then we'll say plus, this is 48 equals 0. We're going to let u be equal to, again, x raised to that smaller power. So this is x to the 1/2 power. And so everywhere I see x to the 1/2 power, so for example here and also here, I'm just going to plug in a u. So I'm going to say this is u squared minus 14u plus 48 is equal to 0. Okay, so let's solve this guy using factoring. I'm just going to put some parentheses here and say this is u and this is u. So two integers that sum to negative 14 and give me a product of positive 48. That's going to be negative 6 and negative 8. So negative 6 and negative 8. So we have u minus 6 equals 0 or u minus 8 equals 0. Okay, so from here, let's add 6 to both sides of the equation. Cancel that. We get u is equal to 6. And then or over here, let's add 8 to both sides of the equation. Cancel that. We'll get u is equal to 8. Okay, so this is a little bit easier to solve than the last one. We have fewer steps. Basically, we let u be equal to x to the power of a half or the square root of x. So again, we let u be equal to the square root of x. So all we need to do is everywhere there's a u, plug in square root of x. So you'd have the square root of x is equal to 6, or you'd have the square root of x is equal to 8. As I just mentioned, if you want to solve this type of equation, you could just square both sides, right? So in this case, if I square both sides, let me rewrite this. So the square root of x, I'm going to square this, is equal to 6 being squared. So x is going to be equal to 36. Again, when you think about this, the squaring operation cancels the square root operation, and you're left with a radicand. So you have x is equal to 6 squared is 36. If you plug a 36 back in here, the principal square root of 36 is 6, so this does work as a solution. Then over here, let's just put a little border. If I square both sides of this guy, so let's square this, and let's square this. Again, this is going to cancel, and you're going to have or x is equal to 8 squared is 64. Again, plugging 64 in here, square root of 64, the principal square root of 64 is going to give you 8. So this does work as a solution as well. So you got x equals 36 or x equals 64. Let me just write it like this. So x equals 36 and then comma 64. All right, let's take a look at problem number 6 now. So a very similar setup. So we have x plus 16 is equal to 10 times the square root of x. So again, let's subtract 10 times the square root of x away from each side of the equation. Let's cancel this away and put 0. Let's say that we have x minus 10 times the square root of x, and then plus 16, and this equals 0. And once again, I am going to let u be equal to x to the power of a half. So let's first write this as x to the power of a half, and then let's square that. And then minus 10 times x raised to the power of a half, and then plus 16, and this equals 0. So I'm going to let u be equal to x to the power of a half, so I can make my substitution. And so you got it here and then also here. So I'm going to plug in a u in each case. So let's come back here and just say that this is u squared minus 10u plus 16 is equal to 0. So let's factor this. I'll say this is u and this is u. And then basically you need two integers whose sum is negative 10 and whose product is positive 16. So that's going to be negative 8 and negative 2. So let's put negative 8 here and negative 2 here. Okay, so we want to solve u minus 8 is equal to 0. Or u minus 2 is equal to 0. So for this one, let's add 8 to both sides of the equation, cancel that away, and say u is equal to 8. Then over here, let's add 2 to both sides of the equation, cancel that away, and we'll say u is equal to 2. So once again, we let u be equal to the square root of x, or x raised to the 1/2 power. So we let u be equal to x raised to the 1/2 power, or let's just put the square root of x. I think that's a little bit easier here. And again, all I want to do is just go back and substitute again. So everywhere I see a u, I'm going to plug in square root of x. So the square root of x is equal to 8. Then or, we have the square root of x, just plugging that in for u, is equal to 2. Okay, so coming down here, let's just square both sides. So let me rewrite this. So square root of x is equal to 8. Let me square this side and square this side. We know that this is going to be undone by this. And so we'll have this radicand, which is x, is equal to 8 squared is 64. Then over here, let me make a little border. I'll put the square root of x is equal to 2 like this. Square both sides. And what we're going to have is this canceling with this. And again, you're just going to have your radicand here of x, and this equals 2 squared. This kind of looks like 21. Let me make the parentheses a little bit better. So once again, 2 squared is going to give me 4. So checking these, the principal square root of 64 is 8, so that works. The principal square root of 4 is 2, so that works. So x is 64 or x is 4. Again, let me write it like this. So x equals 64, comma 4. All right, let's take a look at problem number 7 now. So what we have is 19x to the 2/3 power plus 34x to the 1/3 power plus 8. This is set equal to negative 2x to the 2/3 power. All right, so the first thing I'm going to do here is just add 2x to the 2/3 power to both sides of the equation so that this right-hand side is going to be 0. Let me slide down here just a little bit. And so what we'll have here is 19x to the 2/3 power plus 2x to the 2/3 power. That's going to give me 21x to the 2/3 power. Then plus you have 34x to the 1/3 power. Then plus 8, and this equals 0. So the reason this is going to be quadratic in form, again, look at x raised to the smaller power. Here, that smaller power is 1/3. Look at x raised to the larger power. Here, it's 2/3. So this 2/3 is double that of 1/3. Okay, so you can always write it using that little pattern. In other words, I could say this is 21. Let's go x raised to this smaller power, so to the 1/3 power. And then I'm going to raise this guy to the second power or square it. Again, power to power rule, 1/3 times 2 would get me back to 2/3. So I haven't done anything illegal. Then plus you have 34x to this 1/3 power. Let me make this 3 a little bit cleaner. Then plus you have 8, and this is set equal to 0. All right, so from here, I'm just going to let u be equal to, again, x raised to that smaller power. So x to the 1/3 power. And then I'm just going to plug in. So where do I have x raised to the 1/3 power? Here and also here. So I'm going to plug in a u there. So let's put that we have 21u squared plus we're going to have 34u and then plus 8, and this equals 0. Let me make this a little bit better. So we can actually solve this using factoring. Some of you will find this factoring to be a little bit more complex, so you might want to use the quadratic formula. It's really up to you. I think we can solve it using factoring. So let's set up our parentheses here. We know that this first guy is not going to be a given because 21 is not a prime number, right? It's 21 times 1 or it's 7 times 3. As I've told you in previous factoring videos, it's very unlikely that 21 times 1 will ever work. You might have to go to it. It might work, but it's very unlikely. So I would always start with 7 and 3. So let's go 7u and 3u and just go through the possibilities. And again, if it doesn't work out, then you can try 21 and 1. So now I want to think about this final guy here, which is 8. 8 is either 1 times 8 or 2 times 4. Now 1 and 8 is not going to work. If I put an 8 here, it's too big. Remember, you have a plus sign here, or really have all plus signs, so everything's going to be addition. You can already put in the plus signs here because you know that's going to be the case. But if you put an 8 here, 7 times 8 is 56. This is already too big. I'm trying to get a middle of 34, so that's not going to work. If you put the 8 here and the 1 here, well, now you have 24 plus 7, and that's 31, and you need 34. So this is out. That's not going to work. So what I need to do is go to 4 and 2. So if you put the 4 here and the 2 here, that's actually going to work. Because your outer here is going to be plus 28u, right? 7u times 4 would be 28u. Your inner here is going to be 2 times 3u or 6u. And 28u plus 6u is going to give me the 34u that I want in the middle. So this is how we can factor this guy. And so again, I can just solve this using the zero product property. Let me grab it real quick. And let's say we have 7u plus 2 is equal to 0. And then or we have 3u plus 4 is equal to 0. What we'll do from here is just subtract 2 away from each side of the equation. Cancel this away. We'll have 7u is equal to negative 2. Divide both sides of the equation by 7. And we'll say u is equal to negative 2/7. Okay, let me show this as canceling. Over here, let's subtract 4 away from each side of the equation. Cancel this away. We'll say 3u is equal to negative 4. Divide both sides of the equation by 3. Cancel this away. We'll put or u is equal to negative 4/3. So again, we let u be equal to x raised to the 1/3 power. Let's come down here and let's remind ourselves that we let u be equal to x to the power of 1/3. So what you're going to do is everywhere there's a u, you're going to replace it with x to the power of 1/3. So we would have x to the power of 1/3 is equal to negative 2/7. Then or x to the power of 1/3 is equal to negative 4/3. Let me make this a little bit better. Now remember, if you have x to the power of 1/3, it's like the cube root of x. So you could write it like that if that's more clear for you. So let me do this like this, the cube root of x. Let me do this like this over here as well. So the cube root of x. Now, what do I need to do to undo this cube root? I need to raise both sides to the third power, or I need to cube both sides. So in other words, if I have the cube root of x is equal to negative 2/7, then I can cube this side, and I can cube this side. And then what's going to happen is that this guy right here is going to cancel with this guy right here, and I'm left with my radicand. So I have x is equal to, you're going to cube -1, that's negative, cube 2, that's 8, and then cube 7, that's going to be 343. So you're going to have negative 8 over 343. Then or, over here I'm going to do the same thing. Let me put a little border here. I would have the cube root of x is equal to negative 4/3. Again, I'm going to cube both sides. And so this right here is going to cancel with this. And again, you just have your radicand. So what we'll have is x is equal to, negative being cubed is negative, 4 being cubed is 64, and 3 being cubed is 27. So you have x equals negative 8 over 343, or x is equal to negative 64 over 27. And again, just so we get used to the other notation, let's just write this as x is equal to negative 8 over 343. Let me make this 3 a little bit cleaner. And then I'll put a comma, and then negative 64 over 27. Okay, let's look at problem number 8. It's exactly the same setup as problem number 7. So we have 7x to the 2/3 power minus 38x to the 1/3 power minus 17 equals negative 5 plus 2x to the 1/3 power. So the idea here is I'm going to add 5 to both sides of the equation, and I'm going to subtract 2x to the 1/3 power away from each side of the equation. Let's cancel this right-hand side and just say it's 0. And so what we're going to have is 7x to the 2/3 power. We'll have negative 38 x to the 1/3 power minus 2x to the 1/3 power. That would be negative 40 x to the 1/3 power. And then negative 17 plus 5 is going to be negative 12, so minus 12, and this equals 0. Again, I'm going to make a simple substitution. I think you know at this point that u is going to be equal to x to the 1/3 power. But let's actually go through this in case anybody's still confused. So let's write this as 7x to the 1/3 power, and then I'm just going to square this, and then minus 40x to the 1/3 power, then minus 12 is equal to 0. Again, everywhere there's x to the 1/3 power, you're just going to plug in a u. So let me actually just write that out and say that we're going to let u be equal to this x to the 1/3 power. And so what we'll say is we have 7u squared minus 40u, and the minus 12 is equal to 0. Okay, so we're going to solve this using factoring. Again, if you want to use the quadratic formula because you find this a little bit too difficult to factor, that's really up to you. You'll get the same answer either way. So I'm just going to say this is 7u here and u here, because 7 is a prime number. And then basically I need to work this out. Now I know since this is a minus here, I'm going to need to subtract in terms of absolute values. And I'm trying to get to 40. Forget about the fact that it's negative. I'm trying to get to 40. So think about 12. You could do 1 and 12, but you know that's too big. So 7 times 12 is just way too big. That's not going to work. If you flip it around, it's actually going to be too small, right? So basically you would have 7 and 12. 12 minus 7, again, in terms of just doing everything in terms of absolute value, that's going to give you 5. So that doesn't work. So 1 and 12 is out. So the next one would be 2 and 6. Now it turns out you can make 2 and 6 work. If you put a 6 here and a 2 here, you have 7 times 6, which is 42, and 2 times 1, which is 2. 42 minus 2 would give you 40. Again, forget about the fact it's negative. You just need to work out the sign. So this one needs to be negative, and this one needs to be positive, so that you get a negative 42u, and then you get a positive 2u. And then if you add those two together, negative 42u plus 2u would give you negative 40u. Okay, so that's done. So what we would do from here is say that we have 7u plus 2 is equal to 0, or u minus 6 is equal to 0. And let's just solve these. They're very easy. So let's subtract 2 away from each side of the equation here. Cancel this. We have 7u is equal to negative 2. And let's divide both sides of the equation by 7. Cancel this away. And so we get u is equal to negative 2/7. Over here, let's add 6 to both sides of the equation. Cancel this away. And we'll say that u is equal to 6. So let's put or u is equal to 6. And again, you just need to make a simple back substitution. We originally let u be equal to x to the 1/3 power, or you could say it's the cube root of x. Whatever you want to do, it doesn't matter. So we'll say, and we'll just keep it in this format for this one. So we'll say that x to the 1/3 power is equal to negative 2/7, or x to the 1/3 power is equal to 6. And again, to solve this, we're just going to cube both sides. So let me rewrite this. So x to the 1/3 power is equal to negative 2/7. Again, I'm just going to cube both sides. And with this one, it's power to power rule. So 1/3 times 3 would be 1. So basically, you're just left with x. And this equals, if you cube a negative, you get a negative. Cube 2, you get 8. Cube 7, you get 343. So you get x equals negative 8 over 343. Let me slide this down a little bit. I'll put or. For this one, let me put a little border. We have x to the 1/3 power is equal to 6. Again, I'm just going to cube both sides of the equation. So again, power to power rule, 1/3 times 3 is 1. So this is x to the first power, just x. This equals 6 cubed is going to be 216. So these are our solutions. X equals negative 8 over 343, or x equals 216. All right, for the last two, it's a little bit of a factoring trick. So for problem number 9, we have x to the 4th power minus 2x squared plus 1 minus 12 is equal to the negative of x squared minus 1. So I'm going to actually group this like this, and I'm going to move this guy over here. So what I'm going to do is say I have x to the 4th power minus 2x squared plus 1, and then I'm going to actually move this over here by adding this whole guy over here. So plus, I'm going to have this x squared minus 1, and then I'm going to have this minus 12, and this equals 0. So I didn't do anything illegal. I added the same thing to both sides of the equation. I can add this whole quantity if I want. And you could do it individually and then group it back together, but I think this is just a little bit quicker. Okay, so now that we have this set up this way, the reason I grouped this together, if you notice, this right here can be factored into this guy being squared. Okay, so let's slide down here, and let's say that this would be x squared and then minus 1 quantity squared. Now, I know most of you will see that x squared minus 1 can be further factored. This could be written as x plus 1 times x minus 1 like this. But for the purposes of what we're trying to do, this is really not that helpful because I want something that's going to be squared here, and then I want something that's the same thing raised to the first power. So what I want to do is say this is plus, this is x squared minus 1 raised to the first power. Then I have minus 12, and then this equals 0. So looking at this guy right here, again, if I let u be equal to this, the guy raised to the smaller power, so let me put this as we're going to let u be equal to this quantity x squared minus 1, just raised to the first power. So let's make our little substitution. For my x squared minus 1, this quantity, I'm just going to replace that with u. So this will just be u squared. And then plus, again, I have x squared minus 1, this quantity. I'm going to put that as u. And then minus 12, and this equals 0. So let's put a u here, and let's put a u here. Let's put equals 0. And so I need two integers that sum to positive 1 and give me a product of negative 12. Well, that's going to be positive 4 and negative 3. So plus 4 and minus 3 here. So let's solve this. So we're going to say u plus 4 is equal to 0, or we'll say u minus 3 is equal to 0. Let's subtract 4 away from each side of the equation. I'll cancel that. We're going to get u is equal to negative 4. Then or, let's add 3 to both sides of the equation. Let's cancel that. We'll say u is equal to 3. Now again, we come back to this other page. We let u be equal to the quantity x squared minus 1. Let me write that so we remember. We let u be equal to the quantity x squared minus 1. So I'm just going to replace u with x squared minus 1. So I'm going to go x squared minus 1 is equal to negative 4. Then or, I'm going to say x squared minus 1 is equal to 3. So at this point, I'm just going to use my square root property to get an answer. The first thing you need to do is get x squared on the left by itself. So I'm just going to add 1 to both sides of the equation here. Cancel that, and we have x squared is equal to negative 4 plus 1 is negative 3. Again, if x squared equals k, then x equals plus or minus the square root of k. So here, x equals plus or minus the square root of negative 3. So I'm going to put I times the square root of 3 like that. And then over here, let's add 1 to both sides of the equation. Let's cancel that. We'll say x squared is equal to 4. So in this case, x would be equal to plus or minus the square root of 4. So that's plus or minus 2, right? The square root of 4 is 2. So again, you could write it this way. You could write it with the or. It's really whatever you want to do. I think this is more compact. So again, you have 4 solutions here. I times square root of 3, negative I times square root of 3. Then you have 2, and then you have negative 2. Okay, let's look at problem number 10. It's a similar setup to problem number 9. It's actually a little bit simpler though. So we have x squared plus 4x plus 4 is equal to negative 11 times the quantity x plus 2 plus 12. So again, if you see this in this section, you're expected to try to factor things. Again, if I see x plus 2 here, and then I'm eyeballing this and I'm saying, well, I know I can factor that. This is a perfect squared trinomial, right? This is x plus 2 quantity squared. Okay, and this is x plus 2 to the first power. So let me actually add 11 times the quantity x plus 2 to both sides of the equation. And let me subtract 12 away from both sides of the equation. Remember, because I added 11 times the quantity x plus 2 over here and added negative 12 over here, or subtracted 12 away, however you want to think about it, this side is canceled and it's 0. Okay, so it's important to put that there. So from here, I'm just going to make a simple substitution. I'm going to let u be equal to, again, your guy here raised to the smaller power. So this would be x plus 2, this quantity. And then I'm just going to replace it. So here and here, right? So I'm going to replace that with u. So let's say we have u squared plus 11u minus 12 is equal to 0. So let's factor this. We'll put a u here and a u here. Set that equal to 0. And so two integers that sum to 11 and give me a product of negative 12. So you would want to go positive 12 and negative 1. So plus 12 and minus 1. So from here, I'll go u plus 12 is equal to 0. Then or u minus 1 is equal to 0. Let's subtract 12 away from each side of the equation. Let's cancel this away and say u is equal to negative 12. Then over here, let's add 1 to both sides of the equation. And we'll say u is equal to 1. So I want you to recall that we let u be equal to this quantity x plus 2. So I'm just going to say for u, we have x plus 2 is equal to negative 12. Or we're going to have x plus 2 is equal to 1. So real simple to solve these. For this one on the left, let's subtract 2 away from each side of the equation. Cancel that. We'll have x is equal to negative 12 minus 2 is going to be negative 14. Then or, over here, let's subtract 2 away from each side. Cancel that. We'll have x is equal to 1 minus 2 is negative 1. So we get x is equal to negative 14. And I'll put a comma and negative 1. All right, let's take a look at our practice test. We're told to solve each word problem. For the first problem, we're told that Larry needs to wash a window in a building that is 8 feet from the ground. To avoid offense, he decides to rest the ladder against the building. For stability, Larry decides he should place the ladder 6 feet away from the building. How long of a ladder will Larry need? So the goal here is to figure out how long of a ladder will Larry need. Now, we worked an example that was very similar to this in the lesson. So if you saw that, then you know that this type of problem is solved using the Pythagorean theorem. It's actually pretty simple. What you might want to do is make a little drawing just to illustrate the situation. So I have that on the next page. And essentially, let's just go through it. Larry needs to wash a window in a building that is 8 feet from the ground. So let's go to the drawing. And you can see that where this guy is, where this window is starting here from the ground, that's going to be 8 feet. So I can draw this in here. Okay, and let's just say this is 8. That represents 8 feet. So that's the distance from here, from the ground to where that window is starting. Okay, what else are we told? It says to avoid offense, he decides to rest the ladder against the building. So coming back, that's why you see this ladder being angled here. It's to avoid this fence. And then it says, for stability, Larry decides he should place the ladder 6 feet away from the building. So if we think about this guy over here, where this ladder is resting on the ground, from that point right there, going to where the building is, we're told that's 6 feet. Okay, so let's go through and draw this one in. Okay, so let's put a 6 there for 6 feet. And you see that you're forming a right triangle. So let's put a right angle symbol in like that. And then what are we trying to figure out? Well, we know the length of this leg. We know the length of this leg. We're trying to figure out the length of the hypotenuse, which is the length of the ladder. So let me draw this one. And so this is what we're trying to figure out. So let's represent this with x. Now I'm going to go back and real quickly, so no one's lost, I want to write this out. We're going to let x be equal to exactly what we're trying to find. So the length of, we'll say Larry's. So Larry's ladder. And of course, since we're working with feet, this will be in feet. Okay, so we'll be specific there. All right, coming back, it's pretty easy to get a solution here. If we think about it, again, using the Pythagorean theorem, it's a squared plus b squared is equal to c squared. Well, I'm just going to take 6 squared plus 8 squared. So 6 squared plus 8 squared is going to be equal to, instead of my hypotenuse being c, now it's x. So it's just equal to x squared. So really, I just need to solve this equation. And so that's pretty easy to do. 6 squared is 36. 8 squared is 64. 36 plus 64 is going to be 100. So this is x squared equals 100. You can solve this using the square root property. If x squared equals k, then x equals plus or minus the square root of k. So here we can just say that x is going to equal plus or minus the square root of 100, and the square root of 100 is 10. So let's just put x equals plus or minus 10. Now, does it make sense for negative 10 to be an answer here? No, this ladder cannot be negative 10 feet long. That doesn't make any sense at all, so you throw it out. So we know that x here would be 10, right? That's the length of the ladder. And just checking that, you would just check that 6 squared, so this guy squared, plus 8 squared, so this guy squared, does equal 10 squared. And it does, right? 36 plus 64 does give you 100, so that checks out. So coming back here now, I'll just give an answer. And you can make a sentence. I'm just going to put 10 feet. So 10 feet. That's going to answer the question, how long of a ladder will Larry need? His ladder needs to be 10 feet in length. Okay, let's look at problem number 2 now. So 2 cars left an intersection at the same time. One of the cars traveled directly north, while the other car traveled directly east. 2 hours later, they ended up being exactly 203 miles apart from each other. If the car that traveled north traveled 7 miles less than the car that traveled east, how far did each car travel? So again, another problem that we're going to solve using the Pythagorean formula, and I just recommend drawing a little diagram. So I have one set up with all the labeling on the next page here, and basically you can see that these 2 cars leave from the same intersection. One, this red car is going to go east. It's going to end up here at the end of the 2 hours. The blue car is going to go north. It's going to end up here at the end of the 2 hours. So you see that we're just forming a right triangle, right? So the distance between where this car is and this car is at the end of the 2 hours is going to be 203 miles. So first off, let's let x be equal to the distance that this red car is going to travel, basically the eastbound car. Let me actually put this up here. I think we don't need to go to the next page. So let's go let x be equal to, and I'll just say the east, so the eastbound car. Now, specifically, we're told that the northbound car, or this blue car in this case, is going to travel 7 fewer miles in terms of the distance. So we can say then, x minus 7 is equal to, we'll just say that's going to be the distance for the northbound car. So I'll just put northbound car. Okay, and again, you could write this out further if you want for your notes. You could say the distance traveled for the eastbound car or the distance traveled for the northbound car. I'm just trying to keep it concise so we can fit it on the screen. All right, so how would you figure this out? Well, we know that from the Pythagorean formula, again, a squared plus b squared equals c squared. So in this case, we're going to have one leg is going to be a length of x, so it's x squared. Then plus the other one is the quantity x minus 7, so x minus 7 quantity squared. And this equals the length of the hypotenuse, or again, the distance from where this car is going to be and this car is going to be, that's 203. So 203 being squared. All right, let's grab this real quick and let's come to a fresh sheet so we can work this out. So we have x squared, nothing you can do with that for now. Plus, you would expand this. You can just use your formula. So the first guy squared is x squared, then minus 2 times this guy times this guy. 2 times 7 is 14, so this would be minus 14x. Then plus 7 being squared is 49. If you want at this point, you can go x squared plus x squared. That's going to be 2x squared. Let's just make this a little bit simpler. And this is going to be equal to 203 squared. If you punch that into your calculator, you're going to get 41,209. Okay, so what you can do here is just subtract this away from each side of the equation. So we'll have 2x squared minus 14x. And then if I subtract 41,209 away from 49, I'm going to get negative 41,160. And let's set this whole thing equal to 0. And for this one, I would not attempt to factor it. I would just use the quadratic formula. So we know that a is 2. We know that b is going to be negative 14. And we know that c is going to be negative 41,160. So this is definitely something you want to use a calculator for. So the quadratic formula is that x is equal to, we have the negative of b. So b is negative 14. So the negative of negative 14, then plus or minus the square root of, we have b squared. So that's negative 14 being squared. Let me slide this down so it all fits. Then we have minus 4 times a in this case is 2, and then times c. C is this gigantic number, so negative 41,160. Close that down. This is all over 2a. So a in this case is 2. 2 times 2 is 4. Okay, let's see if we can work this out. We're just going to punch this into our calculator. Negative 14 squared is going to be 196. I'm just going to erase this as I go and just put this as 196. I know that this is going to be a positive result because it's negative times negative. So let me put plus negative here so that's clear. So basically just work with the absolute values. 4 times 2 is 8. And then 8 times 41,160, that's going to be 329,280. So let's put plus 329,000 and then 280. So let's add 196 plus 329,280, and that's going to give us 329,476. So 329,476. And then if we punch this into our calculator and just take the square root, we're going to get 574. So I'm actually just going to erase this and put 574. So now it's pretty easy. The negative of negative 14 is just going to be positive 14. So you have two different scenarios to set up. One of them you can throw away because, again, this is a distance. So you would do x is equal to 14 plus 574, which is 588 divided by 4. And this is going to give you 147. Now, the other scenario where you have the minus here, don't worry about that, right? Because you can't have a negative distance, so you can throw that out. So 147 is what we get for x. Coming back up here, remember, x was the distance for the eastbound car. So that is 147. And then the northbound car traveled 7 miles less. So it would be 140 miles. So we'll just say the eastbound car, that guy is going to be 147 miles. So that's how far they traveled. And then for the northbound car, again, it traveled 7 miles less than the car that traveled east. So for this one, it's 140 miles. Okay, so checking this is pretty simple. We would just come back to our Pythagorean formula and think about, does 147 squared plus 140 squared equal 203 squared? You punch that into your calculator, you see that it works out. So again, just coming back up here, we can say our answer is correct. The eastbound car traveled 147 miles, while the northbound car traveled 140 miles. All right, let's take a look at problem number 3 now. So Jamie wants to buy a rug for a room that measures 18 feet wide by 22 feet long. Jamie wants to leave a uniform strip, this just means that the width is the same, of uncovered floor around the rug. After visiting the carpet store, she buys a rug with an area of 252 square feet. What are the dimensions of the rug? So what we'd like to figure out here is, what are the dimensions of the rug? So in other words, what's the length? What's the width? Now we are given some information that we can use to set up a little diagram. First off, we're told that this room has a measurement of 18 feet wide by 22 feet long. So if you're setting this up, you just want to draw yourself a little rectangle. And then for the length, you just want to notate that it's going to be 22 feet. Okay, so that's the length of this room. And then for the width, you want to notate that it's going to be 18 feet. So that's 18 feet. Okay, so we've got that down. Now, the key to understanding this problem is the fact that you have this uniform strip where the width is the same of uncovered floor around the rug. So going back to the diagram, that's this brown that's around the rug. You see that it's the same width everywhere. So the key here is just to let a variable like x be equal to that. So you can say that this width right here can be represented with x, and it's the same all the way around. That's what we mean by uniform. So let's just put this as x all the way around. So if you wanted to model the length of this rug, what you would do is you would take 22 feet, which is the length of the room. Let me put L here for length. So 22 for 22 feet, length of the room. You would want to subtract away this width right here, which is x, so minus x. And then you'd also want to subtract away that width right there, which is also x. So basically 22 minus 2x, that would represent your length of this rug. Then for the width, we're going to do something similar. So now it's going to be 18. So 18, and then you're going to subtract away x, and then you're going to subtract away x again. So 18 minus 2x. So we are told that the area of this rug is going to be 252 square feet. Well, area comes from length times width. So all I have to do is take 22 minus 2x, this quantity, multiplied by 18 minus 2x, this quantity, set it equal to 252. I'll solve that quadratic equation, and I'll be done. So let's grab this real quick, and let's set up our equation. So we would want the length, which is 22 minus 2x, times the width, which is 18 minus 2x. And we're going to set this equal to, again, 252. So let's do FOIL. 22 times 18 is going to give me 396. Then I'm going to have 22 times negative 2x. That's going to be negative 44x. Then negative 2x times 18 would be negative 36x. Then negative 2x times negative 2x would be plus 4x squared. This equals 252. So let's get this into standard form. I'm going to have 4x squared. Negative 44x minus 36x is going to be negative 80x. And then what I'm going to do is subtract 252 away from each side of the equation. That'll cancel over here and be 0. So 396 minus 252, that's going to give me 144. And then let's set this equal to 0. Now looking at this, these numbers are a little bit big, but you might notice that everything's divisible by 4. So that might help you out. You just divide everything here by 4 legally. So this would be x squared minus, this would be 20x, and then plus, this would be 36, and this equals 0. So at this point, you could solve it using factoring, or you could use the quadratic formula. Again, whatever you want to do. I'm just going to factor this one. I think it's a little bit quicker. So let's say this is x and this is x. So give me two integers that sum to negative 20 and have a product of positive 36. So that's going to be negative 18 and then also negative 2. So when I solve this, I'm going to get x minus 18 is equal to 0, or x minus 2 is equal to 0, just using my zero product property. Let's add 18 to both sides of the equation here. That's going to cancel. So you get x equals 18, then or let's add 2 to both sides of the equation here. That cancels, x is equal to 2. Now we're only going to need one of these solutions. Let's go back up. And you certainly don't want to turn your test in and say x equals 2 or x equals 18, something like that. Remember, you're trying to find the dimensions for this rug. So you need a length and you need a width. If I plug a 2 in there, would that make sense? 22 minus 2 times 2 is 4. So 22 minus 4 would be 18. So my length for the rug would be 18. So in other words, this from right here to right here would be 18. And then you would have another 2 feet to go there and another 2 feet to go there. 18 plus 2 plus 2 would give me to 22. So that works. Then this one, if you plug in a 2 there, 18 minus, again, 2 times 2 is 4. So 18 minus 4 would be 14. So your width would be 14. Okay, so does that work? Again, thinking about it, going from right here to right here, well, that's going to be 14, and then you have 2 there and 2 there. So 14 plus 4 gets me back to 18. So this all works out. It's all checked. So the length of the rug is going to be 18 feet, and the width is going to be 14 feet. Again, if you multiply those two together, you would get 252 square feet. Now, in terms of the other solution we got x equals 18. Does that work? No. If you plugged in 18 there, you'd have 22 minus 2 times 18. That's obviously not going to work. It's a negative value. You can't have a negative length or a negative width. So when you see something like that, you need to throw that solution away. We already have what we need. We know the length is going to be 18 feet and the width is going to be 14 feet. So let's put that the length is 18 feet and the width is going to be 14 feet. All right, let's take a look at problem number 4 now. So Molly's backyard is perfectly square and has a total area of 800 square feet. Molly sets up a sprinkler in the very center of her backyard, which sprays water in a circular pattern and only covers her backyard. What is the radius of the circle formed by the water pattern of the sprinkler? So let me highlight this. We are asked to find what is the radius of the circle formed by the water pattern of the sprinkler. So hopefully this problem did not give you too much trouble. I would definitely recommend drawing a little picture. But again, this is another problem, like a lot of them are in this section, that just deals with the Pythagorean theorem. So setting up a little picture, I would start with drawing Molly's backyard. It says that it's perfectly square, so I would just draw myself a little square. It does not need to be perfect. So let's come down here. And you'll see that I've already drawn a square. It's this green square here. So that's Molly's backyard. The next part there, it says that Molly sets up a sprinkler in the very center of her backyard. So you want to go to the very center and you want to set yourself up a little sprinkler. I know these things are hard to draw, so just do the best you can. It doesn't have to be perfect. Then it says it sprays water in a circular pattern, and here's where everyone gets lost, only covers her backyard. So let me be very clear about what this means. Let's come down here. If you think about a circular pattern, if you've ever had a sprinkler in a lawn, you know that if it's spraying and you have it set to cover your lawn, well, it's going to have to go over some of the parts, right? If you had a square like this. So in other words, this pattern here is going to end up hitting here, which is outside. It's going to hit here, which is outside, here, which is outside, and here, which is outside. But you need to set it such that it covers the entire backyard and it's a circular pattern. So it's going to need to hit here. It's going to need to hit here, here, and here, and it doesn't need to be larger than that. So we know these 4 points right here would be on the circle, so that's how we can sketch our circle, okay? But it does not mean that it's not going to hit outside of the backyard. As long as it's inside of the circle, it's okay. It does mean that it's not going to hit out here. So that's what that means in case you were confused. So now we would have our circle drawn, and we have our sprinkler in the middle, and we have our backyard. Okay, so what else do we need? Well, coming back up here, again, just reading this one more time, what is the radius of the circle formed by the water pattern of the sprinkler? Well, coming back down, again, I would want to set up my radius here, again, from the center, which is where my sprinkler is, to any point in that circle. I just happen to draw it this way, but you could have drawn it this way. Whatever you want to do, the idea here is you're going to recognize that you can use your Pythagorean theorem. So let me put in these sides here, so this is crystal clear. We just put in my right angle symbol. So you see this is a 90-degree angle. And essentially, if you doubled this radius, so in other words, if you took this and you doubled it and extended it out to here, well, you see that you have a right triangle in that case, right? So doubling the radius means you have the diameter. So basically, the length of the hypotenuse here would be 2r. Okay, so we need to know that. Now, how do I figure out this length here and this length here? Remember, with a square, all the sides have the same length. So you can just pick a variable like x to represent the unknown side length. So let's just put x here and x here. So the area would be x squared, right? It's side squared. So the area, let's just say, is going to be x squared. And now we are told in the problem that Molly's backyard is perfectly square and has a total area of 800 square feet. So what we can do, we know x squared is the area, and the area is 800 square feet. So what I can do is just say that x squared is equal to 800, and I can really quickly solve this equation. I can figure out what x is, and I'll basically be good to go. And let's just say that x is equal to, normally you do plus or minus the square root, but in this case, you just need the principal one. The negative one wouldn't make any sense. So you would do the principal square root of 800, which I'll write as the principal square root of 400 times the principal square root of 2. The principal square root of 400 is going to be 20. So this is going to be 20 times the square root of 2. So I would just update this. This length here is going to be 20 times square root of 2. And this length right here is also going to be 20 times square root of 2. Okay, so we can get rid of all this. Now, again, for the Pythagorean theorem, you have, let me move this down, you have a squared plus b squared is equal to c squared. So the legs, the a and the b here, you're going to have 20 times square root of 2 in each case. Let me actually move this over here. So we're going to say that we have 20 times square root of 2. So this is going to be squared. Then I'd have plus this guy again. So instead of writing that again, you could just do 2 times this amount. Okay, so 2 times, you have this 20 times square root of 2 being squared. Let me move this over so it's a little bit cleaner. Okay, so what's this going to be equal to? Well, again, this diameter here is 2 times the radius, that 2r, and that needs to be squared. So we have set up our formula here, and we're just going to solve for r. Again, that's what we're trying to figure out. So to kick things off, I would square 20. That would be 400. So you would have 2 times 400, and then times the square root of 2 squared is 2. So let me just actually write this as 4 times 400. I'm not going to simplify that yet because you're going to see that something's going to cancel in a moment. So let's put equals. 2 squared would be 4, and then you would just have r squared. What I'll do from here is divide both sides of the equation by 4. And so this is going to cancel over here and over here. And I'm going to say that r squared is equal to 400. And you can solve this with the square root property. Again, you don't need plus or minus the square root of 400. You just need the principal square root of 400. So I would say r is equal to, the square root of 400 is going to be 20. So that tells me this radius here is going to be 20 feet. So if you wanted to check this before we even move on and put our solution down, you would just verify that 20 times square root of 2 squared plus 20 times square root of 2 squared is equal to, again, the radius is 20, so twice that is 40, so it would be 40 squared. So you want to make sure that those two are equal. I can assure you that it is. Already, I've already checked it. So our radius here is going to be 20 feet. So coming back up here, I'll just answer this. Again, you can make a sentence if you want. I'm just going to put 20 feet. All right, let's look at problem number 5 now. So we have that a toy spaceship is launched vertically upward from an initial height of 84 feet. The initial velocity is 20 feet per second. Find out how long before the rocket will hit the ground. So this type of problem, which you'll also see in this section, is very simple. They're going to give you a formula that you can just plug into. So coming down here, you'll see this note, and this is in all the textbooks. For this problem, we will disregard air resistance, and then you're also going to be given this formula. So here, h, which is the height, is equal to negative 16t squared. Now, t is going to be the number of seconds, then plus v sub 0. V sub 0 is going to be the initial velocity in feet per second, then times t, which again is the number of seconds again, then plus s sub 0, and s sub 0 is the initial height in feet the projectile is launched from. Let's just grab these things that we're going to need. So the first thing is the initial velocity, which is v sub 0, that's given to us as 20 feet per second. So let's just put 20. And then the initial height is given to us as 84 feet. So that was s sub 0. So this is going to be 84. And then in terms of the height, the h, you're going to need to figure that out. It says specifically, find out how long before the rocket will hit the ground. So what's the height of the ground? Well, it's meant to be 0. Okay, so the height, the h, is going to be 0. So let's grab this real quick. And all we're going to do is plug in here. And we're going to have a very simple quadratic equation to solve. So we know h is 0. So let's plug in a 0 for h. and this equals negative 16 times t squared, then plus our v sub 0 is 20, so 20, then times t, and then we're going to have plus, we're going to have this s sub 0, which is 84. So let me copy this, and basically what I would do here is divide everything by negative 4, just to make the equation a little bit simpler. So I'm going to divide this by negative 4, this by negative 4, this by negative 4, and this by negative 4. So 0 divided by negative 4 would be 0. And this equals negative 16 divided by negative 4 is positive 4. So this is 4t squared. A positive divided by a negative is a negative. 20 divided by 4 is 5. And then you'd have your t. And then positive divided by negative is negative. 84 divided by 4, that's going to give me 21. So from here, you can use your quadratic formula, or you can solve this using factoring. I'm just going to solve it using factoring. So I'm going to go 4t squared minus 5t minus 21 is equal to 0. The 4 here, that's going to come from either 4 times 1 or 2 times 2. So you would have to check 4t and t, and then you would also have to check 2t and 2t like this. Again, your factors of 21, forget about the fact it's negative, it's 1 and 21, or it's 3 and 7. So thinking about 1 and 21, would that work? If you put a 21 here, let's say you put a 21 here and a 1 here, well, again, because this is a negative here, you just want to subtract, and I'm trying to get to 5, forget about the fact that's negative. 4 times 21 is just way too big. That's never going to work. If you flip this around and you put a 1 here and a 21 here, well, that's going to be 4 and 21. That's just not going to work. So forget about 1 and 21 with this first guy here. Now you could check it here, but putting a 21 here and a 1 here, that's going to be too big as well. 2 times 21 is 42. 2 times 1 is 2. 42 minus 2 is 40. Forget about that. That's out. So this one is not possible. So now you would check 3 and 7. So would that work? Well, if you put, let's say, a 7 here and a 3 here, this would be 28 minus 3, that's 25, so that's not going to work. If you flip it around and put the 7 here and the 3 here, now you've got 12 minus 7, which is 5. So this is what we want. So get rid of that. Found what you need. So we would say, to get the signs right, that we want this to be negative and this to be positive. So that way this guy on the outer would be negative 12t. This guy on the inner would be plus 7t. We'd basically be good to go. Negative 12t plus 7t will give me that negative 5t in the middle. Okay, so now that we figured that out, let's go through here and solve using the zero products property. One of these is going to be nonsense, and I'll show you that in a moment. So you have 4t plus 7 is equal to 0, or you have t minus 3 is equal to 0. And this one's going to end up being nonsense because you're going to get a negative value. You can't have a negative time, so you can just throw it out. So you can solve that on your own. I'm just going to tell you it's not going to work. For this one, you would add 3 to both sides of the equation, and you're going to get t is equal to 3. So that's the number of seconds, and specifically what we're asked to figure out, right? Find out how long before the rocket will hit the ground. Well, it's going to be 3 seconds. So 3 seconds. And if you want to check that, you could just plug everything back into your formula. Just evaluate and make sure that the left and the right sides are equal. I've already checked this, so I'll let you do that on your own. All right, let's take a look at our practice test. We're told to solve each inequality, write in interval notation, and then graph the interval. All right, for the first problem, we're looking at 2x squared minus 6x plus 2 is greater than negative 2. So the first thing I'm going to do is actually make the right-hand side of this inequality 0. So to do that, I'm just going to add 2 to both sides of the inequality, cancel this away and put 0 here. So we'll have 2x squared minus 6x, then plus 4, and this is greater than 0. Now you might notice that everything here in this inequality is divisible by 2. So I'm just going to make my life a little bit easier. And remember, you can always divide both sides of an inequality by a positive number, and you won't change the solution set. So I'm going to divide by 2 here, 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 and here. And so 2 divided by 2 is 1, so this is x squared. Then minus 6 divided by 2 is 3, so this is 3x. And then plus 4 divided by 2 is going to be 2. And this is greater than 0 over 2 is 0. Okay, so the idea now is basically I can replace this inequality symbol with equals, and I can solve the resulting equation. Now that's going to give me my critical values, and we'll talk more about that in a second. So let's just actually set this up. So we're going to go x squared minus 3x plus 2. Let's say this is equal to 0. Now, how could I solve this? Well, I could use the quadratic formula, but I think it's quicker in this case to just factor. So let's see what we get here. So we'll say that we have x here and x here. We need 2 integers that have a sum of negative 3 and have a product of positive 2. So that's going to be negative 2 and negative 1. Now, if I solve this using the zero product property, you would basically set x minus 2 equal to 0, or you would set x minus 1 equal to 0. And over here, you just add 2 to both sides of the equation. So x is equal to 2. Over here, you add 1 to both sides of the equation. So you get x is equal to 1. Okay, so these are the critical values. Essentially, you're just using these values to split your number line up into these different regions. Before I go to the next sheet where we have our number line, I just want to factor this real quick so that we have it. So x minus 2, that quantity times the quantity. We're going to have x minus 1 and put this as greater than 0. Okay, so once you have your little number line set up, you really only need your critical values. So I found 1 and 2. Right, so you're going to put these on the number line, or you could use a table, whatever you want to do. So I'm going to put a 1 here and a 2 here, and then you can just get rid of this. You don't need it anymore. And I like to have this in factored form. It just makes the calculations a little bit quicker. Of course, you could just use a calculator, but it's really up to you. So what I want to do here is just set up these regions. So let's just call this region A, this B, and this C. And basically, these critical values are not included. Okay, so we want to think about those separately, and I'll talk about that towards the end. But basically, this is where x is strictly less than 1. This is where x is greater than 1 and less than 2. And here, this is where x is strictly greater than 2. Okay, so we would take a number inside of each region and test it in our inequality and see if it's true. So if it works, then every number in that region is going to work. If it doesn't work, then no number in that region is going to work. Okay, so what we would do here is start with region A. So x is strictly less than 1, so you could pick something like 0, and you could plug that in here and here. Now, you can go through and do the calculation, or you can just figure out, will this be greater than 0, meaning is it going to be positive? Well, you can just eyeball that and see that you would have negative 2 there times negative 1. Well, negative times negative is positive, so I know that this would be a positive result. In this case, it would be positive 2. So you can just put a t here for true, put a t there for true, or you could write true out, whatever you want to do, but all the numbers inside of this region A are going to work. So x could be anything less than 1. Those numbers would all satisfy the inequality. Now let's go to something in region B. So x is greater than 1 and less than 2. I would pick something like 1.5 or 3/2. So you're going to plug in, let's say 1.5 there, like this. And again, you don't have to actually do the calculation. You can just think about the sign. 1.5 minus 2 is going to be negative. Then 1.5 minus 1 is going to be positive. So negative times positive will give me negative, and a negative is not greater than 0. So this here would be false. And if this is confusing for you, you can just crank this out with your calculator. This would be 1.5 minus 2 is negative 0.5, and this would be 1.5 minus 1, which is positive 0.5. You multiply those together, and you get negative 0.25, right? So we know that's not greater than 0. Okay, for region C, where x is strictly greater than 2, let's just pick 3. So let's just pick 3. And you can see that 3 minus 2 would be 1. And then 3 minus 1 would be 2. So again, you only have to think about the result. Is it going to be positive or negative? So this is a positive times another positive, so it would work here. A positive would always be greater than 0, so this is true. Again, if you want to crank it out, 3 minus 2 again is 1. 3 minus 1 is 2, so 2 times 1 will give you 2. Now, in terms of your critical values, you want to think about those at the end. And all you have to think about is the inequality symbol that you're working with. In this case, you have a strict inequality. So if you have a strict inequality, that means that these critical values are going to be excluded from the solution. And you can eyeball that and see that it's not going to work. If you plug in a 1 there, then you have 1 minus 1, which is 0. 0 times anything is always 0. 0 will not be greater than 0, so this is going to fail. For a similar reason, this one's going to fail. But if I change this to greater than or equal to, then they would both work, right? Because you would have 0 is equal to 0. So what you want to do in this particular case is exclude them. So you would want to list your solution by saying that x is strictly less than 1 or x is strictly greater than 2. And then in interval notation, we could say that we have from negative infinity up to and not including 1. And then we'll put the union with, we'll have anything greater than 2. Right? So basically a parenthesis next to 2. And again, this is going out to positive infinity. Now let me show this on the graph. So coming to our number line here, let's just put a 1 here and then a 2 here. And then for x is less than 1, again, at 1, I would put a parenthesis here. Some books will put an open circle to show that it's not included. And then I'm just going to shade everything to the left. And then for x is greater than 2, again, I'm going to put a parenthesis here. And then I'm just going to shade everything to the right. So again, your book might use an open circle just to show that it's not included. So that's up to you what you want to do. But this would be my solution graphically. Then you have x is less than 1 or x is greater than 2. And then, of course, an interval notation. All right, let's take a look at problem number 2 now. So we have 6x squared minus 10x plus 2 is less than 6. Again, what I'm going to do is make this right-hand side 0. So we'll subtract 6 away from each side of the inequality. Cancel this away and put 0. We'll have 6x squared minus 10x. 2 minus 6 is going to be negative 4. So let's put minus 4. And this is less than 0. All right, so from here, you'll notice that, again, you could divide everything by 2. And dividing everything in an inequality by the same positive number does not change the solution set. So I'm going to divide by 2, divide by 2, divide by 2, divide by 2. And I'm going to have 3x squared minus 5x minus 2. And this is strictly less than 0. Okay, so I'm going to replace this inequality symbol with an equal symbol. And so I'll basically have 3x squared minus 5x minus 2 is equal to 0. I'm going to leave a little space because I'm going to put the factored form up there in a second. So let's just try to factor this real quick. So we would have 3x and x, because again, 3 is a prime number, so that's a given. Then for 2, forget about the fact that's negative. It's 2 times 1 only. So what I want to put a 2 here and a 1 here. Well, 3 times 2 would give me 6, and then 6 minus 1 would give me 5. So I want this to be negative, and I want this to be positive. My outer here would be negative 6x. My inner here would be positive x. Negative 6x plus x would give me negative 5x. So this is what I'm looking for. So let's put this up here so we have it. So 3x plus 1, this quantity, times the quantity x minus 2. And then this is going to be strictly less than 0. Okay, so we'll have that for later on. So for right now, let's just go through and solve this using our zero product property. So we'll have 3x plus 1 is equal to 0. Then or, you're going to have x minus 2 is equal to 0. So what we'll do is subtract 1 away from each side of the equation here. Cancel this. We'll have 3x is equal to negative 1. Divide both sides of the equation by 3. Let's cancel this away. And basically, you're going to have x is equal to negative 1/3. Over here, you just add 2 to both sides of the equation. So basically, let me just show this. We'll have or x is equal to 2. Okay, so coming to where I have my number line set up, let's just do the same thing. So I'll just call this region A, region B, and region C. And the numbers we're working with, the critical values, will have negative 1/3, and then we're going to have positive 2. Let me make this 3 a little bit better. Once you write this in, you can just get rid of this. You don't really need this anymore. So let's just move this up a little bit. And basically, I just want to specifically note that here we have x is strictly less than negative 1/3. Here we have x is greater than negative 1/3, and it's less than 2. And then here, x is greater than 2. Then recall that because we have a strict inequality here, these endpoints or critical values are not going to be included in the solution. Okay, so let's just test things and see if they work. Again, you can just think about the sign. Is it going to be negative? If it's going to be negative, that means it's less than 0. So we would basically accept it as a solution. If it ends up being positive, then we're going to reject it, right? We're looking for this to be less than 0. So what is less than negative 1/3 that we can use? We could use negative 1. So if you plugged in a negative 1 there, I know this would be negative. If I plugged in a negative 1 there, 3 times negative 1 is negative 3. Negative 3 plus 1 is going to be negative 2, so this is negative as well. Well, negative times negative would give me a positive, and a positive is not less than 0. So this one is not going to work. I'm going to put an F there for false. And let's move on to the next one. And again, if you want to, you can always just go through and plug in and figure out what the value is, and you can compare it that way. It's just up to you. So for the next one, I need something that's greater than negative 1/3 and less than 2. Let's just use positive 1. So plug in a 1 there and a 1 there. 1 minus 2 is negative 1. So this is going to be negative. And then here, 3 times 1 is 3. And then 3 plus 1 would be 4. So this would be positive. Positive times negative would give you a negative. So yes, this would be less than 0. So we want to say that this would be true here. And then for the last one, we have x is greater than 2. So you could pick something like 3. So you'd plug in a 3 there and a 3 there. 3 minus 2 would give you positive 1. So let's put a plus sign here. And then basically 3 times 3 would give you 9. 9 plus 1 would give you 10. So let's put a plus sign there. Positive times positive is positive. So a positive will never be less than 0. So this one would be false here. So we can say that our solution here is basically going to be that x is greater than negative 1/3 and it's less than 2. Remember, we're using strict inequalities here because the inequality we got originally was a strict inequality. So the negative 1/3 and the 2, those are going to be excluded. Now in interval notation, basically I'm just going to show this like this. So negative 1/3 next to a parenthesis, then comma, you're going to have 2 next to another parenthesis like this. And then graphically, let's put negative 1/3 here. Let's put 2 here. So this is where you can put a parenthesis here and a parenthesis here. Or again, you can put an open circle. And then I'm just going to shade everything in between. So here, x can be any number that is greater than negative 1/3 and less than 2. All right, let's take a look at problem number 3 now. So we have 6x squared is greater than or equal to 5x squared plus 99 plus 2x. All right, so let's clean this up a little bit. What I'm going to do is subtract 6x squared away from each side of the inequality. Let's cancel this away and put 0 over here. So we'll have 0 is greater than or equal to 5x squared minus 6x squared is going to give me negative x squared. Then you have plus, we're going to write the 2x next, and then plus 99. All right, so I always like my variables to be on the left. So what I'm going to do is actually write this as negative x squared plus 2x plus 99. And note that this symbol is pointing in this direction. So I'm going to keep it that way. I'm basically going to say this is less than or equal to 0. So if you read it from this way, you see that 0 is still greater than or equal to this guy right here. Okay, so it's important to check that if you're rewriting things. Now, one thing I would do here, if I'm going to factor this, I don't like a negative leading coefficient. You could pull out a negative 1, but what I like to do is actually divide everything by negative 1. But remember, if you're working with an inequality and you multiply or divide by a negative number, you have to flip the direction of the inequality symbol. So I'm going to divide this by negative 1, this by negative 1, this by negative 1. I'm going to flip this, and then I'm going to divide this by negative 1. So this gives me x squared, then minus 2x, then minus 99. This will now be greater than or equal to, and this will still be 0. Now I'm going to replace this inequality symbol with equals and solve the resulting equation. And let me just put a little space here because, again, I want to write this in factored form just to make things a little bit easier on myself. So give me two integers whose sum is negative 2 and whose product is negative 99. Well, let me put my x here and my x here. Well, 99 is basically 9 times 11 or 3 squared times 11. So let's think about 9 and 11. Can we make that work? Well, if I did a negative 11 and a positive 9, yeah, that would work. So if I did a negative 11 and a positive 9. Let's put this up here. So x minus 11, this quantity times the quantity x plus 9. And this will be greater than or equal to 0. So we're going to need that for later on. Okay, so I'm just going to solve this using my zero product property. So x minus 11 equals 0, or x plus 9 is equal to 0. From here, let's add 11 to both sides of the equation. Cancel this away. We'll get x is equal to 11. Then, or, over here, let's subtract 9 away from each side of the equation. Cancel that away. We'll say x is equal to negative 9. So coming to my number line, I'm going to put negative 9 here and positive 11 here. So again, this will be region A. Let's call this B. Let's call this C. Here we'll have x strictly less than negative 9. Here we'll have x is greater than negative 9 and less than this positive 11. And here x is strictly greater than 11. Now you'll notice that we have a non-strict inequality here. We have the greater than or equal to. So that just tells us that negative 9 will work as a solution and 11 will work as a solution. Why? Because again, if you plugged in a negative 9 here, negative 9 plus 9 is 0. 0 times anything is 0. So you will get 0 is, again, equal to 0. So it satisfies this part right here. Okay. The same thing would happen with 11. So these guys would now be solutions, but we'll notate that later on. For right now, we're not even worried about it. We would first test something in this region A. So let's maybe take a look at something like negative 10. If you plugged in a negative 10 there and a negative 10 there, so that gives me a negative, right? Negative 10 minus 11 would give me negative 21. Then here, negative 10 plus 9 is going to be negative 1. So again, this gives me another negative. Negative times negative gives me positive, right? And a positive is going to be greater than 0. So we know that inside of this region A, it's going to be true. All right, let's look at the next region, which is region B. You could pick 0 there. That's going to be really easy to work with. So plug in a 0 there and there. And you see that 0 minus 11 would be negative 11, so this is negative. 0 plus 9 would be positive 9, so this is positive. Negative times positive is negative, and a negative will not be equal to 0, and it will not be greater than 0, so this right here is going to be false. Then for the other guy, let's look at x is greater than 11. Maybe we'll pick something like 15. I think that's pretty easy to work with. So let's go 15 here, and let's go 15 here. And you can see that 15 minus 11 would be 4, so this is a plus. And 15 plus 9 is going to be 24, so this is a plus here. Positive times positive is positive, and any positive is always going to be greater than 0, so this is going to be true. Let's get rid of this, and let's write our solution now. And again, these critical values here, negative 9 and 11, will be included. So x can be less than or equal to negative 9, or x can be greater than or equal to 11. And then in interval notation, so we'll have from negative infinity up to and including negative 9. So you want to use that bracket there. And then the union with, here, we want to use a bracket next to 11. And then comma, we're going to go out to positive infinity. Okay, so let's put negative 9 here, positive 11 here. And what you'd want to do is put a bracket here, or again, some books in this case will use a closed circle, or you could say a filled in circle to show that negative 9 is included. And then you want to shade everything to the left. Here at 11, I'm just going to put a bracket there to show 11 is included, and I'm going to shade everything to the right. All right, let's take a look at problem number 4 now. So we have 6x squared plus 17x minus 8 is less than or equal to 9x. So the idea here is I'm just going to subtract 9x away from each side of the inequality. I'm going to make this right-hand side 0. And so what I'll have is 6x squared. 17x minus 9x would be 8x. So plus 8x minus 8, and this is less than or equal to 0. Again, if you notice, I could make this simpler by dividing everything by 2. So I'm just going to divide everything here by 2. And so this is going to give me 3x squared plus 4x minus 4 is less than or equal to 0. So from here, I'm just going to leave a space, and I'm going to replace this with an equation. So 3x squared plus 4x minus 4 is equal to 0. And I'm going to put my factored form here, and I'm also going to put it up here. But let's just do it down here first. So 3 is a prime number, so I can just right away put 3x here and x here. Let's think about 4. You've got 1 and 4, or you've got 2 and 2. So if I put a 4 here and a 1 here, that is going to be too big, right? 3 times 4 is 12. 12 minus 1 would be 11. If I switch that around and put a 4 here and a 1 here, now you've got 3 and 4. 4 minus 3 would give you 1. So this is not going to work. So it's going to have to be 2 and 2. So basically, you're going to have 6 minus 2, which would give me 4. So let's put a plus here and a minus here. So this would give me 6x. This would give me negative 2x. 6x minus 2x would give me positive 4x. So this is exactly what I want. All right, let me copy this up here, actually. So we'll have 3x and then minus 2, this quantity, times the quantity x plus 2, like this. And we'll say this is less than or equal to 0. All right, so for this one right here, let's set 3x minus 2 equal to 0, then or x plus 2 equals 0. We already know this one. We'll just say x is equal to negative 2. Again, you could just subtract 2 away from each side of the equation. That's real simple. Then over here, let's add 2 to both sides of the equation. Cancel that away. We'll say 3x is equal to 2. Divide both sides of the equation by 3. This cancels. And you get x is equal to 2/3. So you have x equals 2/3 or x equals negative 2. So let's go to the number line. Okay, so let's put negative 2 here and then positive 2/3 here. Again, I'm going to call this region A, region B, and region C. So this is x is strictly less than negative 2. This is x is greater than negative 2 and less than 2/3. And then this right here is going to be x is strictly greater than 2/3. Okay, you can get rid of this at this point. I know that negative 2 and then also 2/3, those are going to work as solutions here. So I need to make sure I remember to include them. And I'm just going to test values here. So something less than negative 2, let's just pick negative 3. So let's pick negative 3, and that's going to get plugged in each case. Well, 3 times negative 3 is going to be negative 9, and then negative 9 minus 2 would be negative 11. So I know this is negative. And then here, negative 3 plus 2 would be negative 1. So I know this is negative. Negative times negative is positive. So a positive is not less than 0. So we know that this right here wouldn't work. So this is false. So going to the next one, we would have something between negative 2 and 2/3. You could pick 0. I think that's really easy to work with. So let's plug that in. You'd have negative 2, and then basically times positive 2. So that's obviously going to be negative 4 because this is a negative and this is a positive. So a negative is always going to be less than 0. So this is true. Okay, so looking at the next guy here, we have something that's greater than 2/3. So let's just pick 1. So let's plug in a 1 there and there. So 3 times 1 is 3, and 3 minus 2 is going to be 1. Here, 1 plus 2 is 3. So we know that this is positive and this is positive. Positive times positive is positive, and a positive is never going to be less than 0. So this is going to be false. Okay, so let's just write our solution here. And again, we had a non-strict inequality. So negative 2 and then also 2/3, those need to be included. So we'll say that x is greater than or equal to negative 2, and it's less than or equal to 2/3. In interval notation, again, you just want to make sure you use your brackets. So you have a bracket next to negative 2, and then a bracket next to 2/3. So let's put a negative 2 there. Let's put a 2/3 there. Let's put our bracket in here to show that it's included. Again, you can use a filled in circle. Let's put a bracket here to show that's included. And let's just shade everything in between to show that, again, from negative 2 and including negative 2, going up to 2/3 and including 2/3, those values work as a solution. All right, let's take a look at problem number 5 now. So we have 6x squared minus 8x plus 1, and this is greater than negative x. So I'm just going to add x to both sides of the inequality. Cancel this away and say this is 0. We'll have 6x squared. Negative 8x plus x would be negative 7x. Then plus 1, and this is greater than 0. And again, I'm just going to put 6x squared minus 7x plus 1. I'll say this is equal to 0, just to find the critical values. Let's factor this guy right here. So for 6, it's either 6 times 1 or 2 times 3. I've already worked this problem, so I know it's 6 times 1, so I'm not going to waste your time. I'm just going to say this is 6x and x here. And then 1 can only be 1 times 1, right? So I can put a 1 here and a 1 here. I basically just need to work out the fact that this would be negative and this would be negative, right? So basically you'd have negative 6x here. So negative 6x here, and then negative x here. Negative 6x plus negative x will give you negative 7x. Okay, so let me write this above here and just say this is 6x minus 1, this quantity, times the quantity x minus 1 here, and then I'll put this as strictly greater than 0. So to solve this down here, we'll say 6x minus 1 is equal to 0, or we'll say x minus 1 is equal to 0. For this one, let's add 1 to both sides of the equation, cancel that. We'll have 6x is equal to 1, divide both sides of the equation by 6. Let's cancel this away. We'll say x is equal to 1 over 6. Over here, let's add 1 to both sides of the equation, cancel that away. We'll say or x is equal to 1. So let's put 1 over 6 here. Let's put 1 here. And again, I'm just going to write this as region A. This is where x is strictly less than 1 over 6. Let's say this is region B. And this will be where x is greater than 1 over 6 and less than positive 1. This will be region C. We'll say x is strictly greater than 1. Okay, so once again, we're just going to plug in here and see if we get something that's greater than 0. So you can plug it in and get the value, or you can plug in and just figure out the sign. It's up to you. So for this one, let's just start off by picking 0. Plug in a 0 there and there. So 6 times 0 is 0. 0 minus 1 is negative 1. So this is negative. Here, 0 minus 1 is negative 1. So this is negative. Negative times negative will give me a positive. So a positive is always greater than 0. So I'll go ahead and say that this is true. Then coming over here, I need to pick something that is between 1 over 6 and 1. So this one is a little bit tricky. Let's maybe pick 1/2. So let's plug in a half there and a half there. This one's easier to do. A half minus 1 would be negative a half. So let's put minus there. We know that's going to be negative. Here, 6 times a half would be 3. 3 minus 1 would be 2, so this is positive, right? So positive times negative is going to give me a negative, and a negative is never going to be greater than 0, so this is going to be false. For C, let's just pick positive 2. I think that's pretty easy to work with. So 6 times 2 is 12. 12 minus 1 is 11, so let's put a positive sign there. Then 2 minus 1 is 1, so that's going to be positive as well. Positive times positive is going to be positive, so this is true. Now remember, you have a strict inequality here, so these critical values are going to be excluded from your solution. And to write it, I'm just going to say that x can be strictly less than 1/6, or we could say that x is strictly greater than 1. In interval notation, we'll say from negative infinity up to and excluding this 1 over 6. And then the union with will have excluding 1 going out to positive infinity. So let's put 1 over 6 here and 1 here. And again, these are going to be excluded. So I'm going to use a parenthesis in each case, or you can use an open circle, whatever you want to do. I'm just going to put a parenthesis here, shade to the left. And then I'm going to put a parenthesis here and then shade to the right. All right, let's take a look at problem number 6 now. So we have 5x squared plus 6x is less than 11. And again, I'm just going to subtract 11 away from each side of the inequality. Cancel that away and put 0. So let's write this as 5x squared. Then we have plus 6x minus 11. And this is strictly less than 0. Let me make this 2 a little bit better. Okay, so down here, I'll just write 5x squared plus 6x minus 11 is equal to 0. Again, I'm just going to solve this using factoring. So we'll put a 5x here and an x here because 5 is a prime number. For 11, that's a prime number as well. Forget about the fact that it's negative. So it can only come from 1 times 11. So if you put an 11 here, that's obviously going to be too big. So it would have to be an 11 here and a 1 here. And so what you would want is for this guy to be positive and this guy to be negative. So basically that you would get this negative 5x here and this positive 11x here. Negative 5x plus 11x would give you positive 6x. Okay, so this is my correct factorization. Let me just write it up here. So 5x plus 11, this quantity, times the quantity x minus 1, and this would be strictly less than 0. So here, let's go 5x plus 11 is equal to 0, then or x minus 1 is equal to 0. Let's subtract 11 away from each side of the equation. Cancel that away and say 5x is equal to negative 11. Let's divide both sides of the equation by 5. Cancel this away and say x is equal to negative 11 fifths. Over here, let's just add 1 to both sides of the equation. Cancel that away. And I'll say or x is equal to 1. Okay, so coming to the number line, let's put negative 11 fifths here. Let's put positive 1 here. You can get rid of this information. You don't need it. Let's say this is region A, this is region B, this is region C. So for region A, it's anything where x is going to be strictly less than negative 11 fifths. Here, x is greater than negative 11 fifths, and it's less than positive 1. Here, x is strictly greater than 1. Okay, so just using a test point in each case, for something that's less than negative 11 fifths, let's just use negative 3. So let's use negative 3, and let's see what that would give us. So 5 times negative 3 would be negative 15. Then negative 15 plus 11 would be negative 4. So I know this would be negative. Then here, negative 3 minus 1 would be negative 4. So I know this would be negative. A negative times a negative would give me a positive, and a positive is never going to be less than 0. So this right here is going to be false. Let me actually slide this down just a little bit. So from here, what I want to do is test something in region B. So I think 0 would work pretty well. Plug in a 0 there, you would get 11. Plug in a 0 there, you would get negative 1. So you have a positive times a negative, which would give you a negative, and a negative is always going to be less than 0. So this is true. Let's get rid of this and this. And then basically for the last one, where x is greater than 1, let's just pick 2. So you plug in a 2 there, you're going to get 1, so this is positive. Plug in a 2 there, 5 times 2 is 10, 10 plus 11 is 21. That's going to be positive as well. Positive times positive is positive, and that's never going to be less than 0. So let's go ahead and say this is false. Now remember, you have a strict inequality, so these critical values are excluded from the solution. So we'll just say that x is going to be greater than negative 11 fifths. We'll say and it's less than 1. So in interval notation, we'll say negative 11 fifths. Again, this is excluded. That's why we have the parenthesis. And then comma, you'll put a 1. And again, this is excluded. That's why you have the parenthesis. So graphically, let's say this is negative 11 fifths. Let's say this is 1. And again, I'm going to use a parenthesis with each here to show that they're not included. You can always use the open circle. And then I'm going to shade everything in between. So x can be anything greater than negative 11 fifths going up to and excluding positive 1. All right, let's take a look at problem number 7 now. So we're going to have x squared minus 17x plus 5 is greater than or equal to negative 11x. So let's add 11x to both sides of the inequality. And let's cancel this away and put 0. So over here, let's say that we have x squared. We have negative 17x plus 11x. That's going to give me negative 6x. Then we're going to have plus 5, and this is greater than or equal to 0. So let's write this down here. X squared minus 6x plus 5 equals 0. really, really easy to factor this. We'll put an x here and an x here. We need two integers that give me a sum of -6 and have a product of +5. Well, that's going to be -5 and -1. So up here, let's go x minus 5, this quantity, times the quantity x minus 1, and this will be greater than or equal to 0. Okay, so let's use our zero product property to get our critical values. We'll say x minus 5 is equal to 0, or x minus 1 is equal to 0. From here, let's add 5 to both sides of the equation. Cancel this. We'll get x is equal to 5. Then or, let's add 1 to both sides of the equation. Cancel this. You'll get x is equal to 1. All right, let's put a 1 here and a 5 here. Let's get rid of this. Let me slide this down just a little bit so it all fits in here. Let's put this as region A, B, and C. We'll have x is less than 1. Here we'll have x is greater than 1 and less than 5. And here we'll have x is greater than 5. So for this one, if I pick something like, let's say, 0, and I plug that in here and here, well, this would be -5 and this would be -1. So negative times negative will give me a positive, and a positive is always greater than 0, so this is going to be true. For the next one, let's say we pick something like 2. So we plug in a 2 there and a 2 there. Well, 2 minus 5 is -3, so this is negative. And then 2 minus 1 is going to be +1, so this is positive. Negative times positive is negative, and a negative is never going to be greater than 0. So this is false. Then over here, we have x is greater than 5. Let's just pick 6. Plug in a 6 there and a 6 there. 6 minus 5 is 1, so this is positive. 6 minus 1 is going to be 5, so this is positive. Positive times positive is positive, and that's always going to be greater than 0, so this is true. So for the solution here, remember it's a non-strict inequality, so the critical values are included. You would have that x is less than or equal to 1, then or x is greater than or equal to 5. So what we would say here is that we have from negative infinity up to and including +1, put a bracket there, and the union with 5 is included, so put a bracket there. So from 5 going out to +infinity. All right, so let's put a 1 there and a 5 there. And again, I'm just going to use a bracket with each. So I'll use a bracket here to show 1 is included. And then I'm just going to shade everything to the left. Here I'll use a bracket to show 5 is included. And I'll shade everything to the right. All right, let's take a look at problem number 8 now. So we have -6x squared minus x is less than or equal to 12 minus 7x squared. All right, so let's add 7x squared to both sides of the inequality. Let's get rid of this. And then let's subtract 12 away from each side of the inequality. Let's cancel this. Let's put this as 0. -6x squared plus 7x squared is x squared. Then you have minus x and then minus 12, and this is less than or equal to 0. So let's write this as x squared minus x minus 12 is equal to 0. And so from here, I'm going to factor this as x and then x. We know two integers that sum to -1 and have a product of -12 would be -4 and +3. So actually, let me write this up here. So x minus 4, that quantity times the quantity x plus 3. Let's put this as less than or equal to 0. Let's solve this. So x minus 4 would be equal to 0. Obviously, x is equal to 4. Just add 4 to both sides of the equation. Then or, over here, let's say x plus 3 is equal to 0. Here, we would subtract 3 away from each side of the equation. We would get x is equal to -3. All right, let's put -3 here, and let's put +4 here. Let's set this up as region A, and let's call this B, and then C. So this will be anything where x is less than -3. This will be x is greater than -3 and less than +4. And this will be x is greater than 4. And then for something that's less than -3, let's just pick -4. So we'll plug a -4 in there and there. So -4 minus 4 would be -8. So this is negative. -4 plus 3 is going to be -1. So this is negative. Negative times negative is positive. And a positive is never going to be less than 0. So this is going to be false. Now let's move on to the next interval, which includes 0. So I'm just going to use that. I think that's probably the easiest number to work with. So this would be -4, this would be +3. You have a negative times a positive, which would give you a negative, and a negative is always going to be less than 0. So this is going to be true. Okay, so let's move on to this one over here where x is greater than 4. Let's maybe pick 5. I think that's easy to work with. 5 minus 4 would be 1, so this is positive. Then 5 plus 3 would be 8, so this is positive. Positive times positive is positive, and a positive is never less than 0, so this is false. Okay, so remember, this is a non-strict inequality, so we are going to include these critical values -3 and 4 in our solution. So we'll say that x is greater than or equal to -3, and it's less than or equal to +4. In interval notation, let's put a bracket, and then -3, a comma, we'll put 4, and then a bracket. And then graphically, I'll put -3 here, and then 4 here. And again, we're going to use a bracket here, and a bracket here. And then I'm just going to shade everything in between. So it could be -3, and then any number going up to and including +4. All right, let's take a look at problem number 9 now. We have 5x squared minus 20x minus 32. This is less than or equal to -8x. Okay, just going to add 8x to both sides of the inequality, just like we've been doing. Cancel this and put 0. Let's take a look at 5x squared. -20x plus 8x would be -12x. Then you have minus 32, and this is less than or equal to, we would put 0 there. And again, I'm just going to first replace this inequality symbol with equals. So we'll have 5x squared minus 12x minus 32 is equal to 0. And so to factor this, let's put 5x here, and let's put x here. Let's put this over here as equals to 0. And 32 has a few possibilities, so let's really think about this. So you have 1 and 32. Would that ever work? Remember, because this is a negative here, you're going to subtract and try to get to 12. Forget about the fact that it's negative. If I put a 32 here, it's way too big. If I put a 32 here and a 1 here, that's still going to be too big. So 1 and 32, that's going to be out. Forget about that. The next one would be 2 and 16. So would 2 and 16 work? Well, if I put a 16 here, that's too big, right? 5 times 16 is 80. That's just not going to work. If I put the 16 here and the 2 here, that's going to be 16 minus 10, which is 6. So that doesn't work either. So next you would have 4 and 8. And let's see, if I put the 8 here, that's 40. That's too big. If I put the 8 here and the 4 here, well, now I have 20 minus 8, which is 12. That's what I want, right? I just have to work out the signs. So in this particular case, I want this one to be negative and this one to be positive. That way I can get a -20x and then a +8x. -20x plus 8x would give you -12x. So now let's say that 5x plus 8 is equal to 0, or x minus 4 is equal to 0. Let's subtract 8 away from each side of the equation. And let's say 5x is equal to -8. Then we'll divide both sides of the equation by 5. Cancel that. We'll say x is equal to -8/5. Then or, we'll say here we're going to add 4 to both sides of the equation. We'll say x is equal to 4. Let's put this as -8/5. Let's put this as 4. Let's go back and grab the factored form of that inequality. So coming back up here, let's just write this as less than or equal to like this. We'll grab it and let's see what we have. So I'm going to say this is region A, B, and then C. So this is x is strictly less than -8/5. So this is x is greater than -8/5. And it's going to be less than +4. This is x is greater than 4. Okay, so coming through here, if we think about something less than -8/5, well, you could use something like -2. So if I plugged in a -2 there and there, what would you get? Well, 5 times -2 is -10, and then -10 plus 8 is going to be -2, so this is negative. Here, -2 minus 4 is -6, so this is negative. Negative times negative is positive, and a positive is not less than 0, so this is going to be false. Then thinking about this one right here, let's just use 0. Again, that's probably the easiest number to work with. So let's plug in a 0 there and there. Here you would have 8, and here you would have -4. So this is positive and this is negative, and that's going to give me a negative, which is always less than 0. So this is true. And then thinking about in interval C, something that's greater than 4. So put a 5 there and then also there. 5 times 5 is 25, then plus 8. That's going to be 33. So this is positive. Here, 5 minus 4 is 1. So that's positive. Positive times positive is positive. And so a positive is never going to be less than 0. So this is false. So this is a non-strict inequality. So the critical values will be part of our solution set. So let's go ahead and say that we have x is greater than or equal to -8/5, and it's less than or equal to +4. In interval notation, again, you put brackets here. So you have -8/5 there, comma, and then you're going to have 4 there. And just use a bracket with each because they're both going to be included. And then coming to the number line, you have -8/5 here. You have 4 there. And again, I just want to use a bracket here and a bracket here to show that it's included. And I'm going to shade everything in between. So x can be -8/5, and then anything going up to and including +4. All right, let's take a look at problem number 10. So we have x squared minus 5x is greater than or equal to, we have 143 minus 3x. So let's add 3x to both sides of the inequality. Cancel this away. Let's subtract 143 away from each side of the inequality. Cancel this away. Let's put 0 over here. So you have x squared. Then you have negative 5x plus 3x, which is negative 2x. Then minus 143. And this is greater than or equal to 0. So let's just leave a space and say x squared minus 2x minus 143 is equal to 0. And I'm just going to factor this and say this is x here and x here for two integers that sum to negative 2 and give me a product of negative 143. When you think about 143, it's 13 times 11. So if you did a negative 13 and a positive 11, that would work, right? 11 minus 13 is negative 2, and 11 times negative 13 is negative 143. So let's write this up here. So x plus 11, this quantity times the quantity x minus 13, like this, and this is greater than or equal to 0. So using my zero product property, you have x plus 11 equals 0, or x minus 13 equals 0. Here we'll just say x is equal to negative 11. Again, just subtract 11 away from each side of the equation. Then or over here, we would add 13 to both sides of the equation, so x is equal to 13. All right, so here, let's put this as negative 11. Let's put this as positive 13. Let's get rid of this. Again, this will be region A. This will be region B. This will be region C. And essentially what I want to do here is just say that this is x is strictly less than negative 11. Here, x is greater than negative 11 and less than positive 13. And then here, x is greater than 13. Let me make this 3 a little bit better in each case. So a little bit cleaner. Okay, so let's pick something from region A. You can just pick something like maybe negative 12. So let's do negative 12 here and negative 12 here. Let me make this a little bit better. So negative 12 plus 11 is going to be negative 1. So I know this is negative. Negative 12 minus 13 is negative 25. So this is negative. Negative times negative is positive, and positive is always greater than 0. So this is true. Let's get rid of this, and let's go to the next region, which includes 0. So let's use that there and there. Here you would have 11, which is positive, times negative 13, which is negative. Positive times negative is negative, and a negative is never greater than 0. So this one is false. Let me use different colors for this so it shows up. And let me come over here and actually change this to orange as well. Get rid of this and this and this. And so something that's going to be greater than 13, let's just pick 14. And let's plug that in here, and let's plug that in here. So 14 plus 11 is going to be 25, so that's positive. 14 minus 13 is going to be 1, so that's positive. Positive times positive is going to give you positive, and that's always greater than 0. So let me do this in orange. This would be true. And remember, this is a non-strict inequality, so these critical values are going to be included. Let's write our solution as x is less than or equal to negative 11. Then or, we're going to have x is greater than or equal to positive 13. In interval notation, let's say from negative infinity, going up to and including negative 11. So make sure you use a bracket there. And then the union with, you'll have from 13, and again, including 13, so that's why we use a bracket, going out to positive infinity. Okay, so graphically, let's put negative 11 there and positive 13 there. And again, these are each included. So let me put a bracket here, shade everything to the left. Let me put a bracket here and shade everything to the right.